Sir, can we start?
Yeah, we can start, Soumya.
Yeah, okay. Yeah, hello everyone. Welcome back. So we start with the first talk of this conference. It's a keynote talk by Professor Rana. Yeah, I would request all the participants to please keep yourself muted during the talks. Yeah, okay. So Professor Rana has been a faculty at IIT Bombay, and he is the founder of Math for All, and of course the Time conferences. So I invite him to start his lecture.
Thank you, Soumya. I hope my screen is visible.
Yeah.
Okay. So once again, welcome to Time 2021. And I just want to kickstart with my presentation.
Sir, we cannot see you. Is it possible to
okay. Yeah.
switch on your video? Yeah. Okay. Yeah.
Fine. So let me start my presentation or my talk with a question, which is normally has become my way of interacting. What is the main reason for your participation? So at present, there are only 35 participants, but you will be surprised. There were 200 registrations for this conference. And even after registering, only 35 have come up to listen to the conference. So that's not bad. I normally expect about 10% those who register and then turn up. So this is out of 200, more than 10% have come. Okay. So let us, the idea is let us take a poll. Okay. So I'm going to share a poll with you. Oh, you're not, your polling session is inactive. Oh.
Yeah, I can launch it, sir.
Yeah, so go to the polls.
Yeah, let me launch it.
There is a time.
Yeah, time 2021, right?
Yeah, please launch that.
Yeah.
But I can't see the result probably, right?
ஒரு நிமிஷம்.
Yeah, it is being shown to the participants. I would
Yeah,
request them to please select your answers.
yeah. So participants, Soumya is showing you his screen where a poll is there, live poll. So please select one of the reasons for your answer for your participation. It's okay, Soumya?
Yeah, 26 of them has so far. Yeah, 28.
Yeah, I think we'll give 2 minutes more. It's anonymous anyway. No name is going to appear who has selected what. So feel free to choose whichever you like.
Okay, so we close in 10 seconds.
Yeah.
All right, so we have received 31 votes.
Okay.
Let me end the poll now.
Yeah.
So let me read out the results. So 87% of them has said that I wanted to listen to the experts talk. And 77% has said that I wanted to learn the use of softwares. And 13%, namely 4 of them, have said I just wanted a participation certificate. Yeah.
Yeah. Thank you, Soumya. It's great to know that very few have come only for certificate. Of course, participation certification is a thing you should have, but it's very encouraging to know that 87% are interested in listening to experts and almost same for learning softwares how to teach. So that is great. So why did I select this poll thing in the beginning? My main intention was not to know why you have joined this, but to show you that when you are doing it online, there is a possibility of interaction with your participants. So poll is one of the techniques by which you can interact. We'll have another opportunity to use the poll later. So let us go ahead a bit and come to the main thing that is. So I would like to emphasize connecting and interacting in an online math class. So let me again pose a question. You can put your answer in the chat. Connecting and interacting are two important pillars of math education. And if you look at the scenario at present, which was about 3 years back or 2 years back, when all the classes were actually face-to-face offline, this is how our teaching used to be. There was a teacher who is sort of transmitting knowledge. Okay, he is a knowledge hub transmitting knowledge, and different students, they have a different wavelength of reaching out to this signal. So according to the wavelength of the student, they accept whatever is being given to them. So there was hardly any connecting of the teacher with the students some time back, and that is probably still there. So that is one of the shortcomings of our teaching and learning, especially of mathematics, that as teachers we do not connect much with the students, and it's if you connect, you transmit better, your ideas are received better, you come to know the problems of the receiver, and you can accordingly change your frequencies to transmit. And well, because there was no connection, there was hardly any interaction also. Okay. So let us go a step further. I just wanted to say that connecting and interacting now has changed. So after the date, that is 24th of March 2020. So as all of you know, what is the significance of this date? I won't bother you to answer this question. The significance is, of course, on 4th March 2021, the first lockdown in India, and this changed almost every aspect of our lives. Everything changed, and more so education. So let me just go through a bit. It has changed how we work. So everybody started working from home. The idea was, don't get out of your home because of transmission. So this is what working from home meant, that along with other family members, you are sitting and working. Okay. So work from home and still be productive. That was a challenge. How we interact, there was a great emphasis, and for a very valid reason, we should have social distancing. Okay. So this is what social distancing, a humorous way of looking at it. In a two-wheeler, what does social distancing mean? But that was, there's only a cartoon on that to make things lighter, what social distancing mean. It is still valid. We still have to maintain social distancing. From a lifestyle change to better living habits, better eating habits. So there is a survey done that 55% of the shoppers eating at home more often because of pandemic. So their breakfast habits change, their lunch habits change, and their dinner habits change. For a healthy diet, people start eating a better, healthier diet. Okay, so that is how eating habits change. So that was our effect of lockdown. Our personal hygiene approach to personal hygiene changed. We started washing our hands quickly, and after every activity, frequently. We used to cover. We have been asked to cover, and we have learned how to cover our face, our nose when we're sneezing. Avoid touching your eyes and nose, and clean, disinfect. So these are various effects on hygiene. Okay. Along with that, what changed is how we teach and learn. Okay. So how we teach and learn, everything became online. So from home, you are teaching through an online mode. So internet technology was a big boon for that. Okay. So this is how the scenario for teaching from home looks like. Okay. But what was the effect of this? As a UN report, school closures have impacted around 247 million children enrolled in elementary and secondary education. This is only a survey of UN done sometime in end of 2020. Okay, it's about schools only. Okay, all colleges and higher education institutes are also closed, so that survey is not part of that survey. Another effect of this was that from the onset of the pandemic, teachers were straight away asked to implement distance learning modalities. There was no guidance given to them, right? There was no training and resources. There was no resources, and this occurred at almost every level of education. Okay, so this is not only in India, everywhere. Teachers across the globe were chiefly ill-equipped to hold continuity of learning and get used to new teaching methodologies. So teaching and learning greatly got affected, and there was no time to do any training or giving resources. So teachers learned by themselves and made their own way of doing online education. So rural and tribal areas they were most affected by the reason being the availability of digital devices that was not available um, to rural and tribal areas. Not every child has access to PC and laptops or smartphones. Even if a family has one smartphone, it is not for the purpose of learning alone. Almost everybody would like to use it for other purposes also. The second was the network issue, and third was the data issue. So mostly of course, our urban population was affected for teaching and learning, but rural and tribal areas were affected the most. Here is something which some of the teachers with the help of NGOs try to do. So let me show you a clip. It is very encouraging and very heartwarming.
आम्ही सकाळ झाली का शाळेची वाट पाहतो. 8 वाजेला स्पीकर येतो. ते स्पीकर खुर्चीवर ठेवतात. ते स्पीकर चालू करतात, बोलतात. त्याच्या मागे आम्ही पण बोलतो, गाणे सांगतो, गोष्टी सांगतो, कविता काय काय सांगतो, इंग्लिश शब्द सांगतो. ते स्पीकर आम्हाला खूप काही शिकवतो. स्पीकर दादा, स्पीकर ताई कोणी पण आहे तर जाम शिकवतो आम्हाला.
It's really good to see that the students, the small ones, the younger ones get their younger siblings also, and they come hurriedly, they get their notebooks, they get their textbooks, and they sit into the circles, that we have made, of course, for social distancing, but that's like an important gesture that they come and they sit into those circles. They will not sit anywhere else, even if there is space.
So this is the innovation of some of the NGOs. If internet is not available, then at least make audio pods available to tribal areas. It's a very encouraging thing they had done. So let me go ahead. I'm just trying to tell you what was the problems during pandemic, still some of the areas, and how people are tackling with that. So let me appreciate that by saying this slide that not all heroes wear caps, many of them are teachers. So teachers have done a great job by learning and continuing education in whatever way they can during pandemic. So other than the issue of internet, online teaching, if internet is available, is not available, or available depending on that, you can record and stream it. That is one way of, if the resources of teachers are not available, the videos can be recorded and played at some particular times, so that or can be uploaded on a server so that students can learn. Okay, this has advantage of its own in the sense that they can learn anytime they like, according to their convenience, students, but there is no interaction in that. So it's only communicating. Lectures online, where there is internet available both for the students and the teachers, and they are able to interact in whatever way they can and teach and learn. So that is the advantage of lecturing online. And the third is simulating the chalk and blackboard teaching online. This is one of the methods which is my favorite, that how can one simulate chalk and blackboard teaching online. Okay. The idea is that students get a feeling as if you are writing on the blackboard and teaching them. So they have time to listen and understand. Of course, they have extra advantage of not noting down everything, because after, if you can simulate and record, your lecture will be available offline later on also. So it gives more time. When you simulate chalk and blackboard on an online teaching mode, you get an extra advantage. The students get an extra advantage of understanding things, what you are teaching them. So this is, I call it as from chalk and blackboard is physical inking, and then going to the digital inking. So what does digital inking require? It requires a laptop or some device, and preferably a stylus with which you can write. Okay. So this is, I use what is called a tablet PC, but there are many options available. One can have attach on to a PC to write these things. If somebody wants to know, we can ask questions later on. Okay. And by now, I think most of the people have found out solutions for. But this is one of my best liked ways, digital inking. So that only in a classroom, it requires a LCD projector. In an online class, it requires only internet availability. So not only it removes many drawbacks of chalk and blackboard, there are many advantages. We don't realize that the classical chalk and blackboard method, especially in a math class, you have to clean the blackboard often, maybe after every 5 minutes. And it produces a lot of dust. Even though there are dustless chalks, there is a lot of dust. And the teacher inhales that dust because teacher is very close to the blackboard. So one study has been done about on the effect of this kind of teaching method on the breathing of teachers. I won't share that study here, but it says it should be avoided as much as possible, producing dust and inhaling, especially so when we are now going into a mode which is called a hybrid mode. So for example, one of the advantages of digital inking is that I can teach in a big classroom, like I used to do it in IIT Bombay. Much before the pandemic started, I started using this mode of teaching around 10 to 15 years back. And so in a classroom like this, there are 3 screens and you are sitting and doing your teaching. Instead of writing on a blackboard, you are writing on a tablet PC and everything is becoming visible. And whatever I do, for example, this is one of the slides I did on while teaching a calculus course. I could save that slide. So what I'm trying to show is that you can save your digital inputs and share with the students after the class. So all your recording is available, all your what you have written on the blackboard, what you have spoken, everything is available. And the advantage of digital inputs is that in the blackboard, you can rub once and then it is gone. You can't go back to a blackboard which has been rubbed off. But in a digital mode, you can go back to what you have written even 10 minutes back or 1 hour back. So there are some advantages. So it plays a positive role in enhancement of interaction between elements of an online learning environment by providing a real-time feedback. So that is the advantage of this digital teaching. During pandemic, okay, how does it, so we communicate via internet, connect via internet, and then how do we interact with students? It is normally called as the hot seat strategy between the teacher and student. say interaction between a student and teacher in a physical mode, offline mode, you call out the name of a student and you interact with the students. The same is possible in this online mode by calling out the student's name and give responses. So that everybody else also listens to the response. So this is called hot seat strategy for interacting in a. So I'll show you a clip of my interaction. So this is a calculus course I am teaching this semester. I don't know whether she is there or not, or she is not able to hear. So this is a calculus class where about 40 students are there. So you can see my tablet PC being screen shared, where I write everything on the screen. So as a result, whatever I write is like on a blackboard, but it is actually, I call it as a whiteboard writing. I have my board is white and I write with a pen. That colors of the pen also can be changed depending on what you want to highlight. Okay. And now all the names of the students are available to me on the side. Okay. So I can call any one of them to react and interact with me on particular thing. So this is the clip which is showing that interacting with students in an online class. Okay, Aditi, are you there?
Yes, sir.
Okay. So what can you say about this sequence SN? SN is a sequence of numbers, right?
Yes, sir.
So what can you say about the nature of this sequence?
So it is not geometrical series.
No, SN is a sequence. It is not a series.
It is not a geometrical.
We are not looking at the geometric nature of this SN. SN is a number which depends on n. So how are you getting SN? You are getting SN by adding something to the previous one. You are adding 1 over n.
Yes, sir.
So can you say whether SN is increasing or decreasing?
It is increasing.
Good, very good, because you are adding non-negative numbers. Aishwarya, can you guess what is the limit of this? If it is bigger than this, then what is the limit?
N.
No, limit as n goes to infinity. So it can't depend on n. What is happening to limit of this quantity? As n goes to infinity, what is this?
It's increasing.
It is increasing and it is not bounded above, right?
Yes.
You can make it as large as you want. So this tells us that limit of this is equal to plus infinity. So I just wanted to give you a feel for what hot seat interaction on an online class can mean. Okay, but that greatly depends upon the teacher and the student and what kind of connection you have between the two. Let me go over to saying something. So this is the online class. The difficulties in this mode, which anyway are there in any interaction which is internet based and technology based, that slow internet, audio devices not responding and so on. The internet is slow, probably sometimes the audio device of the student is not working or the teacher is not working. So interaction between the teacher and student is affected by this. Second thing is the most of the interaction is oral responses, right? So the teacher either has to interpret the response given by the student into a written response so that all other students can look at it, okay? Or just leave it that as an oral response, whatever you can make of it. So, or what you can do is, if the student also is using screen sharing and pen-based technology, then this is interaction is the best. So this is the best way of teaching and interacting. If you are doing it with a stylus and a input device, a tablet or a tablet PC, and your students also are able to respond back by writing something and sharing their screen. So that is, so these are some of the drawbacks of this method, but this is the best possible, I think, at the present stage. Right. So let us, what other ways of interactivity you can bring into the class? One is calling the student and saying, hey, what do you think of this particular point? Can you give me your reaction? Or can you say something, right? You can have a surprise quiz in between your lectures and ask students to work out so that they are engaged, okay? There is an interaction. You can also give students an opportunity to create something and be owner of that, whatever they have created in an online thing, okay? So for example, the student can be asked to create a mathematical concept through a video, animation, diagram, concept map, and ask more interesting questions, okay? So these are possible ways, but all require slightly better technological inputs, which are not required in an offline class. Okay, so what I'm saying is are valid for both offline and online teaching, but this is possible in online. So here is a question I would like to pose. So I said surprise quiz. So here is a surprise quiz. Suppose you are in your office, on a room, or somewhere in a school. You have finished work and it is raining. You don't have an umbrella with which you can now, so that you can go out to the bus stop to catch a bus, right? And you want to avoid getting really wet. Okay? So you don't have an umbrella, it is raining, and you have to walk, you have to go to the bus stop. So the question is, should you run or you should walk? Will you run when it is raining or will you walk? Soumya, can you put the second?
Yeah.
So Soumya is going to show you a poll. So there are three options. I think only two options. Probably.
Two options are there. Yeah.
Yeah. You can read out, Soumya.
So to run or walk. So one option is I will run. The other one is I will walk. Please choose the option that you feel.
And I think everybody should vote because you should have a chance to interact. Okay. Even I would request resource persons, if you are present, some of you, please vote so that we can have a real interaction. Yeah. It's nice to see reactions coming in the chat box, but enter your poll also. Make your selection in the poll.
Yeah, we have received 75% of them has voted. So 78% now.
Okay.
we can close, right?
Yeah, if no one else is, then you can close and tell me the results.
Yeah, so 41% of them has said I'll run.
Okay.
And 59% says I'll walk.
Good. And some of you have put your reasons in the chat box. Somebody Nayak says, I will run if it rains slowly. Choice will depend on whether, okay. Barry says, if the bus is slow, have to wait in the rain anyway. Good one. Arvind Kumar says he will run, and similarly other choices. But let me, if the poll is already closed, so let me just make a remark. Oh, my screen is not visible. Oh no, I think there is this. Okay. Your instinct says, normally that is what I also do, what everybody does, is your instinct tells you that you should run. Running is the best choice. Okay. Your instinct says that running is the best choice. Okay. But is it so? The question is, do you think that is the right choice? Okay. I won't give you the answer, but there is a lot of mathematics involved in analysis of this. People have analyzed this problem mathematically, and I think I will leave it for you to go to internet, take the help of Google Chacha, and try to find out how people have analyzed this problem mathematically. Okay, that is it good to run or to walk? Okay, they have made this is a problem on math modeling now. So you model raindrops as something falling down. Okay, and how see the amount of whether you will get wet or not, how much wet you will get is how many drops will be falling on your head essentially. So there is a way of calculating and estimating this mathematically. So go to the internet and try to do. So this is one way. So I have given you two inputs. One is to start such kind of a thing with a poll. And then from the poll, whatever results comes, you can try to go over to the mathematics of it in a classroom if you want to do this in a classroom. Okay. So this is one way of bringing interactivity in a classroom. Okay. So let me go over to another one probably, which all of you can. So here is the problem. The problem is a uniformly expendable robotic arm is fixed to a stationary control box mounted on a factory floor. So this is a problem which I had done it with the professional development course workshop done at a school. So here is the problem. So the scenario is there is a robotic arm whose base is fixed, okay, on the floor, and the arm is like the other end of the arm is attached to a machine moving on a straight assembly line. Okay, so the other arm of the one end is fixed, other arm is able to move along a straight line, and at the a hook is placed at the middle of it. Okay, so idea is, first of all, you should be able to visualize this, draw it on a paper, and try to analyze. So here is the problem slightly better explained with the help of a picture. Normally, when I did it, I did not give any input more than this, and the participants had to draw a picture and visualize. So here is the picture of it. So here is a robotic arm. This is a robotic arm. Okay. The one side of the arm is like the shoulder. Shoulder is fixed. Okay. The arm is able to move. Okay. Here is the hinge, or here is the hinge, which is the middle point of this arm. Okay. And this point is able to move straight up and down. Okay. So this point is able to move up and down. This is fixed. This is extendable arm, that is a hinge. Okay, so the question is, what can you say about the path of the hook will follow as the machine moves along the assembly line? We want to find out the locus of this middle point. Okay, so I think it's interesting to see how do you interact. So probably the participants can take 2-3 minutes to draw a picture if they like, and try to make a guess what could be the path of this. Okay, so I would like you to put your answers in the chat box. What kind of a curve is the path? Okay, so here is in the chat box. Chat box is alive. Please, this is one way of interacting. If you can't do anything else, at least the chat box is there to interact with the participants. So I am trying to interact with you through the chat box. I have put a question. The question is, there is a robotic arm. This end is fixed. This end is able to move up and down. Okay, and there is a middle of the arm. We want to know whether when this moves up and down, what happens to this middle point. There is a hook. Now there is a hinge here. So what path the middle point will follow? So that is the question. So please put your possible guesses in the chat box. I assure you, I will not name out the person who is putting the guess, so that it will be anonymous response, and so that we can interact. So please think about it for 2 minutes, 3 minutes. And
So can I ask one question?
yes, please. Anybody has a question to ask, clarification, please ask. Yes, Soumya.
So which part of this is extendable?
See, this arm, at present, it is shown as a bent arm kind of a thing. Think of it like an arm, your arm. This is fixed. So this is the shoulder point of the arm, which is fixed, which cannot move.
Right.
And this is the hand, which can move.
So extendable means the length is extendable or
No. It
movable?
Movable. Extendable.
Okay.
Extendable means it can become straight.
Achha, okay. Yeah.
Okay. But this point can move only up and down. The bottle can be taken up or can be taken down. The length of the arm is fixed.
Yeah. Okay.
Length of the arm is fixed, but it is extendable in the sense that it can become straight. It can become upside down if you like. Okay. And there is a hinge. This is the hinge around which it can move. It's like your arm, which can go up and down and so on. So, yes, this bottle moves only vertically. So this end of the robot moves only vertically. I'm making a pointer that this is moving only vertically up and down. Okay. So moves up and down. It is not going horizontally. So we are analyzing only when it moves up and down. That means it remains in that plane. Okay. And it moves up and down. To model it, you can think it that way. So already one response is there. I will not read out the response, because when I say the answer given by a person which may be right or wrong, others will stop thinking. But the answer may be wrong, may be right. Okay. So I would like you to give your response. Okay. Then I will compare the responses given by you. The person who has given the response wants to change, you can change. It is not an exam. You can think and give a response. What could be the path of that midpoint? That is in the mid. So this portion of the arm is equal to this portion of the arm. That is also given to you. So the person has revised. There are two responses now. Okay. Another response, is the hinge at the midpoint? Yes, the hinge is given to be at the midpoint. Okay. So the hinge also can move up and down only. And both parts are extendable in the sense that this hinge, okay, the arm can become straight. That is the way of extendable means. So another choice has come, parabolic. Oh, sorry. I said I will not repeat. So there are 3 different answers available at present in the chat box. Four, 5, 6, 7, 8. Good. I think Soumya, we have got enough responses, so I will go ahead.
Yeah, okay.
So one choice is it is a part of a circle, and some other answers are similar, that it is a part of an arc. And then there is somebody, the 2 or 3 people said it is a parabolic, and then I think 2 of them said it is a straight line. Okay, so let us. There are ways of interacting. If I want in a classroom to interact more, I can ask them to model this in Geogebra. Okay, which is a software. So I'm opening Geogebra to model this problem. Okay, this is part of interactivity. So here is the modeling of, okay, here is the fixed point. Here is the fixed point of the, and here is the midpoint, and here is the movable point. The movable point is on the assembly line, so it can go only straight up and down. This is a midpoint. So as this point goes up, okay, so keep in mind extendable, the whole length, okay, can extend, because if it is fixed, then you can't do anything. So this arm has expandable arm, okay, so it can, the length of the arm can become shorter or bigger depending on where you want to reach. Okay, so this is a midpoint, and we wanted the midpoint, the say locus of the midpoint. Okay, so let me, Geogebra is a dynamic geometry software, so let me move this. So this is the robotic arm moving up and down. Okay, I want to see what is the path of the expandable arm. So this is a stage 1. By just moving up and down, I will ask the students to guess what is the path. So I will hide the axis also, so that less visibility is there. So this movable point, okay, what should be the path? Okay, so now you can see that it cannot be a circle, it cannot be a part of a circle, it cannot be a parabola. It looks more like a straight line. Okay, so to really see it, I will put what is called a trace on in this Geogebra thing, and now I will move this up and down. So when I move it, now I'll be tracing the path. So this is the path taken by the midpoint. This is the path taken by the midpoint. So the path is a straight line, and that was one of the answers given by some of you. So that is a way of bringing interactivity in the classroom. Okay, but only thing is you should have all this set up with the students, that they can also access Geogebra. It is possible. I will come to that soon. Okay, how is that possible to bring in students here? Now here is you can extend this exercise a bit more. Instead of midpoint, if it is some other point, what will happen? Instead of midpoint, if it is some other point, okay, so can I change the midpoint? No, I cannot change the midpoint here. So let us take a point. I want to explore if I take another point. So let me take a point here somewhere, E, which is not the midpoint. Okay. And I want to again find out what is the slope of, what is the path of this. So let me move again this point and see where it is going. So you see now I can trace. It is still a straight line. Okay. So it has actually, this is a project which workshop that we did with the student, with teachers of school. So I want to show you that video, how I brought students into the classroom and I could monitor their progress. So here is the. Let me make it slightly bigger so that you can see it better. So this is a professional development for math teachers at a school, Sanskriti school in Delhi. I think these are three important components. There are many more actually, but all others follow from these three. Once we start in an inquiry, there is a talk in the classroom, there is a talk in the group. What the picture will look like, right? So this is the fixed control box, okay, which is fixed on the ground, and this is a robotic arm. Okay, this is the right decrease because that as you move that movable point, the path traced. So you can see now I have these students, these teachers as my students in this class, and I'm going to interact with them. Okay. By the midpoint will be a line parallel to the. So how do I interact? Good guess, right? I'm looking so that check and then can use as you'll get another depends up who has asked. Good. So done. So only I will be able to. So here is the way of bringing students into the classroom. Uh, uh, I have a Geogebra account, so I can create a class. I can create a classroom on Geogebra site, and once I create a class, I'll get a code, and this code I will share it with my students, and they open that Geogebra site and go to the classroom and enter this. Once they enter this code, they will come to my classroom to see now probably what you all are doing. So they come to my classroom and they start doing the test. So I see these are the students on the left side. Okay, and I can see you are given a segment of a given length. So here are students, Lalita, Sakshi, and Anjali, and so on, and they are working on that assignment using Geogebra and trying to make a guess. Okay, and I can see what they are doing. So this is I want you to construct a square with that as the diagonal. Oh, probably it is some other.
Okay, with that length as a segment length to be the fixed, length to be the diagonal.
Yes, that segment to be the diagonal of that square. So construct. So here the problem is not of the robotic arm. It is some other problem given. But I want to show you that I can listen to the students asking questions. I can monitor their progress as they are working. So they were asked to construct a square with a given diagonal. Okay. A square with that given segment as the diagonal, as one of the diagonals. So you see, I can see their progress, how they are trying to construct. I can monitor progress of each one of them, and I can interact with them. So that is advantage of the software. I can have live interaction and observation of my students working on a task. Okay. So let me stop this video here. And so what I have tried to show you is that in online class also, it's possible to have an interactivity with a classroom with the students by going to creating GeoGebra classroom and bringing your students in, and then you can view their how they are working on the problem, and you can interact with each one of them individually and collectively also. So that is interaction, online interaction possible using GeoGebra classroom. So basically idea is assign interactive engaging tasks, view and update progress of students. That is all possible. You can hide students' names if you want to make them anonymous. You can hide their names so that nobody knows who is doing what. Okay, so you can have interaction with the students. So, I just want to end my talk by saying other possible software tools which can help you to. Some of them are being discussed in our workshops, some are not. So there is something called a Nearpod, which is a paid thing, but there is a free thing for teachers, limited one. There is something called Graspable Math, which is online only. It is not offline, but can be integrated with GeoGebra. It has a GeoGebra integration with it. So that is a possibility for interactions. There is something called Azure Puzzle, where you can have a video and start your own video, or you can download a video from a YouTube and have interaction on that. Okay. Then there is something called Class Dojo, which is mainly for the primary level. Okay. So level K to 5 essentially. And this is free for teachers. Okay, that is advantage. And there is a Classcraft. There is a popular game called Minecraft, and they have brought an educational version of it called Classcraft. There is Mathigon, on which we are having a talk as well as a workshop, and we're trying to have a workshop on math whiteboard. We'll see if it becomes possible or not. So these are some of the things, softwares, technological inputs, which can help you to bring interactivity in a classroom. And what is upshot? Some people believe that the unplanned and rapid move of online teaching with no training, insufficient bandwidth, and little preparation, what can happen? We have seen that it will result in a poor user experience that is unconducive of sustained growth. Here are beliefs, and there is a contrary belief that, which is more positive, believe that a new hybrid model of education will emerge with significant benefits, and that will continue. So with that positive attitude, let me stop my presentation. And in case you have any questions to ask, please feel free. I will stop sharing my screen. Yes. So you can put your questions in the chat box, and Soumya will be of help to.
Yeah.
Or I think there are not many people. If you want to unmute your mic and ask a question,
Sure.
that is also welcome. Any questions, please? Are there any teachers in the participants? I think mostly are teachers probably. So let me pick up Anirudh Deshmukh. He doesn't show.
Yes, sir.
Yeah. So are you teaching somewhere?
Oh, no. Right now I am doing my PhD.
Oh, okay, fine. Good. Have you tried your hand at online teaching?
Yes, some time ago, yes. Using that Wacom tablet I have.
Okay, good. Yes. Yeah. So what was your experience of were you able to interact with students in online class?
Initially, no, but later on, I did get a hang of it.
Okay.
But yeah, I do think that other softwares I have to learn for that.
Okay.
So actually, that was one of the reasons I joined this conference.
Oh, good. So at least some inputs you have gotten from that. Yeah.
There are some questions in the chat.
Yeah, very. Let me just say that most of the internet is now available at most of the places in India. I can't vouch for the strength of the internet, but it is available, and the penetration of mobile phone is quite significant. Probably sometime I will show. I think at the time of in 2013, I had shown how technology has, mobile phone has penetrated all segments of life, caste, religion, everything. So students have access to internet mostly. Maybe remote tribal areas there is a problem possibly, but I don't have any data to answer your question. Okay.
Okay, thank you for that. I was kind of wondering about students having not so much mobile phones, but computers of some kind, which are commonly used in Australia for remote teaching. Are there many Indian children for whom that's not the case?
Using what, tablets or something?
Yeah, tablets or PCs or
no,
computers.
I think the availability of hardwares like tablets or PCs or these things is not that common. Even some of the urban areas, it's not that every household has a laptop, but almost every household in urban parts have got at least one to more mobile phones, which are smartphones. And so, no, I don't think other things are possible.
Okay, thank you.
Yeah, mostly students, even students attend online classes on mobile phones. Because I was trying to do some Geogebra activity with some of the students, and the desktop version of Geogebra and the mobile versions are different. So they were having problems in understanding that. So that is a problem, surely.
Okay, thank you.
Yeah, so somebody has asked, are there other softwares like, Soumya, can you read that question?
Yeah, probably you can show that last slide where you
where you can share the list of other softwares. I think now it is recorded. You can later on also have a look at those list of softwares, and as you progress, probably more will come across. Okay.
Yeah.
Recording will be available, so you can always go back and look at. I have mainly used GeoGebra and GeoGebra Classroom. There is a desktop, there is a Desmos, which you will be learning, and there is, so each software has got its plus points and minus points. So, right. Any other question anybody would like to ask?
Yeah, I guess there is no more question.
Chitra, you want to ask something? You had put your name. I thought.
Hello, sir. Good morning, sir.
Good morning. So please ask if you have a question.
We're really happy to attend this workshop.
That's fine. Please go ahead if you have any particular question regarding this talk.
Sir, do you have any online sessions for these software tools?
Yeah, we are having that in the workshops, no? 2 workshops, for 6 workshops as the schedule for the conference. You'll see workshops. There are all online workshops being done during the conference. So join some of them.
Okay, sir. Thank you, sir.
Yeah.
There is another person, Ms. Sneha Sharma. You want to say something?
Yes, sir. Good morning, everyone.
Yep.
Sir, I am a teacher, and I'm PGT Mathematics at Reliant Foundation School, Kopperkerni, and we have been using GeoGebra as well as Desmos. And just to share that these 2 tools I feel very useful in my daily teaching, especially because in senior secondary we have to teach graphs to the students, and especially comparing graphs and talking about few properties of graphs. That becomes very easy using these tools. So online, in a way, certain things have become easier for us using these technology and all. And I'm really looking forward for the advanced level sessions that we have tomorrow.
Okay, good.
So thank you.
Yeah.
Yeah. Yeah. Thank you, sir, for
Yeah.
the nice presentation. So maybe we'll meet at 11:10 for
Yes.
the next talk.
The next talk. Thank you.
Yeah.
Thank you all for coming. Take care. You can stay logged in if you like, or back log in again if you like for the next session.
Yeah, it's only 7 minutes.
And say enjoy the conference. Bye.
Chonaki ma'am, could you please share your screen? Maybe let's.
Yes, I'll just.
Yeah.
Is it visible?
Yeah. Yeah. Chonaki ma'am, could you please? Yeah, probably we can start. Yeah. Welcome everyone. So our next talk is by Dr. Chonaki B. Ghosh. She is a faculty at the Lady Sri Ram College, New Delhi. And she will be speaking on developing mathematical thinking using spreadsheets. Yeah, over to you, ma'am. You may start.
Thank you. Is the screen visible?
No, you have to reshare.
Oh, I have to reshare. Okay, sorry. Is it okay now?
Yeah. You want to make it a full screen or?
Yes, yes, yes.
Yeah, okay, please.
Okay, thank you very much, Professor Rana and Shomyo and the entire team. It's always a pleasure to participate in time, and it has been a wonderful journey since 2005, since the conference started. So the topic today is mathematical explorations using spreadsheets. So I would like to share about students' involvement in certain projects that they explored, in which spreadsheets played a kind of quite a significant role in enabling their developing their mathematical thinking and understanding. So before doing that, I would like to reflect a bit on what are the goals of mathematics education. And I think that as educators, we must always keep revisiting this question. So of course, the NCF 2005, I mean, the position paper on the teaching of mathematics makes a very poignant statement that basically the goal of mathematics education is mathematization of the child's thought processes. And another very good, very nice definition, which I really like about mathematizing, is by Hans Freudenthal, who says that mathematics is, after all, a human activity. The pupil himself should reinvent mathematics, and during this process, the learner is engaged in an activity where experience is described, organized, and interpreted by mathematical means. So I think this word reinvent is very important, because do we give our students any opportunity to discover things for themselves? So now for mathematization, the position paper from content to processes. So the content of school mathematics is all very good, but we need to focus more on the processes of use of patterns, estimation, approximation, visualization, reasoning, and proof, and formal problem solving. And another very nice article by David Wheeler, it's titled Mathematization Matters. He says that mathematization puts ideas into relation and coordinates them. In particular, it seeks to establish the dependence of ideas on each other. But in a nutshell, I think we need to get students to actively engage, solve problems, engage with tasks, justify their reasoning and solutions, and basically elicit mathematical thinking. And if we really see what is mathematical thinking, it is probably developing what is known in the literature as mathematical habits of mind. That is creating visualizations, making strategic guesses, engaging in systematic experimentation, looking for patterns, identifying invariances, making logical connections, and engaging in multiple paths of inquiry. So hopefully in some of the examples that I would be able to, if I am able to share quite a few of them, I hope I'll be able to show you that students engage in some of these mathematical habits of mind. So spreadsheets, of course, there are many tools, very good tools available of various kinds. There's dynamic software, or whether it's computerized systems or even handheld tools. And in all of this range, sometimes spreadsheets are overlooked and sometimes even underutilized. But they can be powerful and they can help in identifying patterns, generating graphical representations, and creating simulations. And they're indeed very suited for the inquiry-based approach to learning. And of course, they can be incorporated like any other tool in online classes. And very often, some of my students who access, let's say, Excel on their smartphones, they're able to do the activities quite well with that. Of course, spreadsheets also do not need a high level of coding, so it's not very intensive in terms of programming either. So with all these spreadsheets be used to quite an extent to enable children to do explorations. Just I wanted to ask, am I clearly audible?
Yeah.
Okay, yeah, thank you. So the first set of first task that I would like to describe, and is always my favorite, is the topic of fractals. And children of all age groups, starting from middle school to senior secondary, I find that they really enjoy this topic, exploring different kinds of geometric fractals. And in the process of doing so, they really, they really explore mathematical ideas. And I would like to share some of that. Of course, the very reason that fractals are important is they are all around us in nature, and they exhibit self-similarity. So whether it's a leaf of this kind, which has a central branch, and along the branch, there are smaller leaves. And within that, those branches, there are yet smaller leaves. So if you magnify a small portion of the leaf, it somewhat resembles the whole leaf. So this whole idea of, self-similarity. And whether it's in the branching of trees, or if you look at a cauliflower, that if you take a small portion of the cauliflower and magnify it, it is in a way resembles the whole cauliflower. And if you take a cross section of the cauliflower, there's a very beautiful branch system in which has fractal patterns in it. So fractals exhibit similar patterns in progressively smaller scales. But of course, when children have to explore fractals, it might be a good idea to give them some of the geometric fractals. Some of the very popular ones are the Sierpinski triangle, Sierpinski carpet, and there are many others. And I usually begin with the Sierpinski triangle because it's easy to understand. That has been my usual formula. But today I want to break away a little from that. And I want to share how students of grade 10 explored what is the Koch snowflake. So this is the Koch. So first I'll begin with the Koch curve. So what we do in the Koch curve is you take a line segment, and you divide it into 3 equal parts, and you remove the middle third. So if there are 3 equal parts, you remove the middle third, and on that middle portion, you raise an equilateral triangle of the 1/3 the length of the original length of the segment. So for example, so I divide this into 3 equal parts, I remove the middle third and raise an equilateral triangle here. And this process, now there are 4 smaller line segments. So if original line segment is 1 unit, then each of these line segments will be 1/3. So there are 4 line segments, and on each of these in the next stage, the same thing will be repeated. So each of these will be divided into 3 equal parts, and you remove the middle part and you raise a smaller equilateral triangle. So it will look like this, and you keep on doing the same. It's a recursive process. And by the time you reach stage 4, you see that it's fairly intricate and very, very beautiful. So what kind of mathematics can really be culled out for children in different stages? So of course they get familiarized with the process of recursion, and it's also difficult to draw such things by hand. Though it's a very good idea to get an isometric dotted sheet and getting children to do these drawings by hand. And I feel that it is not just the use of technology, but by hand and hands-on things are very, very important, and there should be a balance between the two. Of course, if you want to get a very accurate drawing, there are many softwares probably which can do that, but the simple mathematical code written here on Wolfram Cloud will generate these stages of the Koch curve. So now, if you do this on an equilateral triangle, so suppose I take an equilateral triangle and I divide, so let me just try to. So suppose I trisect the sides of the triangle and I remove those middle thirds just as it was in the Koch curve, and I raise an equilateral triangle of this length on each of the 3 sides. So what I will get is this. So this is stage 0, this is stage 1. And now there are 12 line segments, and I repeat the same process of trisecting, and I will get this, which is stage 2, and then this is stage 3. And again, we see by the time it reaches stage 3, it becomes very intricate and beautiful. So what kind of questions can students, what kind of things can students explore? One, of course, how many line segments will be there at each stage? That itself is a problem of interest with students. Immediately, the first thing they want to do is count the number of line segments. And then you can ask that, can you find a rule for the length of a line segment at any given stage? So if the original length is 1 unit, what happens to the lengths at each stage? The number of line segments at the nth stage. So how many line segments are there at any given stage? What is the perimeter or total length of the Koch snowflake at any stage? And what is the total area at any given stage? And further, what happens as n? N is the number of stages. So if n grows indefinitely, then what happens to all these attributes of the snowflake in terms of number of segments, perimeter, area, and so on? So, of course, the first thing that children, it's helpful is to draw up a table where they write the attributes. And so that, for example, number of line segments in the first stage 0, this is actually, so any starting stage of a fractal is usually termed as stage 0, the do nothing stage, and thereafter the recursive process starts. So here there are 3 line segments. So, and at stage 1, there are 4, each of these line segments is divided into 4 smaller line segments. So there are 3 into 4, that is 12 line segments. At stage 2, each of these 12 line segments will further lead to 4 line segments, and therefore it is 3 into 4 square, which is 48, and so on. And at the nth stage, there is 3 into 4 raised to the n. So students quickly see that the exponent is matching with the stage number, and they're able to generalize. So a table is given where students were asked to fill in the numbers. So initially they put numbers 3, 12, 48, and so on. And then they were scaffolded to write it in terms of 3 and 4 to be able to see the pattern and then coming up with the general term. Again, if you take the length, if this is 1 unit, then this is 1/3, this will be 1/9, and so on. So there are powers of 1/3. So at any stage, at the nth stage, it will be 1/3 raised to the n. If you look at the perimeter, then it basically comes out to be 3 times 4/3 raised to the n. The total area enclosed by the snowflake at any stage will require a little bit of work, so that I will like to show a little later. But the important thing is that students not only were able to write the general term of these sequences, geometric sequences, but they also came up with recursive rules. So at any given stage, the number of line segments is 4 times the number of line segments of the previous stage. So this was written as Sn is equal to 4 times Sn minus 1, and similarly for other attributes. So getting a tabular representation of this growth process is something which is important, and it helps to at least students would be engaging in the process of generalization. Now after this, the total area. Now the total area is something, so these were grade 10 students, so some of them were familiar with the concept, but some of them had already, these children do go to coaching classes and they cover a lot of the syllabus of higher classes in their earlier classes. But these children had a basic understanding of geometric sequences and the theory of geometric sequences. Now when it came to area, so let's say that the line segment is one unit. So the area of this equilateral triangle will be √3/4 into 1 square, which is √3/4. And at the next stage, what has happened is 3 additional smaller equilateral triangles have got added. So the total area at this stage is going to be √3/4 plus, there are 3 smaller triangles, so it will be 3 times of √3/4. And each of these line segments is 1/3. So the side length of the equilateral triangle is 1/3. So √3/4 into 1/3 square. So this will be the total. This expression gives the total area at stage 1. So this is stage 0 and this is stage 1. Now coming to stage 2, what happens? So more area is going to get added. So on each of these line segments, there would be a tiny equilateral triangle sitting like here. And how many would there be? There are 12 line segments. So on each of these line segments, there's a tiny equilateral triangle sitting. So there would be 3 into 4, 12 equilateral triangles. And what would be the area of each of these? They would be √3/4 into each of these line segments is 1/9. So it will be 1/9 square, but it can also be written as 1/3⁴. So this total expression gives the area at stage 2. If I were to write another term, so students had great fun in doing this because once they see a pattern, they're able to see it in terms of 3 and 4, and they, without having the diagram, they're able to write the next term as, because the number of equilateral triangles will now be 3. In the next stage, it will be 3 into 4 square, and the area of each of these will be √3/4 into the next line segment will be 1/27, 1/3 of the previous one. So which will now lead to 1 in powers of 3, it can be written as 3 to the 6. And this process will go on till infinity. If you keep on adding and if you keep on going higher and higher stages. So if one does a little bit of calculation, so if I keep this √3/4 term aside, and maybe if I just also keep this term outside, I can see that so this will be giving me 1, and here I will get 4/3 square. And from the next term, I will get 4 square upon 3⁴. So I get a geometric sequence. And they do study, children study that such sequences where the common ratio is less than 1, you can take the sum to infinity using the formula A/1 minus R, where R is the ratio and A is the first term. So anyways, if you do the simplification, you see that, so first time when you ask the children what happens as the stages goes on increasing, they say that, oh, the area also will keep on increasing. And so we said that, okay, why don't you work it out on a spreadsheet? Does the total area go on increasing as the stages go on increasing? And incidentally, I'll show you the spreadsheet a little later, but the spreadsheet tells us that the area does not go on increasing as the stages go on increasing. So in fact, the area approaches a fixed value, and that fixed value happens to be 2√3/5, which is approximately 0.69 up to 2 decimal places. So this came as a bit of a shock to students. So this is a spreadsheet, and this is just a snapshot of a spreadsheet. So as we can see that whether it's the number of line segments is growing very fast. The length of the line segment is getting smaller and smaller. The perimeter is also increasing. And look at the total area, that it does become steady. If you round it off to 2 or 3 decimal places, it does become steady somewhere around here, 0.69. So what is the reason for that? Because it kind of was a break in their thinking, and they said, but it's not possible. How is it possible? It's an infinite process and everything is increasing. And the graphs show that the number of line segments is growing, the perimeter is also growing, and the total area is becoming steady at 0.69. So then they were asked to look at what is called the additional area. So one student said that probably what is happening, and they kind of over time they were able to think about this, that every time we are adding smaller and smaller equilateral triangles to each stage. But as you keep doing it, the total area that is being added at every successive stage is getting smaller and smaller. That was a very important leap in their thinking. And then when it was graphed, we saw that the additional area being added is actually approaching 0, and therefore the total area is approaching a fixed value. So this problem was explored numerically, graphically, symbolically, and there's a lot of mathematics taking place, and these were grade 10 children. So that was something very good that was happening. Some children, how did the children extend this? So some children who really like to draw by hand, they actually did. This is a snapshot of students' work. As you can see, this child uses a isometric dotted paper and does a very intricate drawing of the caught snowflake up to stage 4, which is very hard to do using a very fine tip pen. But it was really appreciable how she did it. And well, as it gets more and more intricate, so if you can, I don't have a poll, I would have liked to see this, but well, if you really, it's difficult to decipher it, but this is stage 6 of the caught snowflake. Now, another thing with older children, for example, with grade 11, it was possible to introduce the notion of what is called the iterated function systems, that is interpreting the growth process in the form of matrix transformation, because matrices is something they study. Now what happens is, let's say this is the initial state. Let's come back to the Koch curve. This is the initial stage of the Koch curve, which is stage 0, which is just a line segment. Now what we need to do to get this, so let me just use the pen. Suppose this is your unit length, this Koch curve. So this is 0 to 1. Now what happens? This is stage 0. Now what happens at stage 1? We get this. So first thing I need to do is I need to shrink this line segment to this. So let's say this is 0, this is 1/3, this is 1/3. If I mark it on the unit line, this is a 2/3 point, and this is 1. So I need to shrink this 0, 1 line segment to this part. And to do this, we need a function, a matrix transformation of this kind, where x will be the coordinates of the point here. And so this matrix transformation F1 will be able to shrink this line segment to this smaller line segment. Let's mark it as F1. Now, for this line, I need to shrink this to 1/3 its length, but also shift it to this point and rotate it by 60 degrees. So to do this, I need to use this kind of a matrix transformation. This is cos of the angle, sine of the angle, minus sine. So cos theta, sine theta, minus sine theta, and cos theta. So they know about this particular matrix, but they've never seen it in action actually. So this was very exciting to students when they saw that this is possible. So F2 will convert this line to this. Similarly, F3, now we need to convert it, shrink this to 1/3 its length and bring it to this position. So F3 would be this one. And finally, we want to shrink this line to 1/3 and push it to this position, which can be done using F4. So this set of 4 functions can be repeatedly done on, now this was stage 0, now this was stage 1. So if I repeat these 4, if I make if I take this to be a single unit and make it undergo these 4 functions, I will get the next stage, and it goes on like that. So we can interpret fractal constructions in the form of an iterated function system. And technically this seems to be complex, but students were able to understand the basics, and figuring out what matrix transformations would lead to the change of these shapes into the next state was something that took time. But once they figured it out, it was really, once again, a very satisfying thing to see that children can, if given the right kind of problem and if given the right kind of scaffolding, children are really able to do these marvelous things. Okay, so, and it didn't end there. So once they get interested in fractals, they want to search the internet and find out all kinds of things. And I have encouraged them to generate their own fractal designs and patterns. So in other talks, I have mentioned about this because I find this so wonderful to see that children are actually creating their own fractal designs. But the Koch anti-snowflake is equally interesting. And there's a beautiful relationship with the Koch snowflake. And that is, if you start with an equilateral triangle, here we do just the opposite of the snowflake. So we trisect the 3 sides. And instead of adding equilateral triangles, at the next stage, I will be cutting off these portions, these equilateral triangles. And so these will go off in the next stage, and therefore we'll be left with this. And then you repeat it on each of these pieces. And again, it becomes very intricate, let's say by stage 3. The students explored the Koch anti-snowflake. The drawing became challenging after stage 3. But they explored here also, they explored number of line segments, perimeter and area. And there was a natural curiosity to see the relationship between this and the Koch snowflake. So, so I'm not getting into the calculation of the area. There's no time for that. But let us see what kind of mathematical thinking emerged in engaging with such a problem. First of all, children engaged with recursion. They found recursive formulae. They expressed attributes of the nth stage of the fractal process with the n-1th stage. They identified copies of lower stages and higher stages, and they also built higher stages using lower stages. So both processes were being done. They engaged with generalization, that they looked at geometric sequences emerging from the various attributes of the fractal and explored it using the rule of 3, that is numerically, graphically, and symbolically. They simulated, they worked out the sequences on a spreadsheet to see the patterns and extensions, as you saw, that, first of all, using this, it was possible to make connections across topics, at least matrices were, because matrices are again taught in a way, not much of applications are done at the school stage. So at least they could see some real important application of matrices. They explored ideas which are well beyond the school curriculum. They're exploring ideas of self-similarity and fractal dimension. I don't have time to get into that, but I have spoken about this also, how one can compute the dimensions of these fractals which are not integers. And of course, creating new fractals is very satisfying exploration. So fractals is certainly a topic I feel needs to be integrated in the school curriculum at some stages. Well, now I'll come to yet another problem. Soumya, can I please request you to tell me when there are sort of, let's say, 15 minutes left?
Yeah, I'll do that. Yeah.
Thank you. So, well, this is also a very well-known problem. I'm sure many people in the audience already know about it. So this is between an anecdote between Srinivas Ramanujan and P.C. Mahalanobis, and it's called the house number problem. So once when P.C. Mahalanobis visits Ramanujan when he was not very well and he was in his home, and P.C. Mahalanobis visits him and says that, I've been reading this, there was this magazine called The Strand, and I found this very interesting problem. And so Ramanujan says, can you read out the problem to me? So Mahalanobis reads out the problem. And of course, he says that, I'll read it out, but it doesn't seem very easy to solve. And the moment he reads out this problem, and Ramanujan apparently says, in fact, he gives the solution to the problem in a very interesting manner. And this also is an interesting, simple problem, interesting problem, and it can be explored by students of grade 10, 11. So it says, my friend's house is on a long street, where the houses are numbered 1, 2, 3, and so on. All the numbers added up on one side of my friend's house is exactly equal to the house numbers on the other side. So, and there are more than 50 houses, but not as many as 500 on the street. So what is my friend's house number? So this is the problem. So the total number of houses on the street is unknown, but it is known that it lies between 50 and 500. And my friend's house number is also not known, which needs to be worked out. So of course, one should leave the problem with students and ask them to figure it out and give them adequate amount of time to, So let's say these are the house numbers, and the total number of houses, let it be n. And somewhere in between is my friend's house. So, so what it says is that the house numbers from all the way from 1 to up to my friend's house, so this, let's say up to m-1, the sum of these is equal to m plus 1 to n. That is the only thing that is given. So using the children know the formula for the sum of n natural numbers, so they're able to write that this is going to be m-1 into m upon 2. And on the other side, to write this sum, I can take the entire sum from 1 to n, which is n into n plus 1 upon 2, and subtract the sum m into m plus 1 upon 2. So therefore, the entire sum from 1 to n minus the sum from 1 to m will give me this sum. And these two have been given to be equal. So when you simplify this, we get, well, we can cancel and we can see, but we get 2m squared is equal to n into n plus 1, and m squared is equal to n into n plus 1 upon 2. This is what we get. Relationship between m and n. Note that m is my friend's house number and n is the total number of houses on the street. Now, this problem, of course, was posed to children after they had already done a little bit of exploration on polygonal numbers, that is triangular numbers, square numbers, pentagonal numbers, and so on. So one thing which this equation tells us, that the left-hand side is a perfect square. Let's say left-hand side is the mth square number, and the right-hand side happens to be the general formula for the nth triangular number. So can we find numbers like this, which are both square numbers and triangular numbers? So that was something that students had to figure out. Okay, so we need to find suitable values of m and n which satisfy this equation. So we are looking for square numbers, which are also triangular numbers. So of course, children had done a bit of exploration earlier, prior to this, posing this problem. And so they knew what are triangular numbers, and diagrammatically they can be represented like this, and so can square numbers be represented like this. And the first thing the children come up, they jumped and said 36. So 36 is a triangular number and it is also a square number. But what does it mean in terms of, so for example, in terms of our equation, so if m square is n into n plus 1 upon 2, and both happen to be equal to 36, and what should be m and what should be n? So m turns out to be 6 and n turns out to be 8. So that means that this part children could easily get, but sadly this is not the solution. That means if there are 8 houses on the street, 1, 2, 3, 4, 5, 6, 7, 8 house numbers from 1 to 8, and if you take 6 as a friend's house number, then of course the numbers on the left side of 6 and on the right side have the same sum. But sadly, this is not the solution to the problem, because it said that the total number of houses on the street lies between 50 and 500. But at least this gives us a hint that that there is a way to find m and n if we know the common values. So that was the next thing. So if you write the first 10 triangular numbers and the first 10 square numbers, 36 is a common value. And you can identify and say that, look, sorry, that 36 is the 6th square number. And it is the 8th triangular number. So the number of houses in the street is given by the position on the triangular number sequence, and the friend's house number is given by, so this is an association that the children made. Now the bigger challenge was to find how to identify more such numbers. How frequent are they, and so on. So, well, one of the methods adopted was to pull out, create a spreadsheet. So I'll try to do this quickly. To increase the size. I hope you're able to see the spreadsheet. So first, is the spreadsheet visible?
Yes.
Okay. So if I put one, so first I'll just create a column. I'll try to do this quickly. And I add 1 to this. I want to create, let's say I want to create the serial number column of 1 to 500. So I just use the fill series command and create a column from 1 to 500. And I want to now create the triangular number sequence here and the square number sequence here. So triangular number, the formula is n. So n will come from this column, n into n plus 1 upon 2. And the square number will be obviously squaring this. So I can do it this way. And we of course know that 1 is a special number. It is all the polygonal numbers. So let me just center it like this. Okay. Now when I got this, I can just double click, create a sequence of triangle and square numbers. And we can see that, like we saw that 36, which corresponds to the 6th square number, and it also corresponds to the 8th triangular number. And this gave us a hint what the house number may be, although it doesn't. In that problem, if the last sentence was removed, then these could have been solutions. Now the thing is, children started scrolling down, trying to hunt for other common values. With little bit of work, they were able to also see that 1225 is a common number. So 1225 is the 35th square number, and it is also the 49th triangular number. So the conclusion was drawn that if there are 49 houses on the street, and if 35 is my friend's house number, then again the sum will be the same on both the sides. So 1225 was another common value. And then they started looking for more, but it became a little difficult to search for more. So this was done by now. What one can do is use the conditional formatting option given in Excel to highlight cell rules. And in this, if I choose duplicate values, so we can select this and we can give it any color. So what Excel does is it points out to the common values. So this was exciting for children because they did not have the mathematical know-how to find out. But so one possible pair of values was 6 and 8, which they already saw. The next common value is 1225, which corresponds to 35 and 49. Again, these are not a solution to the problem because this is the number of houses is 49. It has to be between 50 and 500. And then they keep scrolling down and you come across quite much later 41616, which happens to be the square of 204. And the same value appearing in the triangular number series at 288. So if there are 288 houses on the street, and if 204 is my friend's house number, that is a solution, according to the problem which was read out by Mahalanobis from the Strand magazine. but there aren't any more in this in the sequence up to 500. So this became, and then students were getting more and more curious about it. And then of course they were curious at how did Ramanujan find it out? And it's obviously not easy to answer that question. But the fact that Ramanujan said that this continued fraction would give the solution to the problem. And it's very interesting to see that if one looks at the convergence of this continued fraction. So for example, if you split, so the first convergent will be 6. Next convergent will be 6 minus 1 upon 6. The next one will be 6 minus 1 upon 6 minus 1 upon 6 and so on. If you look at the convergence, these are the convergence. And if you work out their values, we find that, as I said, the first convergent is 6, this one. The next convergent is 35 upon 6. The next convergent is 204 upon 35 and so on. And both the numerators and denominators, there's a pattern in this, of course, and there's a very beautiful pattern in writing new terms. And children have a lot of fun, in writing additional terms of such continued fractions. How long can you keep writing and how long can you keep going on? So that's also great fun. But here, the numerator or the denominator gives you the friend's house numbers. It doesn't tell you the total number of houses on the street. So immediately, upon doing this, the children said, okay, 204 was the friend's house number. That means if the last sentence of the problem was removed at that condition on the number of houses is removed, then 1189 is also the friend's house number. So then they challenged themselves to find out that if 1189 is the friend's house number, what should be the total number of houses on the street? Because Excel did not show anything till 500. So they went and extended the Excel sheet further, and they extended further, and there was a very interesting exploration that they were able to do. So of course, these equation that comes up in the case of this problem is called a Pell's equation, which is of this form. And so Pell's equation is the equation of this form because this was our equation. So we can rewrite it in this form. And these kind of equations where n is a given positive non-square integer, and integer solutions are sought for such equations and all. So it was not everybody could, some children got interested and they went to study this a little further, but everybody could do the exploration on Excel. So there were multiple parts of inquiry. Students explored the problem using spreadsheets. They extended the problem using spreadsheets. They got interested in studying continued fractions. Some others got interested in looking more in depth and learning about Pell's equation. And others, had already, because the polygonal number activity was done before this. So then they started saying that, what if we look at other sequences? Like, are there pentagonal numbers which are also triangular numbers, or are there pentagonal numbers which are also square numbers? So automatically, because it was easy to generate the data on a spreadsheet, they could use it to find more and more patterns and justify their solutions. So it was a very satisfying exploration. And I think it was a good trigger and also a good exercise on learning how to use the spreadsheet. Okay, how much more time do I have?
Around 18 minutes.
18, okay.
Yes.
Okay, so I just have time for one more problem, barely about, I suppose. So a spreadsheet can also be used for simulation. So another interesting problem which I like very much is the well-known, the Monty Hall problem, also called the 3-door problem. So here what is happening is, it says that you are on a game show and you are given the choice of 3 doors. And this is just a picture, but behind one of the 3 doors is the prize, which is the car. So that's the prize. And behind the other 2, well, the problem says they're goats. So nobody wants the goat, everybody wants to win the prize. So these doors are numbered 1, 2, 3. And you are the player and the host is Monty. So Monty asks you to choose one of the doors. Suppose you pick a door, suppose you pick door 1. Now it's very important. If you pick door, you obviously don't, player doesn't know which door has the prize. Monty knows which door has a prize. Monty will never open the door chosen by the player, nor will Monty open the door which has the prize, because Monty knows which door has the prize. So you choose a door, Monty will open one of the other two doors. So suppose you choose door 1, Monty will open door 2 or door 3, will reveal you a goat, and then will ask you to choose again. This is the last choice. We'll ask you to choose again. Would you like to stick to your original choice, which was 1, or would you like to, suppose, for example, the player chooses door 1 and Monty opens door 2 and reveals the goat. Now Monty asks, do you want to stick to door 1, or do you want to now take the chance of opening door 3 to win the prize? What should you do? Is it better to stick to your original choice, or is it better to switch? That's the problem. So I hope the problem is clear to everyone. So if you analyze this problem, so usually the notion is that, look, when Monty has opened one of the doors and revealed a goat, there are only 2 doors left. So how should it matter which one I choose? And the probability of is half and half of winning the prize. But actually, if you go a little bit in depth, it is not so. So let's see if you, so a simple tree diagram can help to, so when you give this problem to students, they start saying all kinds of things, but to channelize their thoughts and maybe to put it in the form of a diagram. So one possibility is that the car can be located behind any one, the prize can be located behind any one of the 3 doors, and the probability is 1/3 each, because you can randomly place the car behind one of the doors. Now, let us assume that the player has chosen door 1. The player's choice is door 1. And if the car is also behind door 1, then Monty will open one of the other 2 doors, but he can open any one of the 2, because both have goats behind them. To him, it doesn't matter. So he opens the other 2 doors with equal probability. But suppose the car is actually behind door 2 and the player has chosen door 1, then Monty has no option but to open door 3. So the probability of his opening door 3 will then be 1, certain. And similarly, if the car is behind door 3 and the player has chosen door 1, then Monty has to open door 2. Now let us see this. The total probabilities against these are given here. Now, if the player has chosen door 1 and the car is also behind door 1, then the player can only win by sticking to his original choice. And the probability of that is 1/6 plus 1/6, which is 1/3. On the other hand, if the player has chosen door 1 and the car is behind door 2, I mean, if the car is actually behind door 2 and the door 1, then the player can only win by switching away from his choice. In that case, the probability is 1/3 plus 1/3, which is 2/3. So there is a 2/3 probability of winning by switching from the original choice and 1/3 probability of winning by sticking to your choice. So this is the basic as an analysis of the problem. But what is more interesting is if you can create a tree diagram to create the sample space of this experiment. Suppose it's a random experiment where the car is located behind one of the 3 doors with probability 1/3 each. Now, so let's say this is the door, the position of the car, the first level of the tree. The second level of the tree is the player's choice. So if the car is behind door 1 and the player has also chosen door 1, these are the doors opened by Monty. So then obviously Monty has to open either door 2 or door 3 with equal probability. However, if car is behind door 1 and the player has chosen door 2, then Monty has no choice but to open door 3. So if you look at this kind of a diagram for all the cases, we see a very beautiful symmetric tree diagram. And we also see, let's say these are the outcomes of the sample space, where the first number denotes the position of the car. These are three triples. The first number denotes the position of the car, the second number the player's choice, and the third number door opened by Monty. So 1, 1, 2 is this case, this branch of the tree, and its probability by multiplying we see is 1/18. Whereas if you take some other case like 1, 2, 3, this one, the probability is 1/9. So all the outcomes are not equally likely. And from this also we can analyze and see that there are 6 situations where the player can win by sticking to his choice, original choice, And there's 6 cases, so 6 into 1 by 18 is actually 1/3. And the others are going to work out to 2/3. So even from the sample space, working out the sample space, one can calculate these probabilities to be 1/3 and 2/3. I don't have time to get into the details of this, but for older students who in class 12, they do Bayes theorem and all, they do conditional probability, the same problem can be analyzed using conditional probability. And you can show that the probability of winning by sticking to your original choice is 1/3, and by switching is actually 2/3. But there were other explorations done by students, like suppose what happens if Monty is biased towards one of the doors. So let's say that the car is placed behind door 1 and the player has also chosen door 1. Now Monty has a choice of opening door 2 and door 3, but he tends to open 3 more often than 2. So let's say there's a 1/4 and 3/4 probability. Then what will happen? That means Monty has a preference for door 3 over the other 2 doors. So this became then the students started saying, well, obviously the probability will change now. But then interestingly, so let me quickly, this is the last thing I will just, can you see the Excel sheet?
Yeah.
Okay, so I'll just expand this a bit. Yeah, so here's an Excel sheet which simulates the Monty Hall problem. I hope you can see in blue, it says in this particular simulation, there are 100 simulations, or was it more than that? Let me just check. Well, there are 1,000 simulations. So each row is a simulation of the problem. So this is just a serial number column. This column B randomly places the car behind. So it's either door 2 or door 3. The ran between command has been used. So the output of column B is just door 1, 2, or 3, because its car is placed behind one of the 3 doors. Here we have fixed the player's choice to be door 1 just for simplicity, but you can randomize that also. Now, a conditional statement is used to check which door Monty will open. Now, naturally, if the car is behind door 2 and the player has chosen door 1, Monty has to open door 3. In this situation, the player can only win by switching. So there will be a yes here and a no here, because the player cannot win by staying with the choice. On the other hand, let's look at this case. The car is behind door 1 and the player is also chosen door 1. In this case, Monty has opened door 3, and the player will win by staying with the original choice because the car is behind door 1 and he had chosen it in the first time. And it says yes. So simple conditional statements can be used to simulate the door which Monty will open, and then check, and then it will say no or yes. Yes and no will indicate whether the player will win by staying with the choice or switching. And combining all this data on the sheet, that is 100 simulations. So suppose the Monty Hall game is played 1,000 times. It works out to be almost 1/3 and 2/3. So probability of winning by staying with one's choices. So this simulation also shows that. Now suppose I tap this sheet again, the entire data changes. And here you see the probabilities have also changed. But in the long run, they will empirically, it will be close, but not exactly so. So again, 0.36 and 0.65 and so on. So we can see this. And interestingly, by making a very simple change in this conditional statement, so now suppose Monty has a preference for one of the doors. I can just change this random command here from 0.5 to 0.25. So let's say that Monty, if there's a choice between door 2 and door 3, Monty will choose door 2 1/4 of the times and will choose door 3 3/4 of the time. If I simulate that by making a small change in this, it is interesting to note that these probabilities do not change. So this came as a huge surprise and a shock to students. How is it even possible? And then went back to probability to analyze why it is so. So the use of the tree diagram, the use of the simulation on the Excel sheet, the symbolic representation of the problem using conditional probability, all of this fell in together to help students analyze this problem. So I'll quickly wind up now. And so let's say in terms of extensions, now the students said that one of the explorations which was done was, what if there were 4 doors? What would happen then? And so this is a diagram drawn by one of the students, a kind of a tree diagram. It became pretty huge, so not the entire diagram could be drawn. So now if there are 4 doors, then the car can be placed behind each one of them with equal probability. So now they become 1/4. The player can also choose any one of the 4 doors with equal probability, that is 1/4. But suppose the car is behind door 1 and the player has chosen door 1, Monty can open doors 2, 3, and 4 respectively with equal probability, 1/3, 1/3, 1/3, and so on. However, if the car is behind door 1 and the player has chosen door 2, then there are only 2 door options now open to Monty, and so on. And sample space was worked out. And students got very excited because they saw that the probability of winning by sticking to one's choice in this case is 1/4, and the probability of winning by switching is 3/4. So there was they kind of conjectured that there is something going on here. First it was 1/3 and 2/3, now it's 1/4 and 3/4. So then they just made a guess that if there were 5 doors, it would be 1/5 and 4/5 and so on. So these problems are interesting, they're beautiful, but while engaging with them, one comes across all kinds of mathematics is dealt with. I'll quickly skip all this. And I would just like to end, I would like to share that in such cases, the student feedback was excellent of these kind of explorations. The project or the expert, they own their project and they seem to be responsible for their learning. And it encouraged group work because, it kind of made students argue with each other, discuss with each other. And I don't see why this cannot be adopted even in an online mode. Technology worked as an amplifier. Technology in this case was obviously the spreadsheet made students, so students could outsource the calculation part to the spreadsheet. And because you see in the triangular and square numbers, if they had to sit and really generate them themselves, it would not have been possible to explore the problem. Technology worked as a reorganizer because it gives you access to higher level concepts, and the problems are also such that if you choose them appropriately, you would give students access to new concepts which probably go beyond what they are learning. The tasks were meaningful and outcomes were not always predefined, so there was always a sense of suspense, and when there was a little bit of a discovery, there was an aha moment. And in some cases, students really like to show their projects in pairs and competitions. So there is a lot of, these problems can help to bring about that shift from content to processes that we talked about. But of course, we need a considered use of the appropriate technology for such explorations. And I would end with the quote by George Pollier, which says that a great discovery solves a great problem, but there is a grain of discovery in the solution of any problem. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you may experience the tension and enjoy the triumph of discovery. Thank you very much for your patient listening.
Thank you, ma'am, for the nice talk. Any questions from the audience? Yeah, you can unmute and ask the question directly.
I hope it was not too overwhelming. I mean, I kind of went a little fast. So.
Yeah, in case there is no question, we thank again, ma'am. So we come back at 1:45 after lunch. So we have the workshop on Geogebra.
Let me just formally thank Jonaki being on the platform once again. Jonaki.
Thank you.
Take care. Yeah, please, Soumya, continue.
Yeah, so we will be coming back at 1:45, 13:45 hours. And we will have the workshop on Geogebra Basic by
I think I'd like to remind about the feedback form you are already linked.
Right, right. So I have already shared the feedback form on the chat, and I request all of you to share your feedback there.
Thank you. Okay. Would you like to close the meeting or rejoin?
Hello, sir.
Hello. Hi, Soumya.
So we start at 5 minutes.
Yeah.
I don't see Girish sir is here.
Yeah, it's not yet joined, I think.
Good morning, Soumya. Rather, good afternoon.
Yeah.
Hi.
Good
Girish,
afternoon, sir.
Good afternoon.
sir.
Good afternoon.
So I'm just checking whether sharing is working or not.
Yeah, it's
Yeah, we can
yeah.
see.
Yes. So we still have 3 minutes.
Yeah.
Yeah. So can we start?
Yeah, I think we can start. Welcome back to the first session in the afternoon. This is going to be a more a hands-on workshop session on GeoGebra by Girish Belkar. Girish has been participating in time conferences as a resource person for a long time. He is from Shriram Sentinel School in Indore. So Girish, I think you can start.
Okay. Thank you very much, sir.
Welcome.
So I hope that everyone has downloaded GeoGebra and opened that, because I'll be assigning you tasks on the way and you need to complete, and with Soumya's permission you can share the screen and show it to us that how it has come out, right? And if you are not, then simply you can Google GeoGebra and that classic app you can be opened in your browser as well. So even if you're not downloaded, you can work on it. So let's start. So GeoGebra, as the name suggests, it's a combination of.
Tell us about the link, like what is the website for the GeoGebra web?
Okay, so you just if you go on Google, and I'll just show you how to do it.
Yeah, I think it's a good idea to.
Yeah, I'll just share that complete screen. So you just Google GeoGebra here. And then click on this classic. So the app is open.
If somebody has not yet downloaded and want to wait for a minute to download, we can do that. In the chat box, please put wait. If you don't say wait, we'll continue.
I'll also put the link in chat box.
Yeah, that will be good. So link for, you can just click the link and it will open for you, GeoGebra Classic. Yes, Girish, wait for a minute.
Yeah.
People are downloading probably. Some are totally new to GeoGebra.
So those who are new and they don't know how to download and install, so the best way is work on browser only. The functionalities will be same.
Yeah, I think we can start.
Okay.
Yeah.
So as we're discussing, the name GeoGebra itself suggests that it's a combination of basically two branches of mathematics. One is geometry and algebra. So when you open your GeoGebra, you see these two windows. This is the first window and this is the another window. So this is, as you can see, is Cartesian axis. So this is the geometry window. Whatever figures will be drawn here, and the corresponding equations would be on the other side. For example, if I point here, so a point is shown here and the corresponding coordinates are shown here. So the basic, there are two display. One is geometry, other is have
I think the audio is low. I think. Yeah, I think there is some network issue.
Yeah, maybe just. So, am I audible now?
Yeah, but you need to share again your screen.
Okay, I need to share my screen again. Correct.
Okay. So एक और दो का कौन कर रहा है? वो एक और दूसरा आज के
So is it visible now?
Yes.
Yes, visible.
So what I was saying that these two screens, when a geometry and algebra, they are interconnected. So whatever I draw on the geometry side screen, which is on the right hand side, the corresponding equation would be displayed on the left hand side and vice versa. So for example, again, I don't know whether that was visual. So if I put a point C here, whose coordinates are 3, 4, the point C would be constructed here. So from here to here or here to here, it's a mutual we can do. So I'll be starting with the tools which we have here. I'll just clear the board. So we have here, one is this arrow. This is very important. This tool helps us to move the geometry board, select any object which is on the screen, right? So these are the two main work of this arrow. Then we have a point toolbar, then the line toolbar, then there is a perpendicular parallel, then you have a polygon tool and circle, and then you have ellipse, angles, right, and so many. So I'll go one by one. So point. So there are sub parts also. So the point, if you click on point, so the point tool is selected, and when you click on your geometry screen, a point is created like this. So wherever you click, a point would be created. So we can create the points like this, and you can see that the coordinates of all the points are shown here. So this is a basic first. Everywhere will require this point tool. Then there are point on object. So suppose you already drawn any object, say a line segment or a triangle, and if you want a point on that, so you can use this tool. But the upper one, this point tool, can also do the job. So this is very rarely required. I normally prefer this point tool. So by using this tool also, we can plot a point on any object. Attach and detach, we hardly require, so I'm not going into that. The next important is intersect. So whenever we want to find a point of intersection of any two objects, maybe two lines, maybe two circle, or a line and circle, or line and line segment. So this tool is again very useful. So this is the second tool which we'll be using frequently after point. Then the third tool which is required is midpoint or the center. So if you have a line segment and if you want to plot midpoint of that line segment, this tool can be used. Or if you have a circle and you want to look at the center of the circle, you can use this tool. So three tools which are important to us as point, intersect, and midpoint or center. So these three tools only I'll be concentrating. Remaining are not required right now, right? So these are the three. Then we come to line tool. So again, we have here different sub tools under line. This is line tool. So whenever you have a 2 point, you can just click on those 2 point and a line will be drawn. So I'll just select this line tool. I click on point A, then on B, and then you can see that the line is drawn passing through A and B. Now this line is a dynamic line. It is not a static line. If I move A or B, the line will also move, right? So to do this, I will select this arrow tool, or you can just press escape key. Once you press escape key, automatically by default, the arrow tool is selected. So from whichever tool you are using, if you press escape key, you will reach to arrow key. So I'll escape. So you can see that arrow key is selected here. Now I'm moving point B, and you can see that the line is also moving along with the points. So that's why this is called dynamic geometry software. The geometry is dynamic, not static. So if you move a point, all the other points and all other objects which depends upon that point will also move. Right? So this is a line tool. Then similarly, you have a line segment tool. It also works similar to the line. Only difference is you get a line segment. Then again, the third tool is segment with a given length. So suppose you want a line segment of fixed length passing through a point, you can use this tool. So I'll show. So suppose I want a line segment passing through C whose length is 4 units. So I'll first click on this point C. As soon as I click, I get a pop-up box which asks for the length. So I type 4 and then click OK. So I get a line segment of length 4 which passes through point C. Again, this line segment is also dynamic. I'll show you. This, I'm moving J. So the point is at a fixed distance, that is 4 units from the C. And then you can see that it is moving around a circle. So this is how you can explain children that the locus of a point which is at a fixed distance from a given point is a circle. And if I move point C, J will also move along with it. So the length of line segment is always fixed 4 units. Then there is a ray tool. So ray tool is again similar to line and line segment. The only thing is in line, the lines extend on the both side, where in the segment, it will start from the first point. The point where you click first, the ray will start from that point. So for example, if I first click on F and then D, so a line segment FD has been formed. So there is no part which is away from F side. So it is only on one direction, whereas a line is in both direction, from this side also and this side also. So these are the 4 things which we'll be using. Polyline vector will not be leading right now, so I'll not explain that. Then we move to the third tool, which are again relationship between 2 lines. So perpendicular line, parallel lines, perpendicular bisector, angle bisector, tangents, and all things are there. So we'll be basically using more of this first 2, perpendicular and parallel. So again, when you click on this tool, and so first you need to, so there are 2 options, either you
स्क्रीन तिथे दिसत 2 नाही होत.
Hello, is there any problem? Okay. So to create a perpendicular line to a given line, so there are 2 possibilities. Either the point is on the line or point is outside the line. So when you, so first you need to click on the line. Once you click on this line, a perpendicular line is drawn. So now this line is currently movable. And as soon as you click on the point, either which is on the line or outside the line, now this line is fixed, cannot be moved. So this relationship, so this is perpendicular. So if I change this line, so you can see that the relationship is always perpendicular. Other line is also moving. So if I move G, this is moving with this. Okay. So same thing is with parallel. I need to have a point and a line. So I choose this FD and then I click on point E. So this new line is parallel to DF or FD. So if I move this point, you can see that the another line is moving, so that they're always parallel. Okay, so these are the points. Now I'll jump toolbar and move to this angle thing, so that we can do something constructive where you can see the power of GeoGebra. So angle tool. So for angle tool, you require either 3 points or 2 lines. So it can give you the angle between 2 lines, or it can give you angle formed by 3 lines. So 3 points. So I'll just first take this case, 3 points.
Sir, can you tell us how exactly you are clearing the screen?
You say the Control A and delete.
Okay. Okay.
So these are the 3 points. Now we need to angle. So when I hover my cursor on angle, at the bottom you can see that the help is given. Can you see? At the bottom is a gray box. Are you able to see, everyone?
Yeah.
So let's select 3 points or 2 lines. So the points need to be selected in anti-clockwise direction. So right, so you get this angle. So first starting point, then the vertex, and then third point. Okay, so when you select in clockwise direction, you get the angle. So this way we can, so again this angle is again dynamic. So if I move C or B, the angle is changing. So we have seen how to plot points, how to join 2 points, how to the perpendicular and parallel lines, and how to measure angle. Now with this little knowledge, we'll be able to verify many geometrical properties. So the first which I am going to take is the sum of 3 interior angles of a triangle is always 180 degree. So for this, I'll need 3 points. So I'll draw 3 points, A, B, and C. Then using the segment tool, I'll draw line segment AB, C, and D. So the triangle is formed. Okay. Now we need to measure 3 interior angles. So I'll select angle tool. I'll go clockwise direction. So first B, then A, and then C. So angle BAC has been measured. Then A, C, B, and lastly C, B, A. Okay, so now you can verify that the sum of angles is 90 degree, and no matter wherever I take this, so 69 plus 51 will come to be 120, and this 60 is 180, right? So we can easily dynamically verify that the sum is always 180 degree. There's also a method of how to display this dynamic text on the other side. and how to find sum, that we'll see tomorrow in the advanced session. But right now, we'll do this. Okay. So this is one just simple demonstration how GeoGebra can help us in exploring and verifying various geometric facts. Obviously, you can't prove, but you can verify, and then you can motivate student to prove why is this happening, right? Another simple things which we can verify here is when we get two parallel lines are intersected by a transversal, then the pairs, how do they behave? Corresponding, alternate, and interior angles on the same side. So again, we'll need point tool. So I have drawn 2 points AB, and now next I'll draw a line through AB. Now to check whether the line is dynamic or not, the best way is to just move these points A and B so that we know the line is moving. At times it happens that the points, you don't click properly on the points and another line is created instead of the line which you want. So it is better to check every time when we do. Now I'll need a third point so that I can draw a line parallel. So either I can have a point already or I can simply use this parallel line tool. A parallel line is drawn, and next time wherever I click, a point will be created and the line would be fixed. So now you can see this, I clicked on here, so point C was created and the line AB is parallel to this new line G. So again I'll verify whether the line are parallel or not. So you can see when I'm moving A or B, the lines are always parallel, right? So now we'll need a transversal. So for that we need 1 point on the line segment, line AB, and another point on this line. So I'll select the point tool, and I'll take this cursor on this. As soon as it's turned to a hand, just click. Okay, the arrow is turning into hand. So that means we have selected the line. So I clicked. So a point D is created. Now again I have to check whether this point D is on the line or not. So what I'll do, I'll again press the escape key so that the arrow key is selected, and then I'll move D. So now D cannot be moved out of the line. It is always on the line. So this point D is on the line. Similarly, I'll create a point on this line. So you can see the arrow and then hand. So as soon as hand, this is, so 2 points D and E are created. Now I'll need a line which is passing through D and E. So a transversal is there. Now we'll verify that the alternate angles are equal. Right? So I'll use this angle tool and I can select this line and this line. So you can see that the angle between these two lines is automatically generated. Similarly, I'll select this and this line. Sorry. This, so order was different. So this creating same. We will use that the tool which says that 3 points. So we'll require points here. So 3 points. So we have 3 points here, and we'll use the angle tool again. So we have B, D, this is angle, and similarly we'll create another angle by selecting. So 2 angles have been created. You can see that both are measuring 74.58. And now we'll move So again, this is 79. If I move C, you can see it is 66.96. This is also 66. I move A, this is 45.5 and 45.5. So understood? So here's a task for you. I want you to verify that the alternate interior angles are equal. I'm giving you 5 minutes to do that. And once you're done, just request Soumya to permit you to share the file on chat. You can request Soumya. So I'm
Is there an issue?
no, I've given them a task.
Okay. Good. Because I was wondering whether.
No. Anybody?
one person says wait.
No, that wait done. Okay.
Yeah.
Aniruddha Deshmukh has done. Soumya, can you give Aniruddha? Or Anga is also done. So I'll stop sharing. So you can just give them rights to share.
Yeah, I think I am sharing now.
Yeah.
Aniruddha is sharing.
Aniruddha is sharing. So just move point A, B. Yes. So we can see. So good work, Aniruddha.
Yeah, thank you, sir.
Shubhangi says she cannot share.
So once, so now Aniruddha just, so next who is?
Hello.
So, Anga.
Can I share?
Yeah, Soumya, who can share now? We'll take first three always, first three. So Anga is second and Shubhangi is third.
Is my screen visible?
Yeah.
Yes.
Angles are far away, so we are not able to understand which angle is alpha and which angle is delta.
Change the colors.
Just keep them so that you know. Right. Yeah. Good. Excellent.
Thank you, sir.
Okay. So Shubhangi is not able to share because she has done on other device. Fine. So we'll move to the next. So I'll just press Control A and then delete. So my drawing box is clear. So we are comfortable. Now we move to another task. So this basic three concept which we learn is the medians, angle bisector, and right bisector. They're all concurrent. So they pass through same point. So I'll demonstrate how to do for medians, and then I'll ask you to do it for either angle bisector or perpendicular bisector. So again, we'll require a triangle. So a triangle can also be directly constructed through the polygon tool. So polygon tool, you can construct many, triangle, quadrilateral, pentagon, hexagon, all. So I'll just use this polygon tool to demonstrate how the polygon is created. So you select this polygon tool. So if you already have 3 points, you click those 3 points in order, or else you can just click 3 at 3 random points and go back to the first point again. A polygon is created. Right. So this is our triangle. So we can create as many as side polygon. All you need to do is when you come back to the first point, the polygon is complete. And this polygon is again, so you can see this polygon is complete. Right. So this is the way we can draw a polygon. Another way, as I told you, we first draw 3 points, A, B, C, then select the polygon tool and start with A, B, C, and then again come back to A. So the polygon ABC is drawn. So there are 2 ways of drawing polygon. Now we have this triangle, and now we need the midpoints of the sides. So as I explained, in the point ribbon only you have midpoint or the center. So this is, we'll select this tool, midpoint or the center. So there are again two ways. You can see below it is written select 2 points, a segment, a circle or a conic. So either way we can find out the midpoint. So I have two options here. Either I simply click on the side BC, the midpoint of the side will come, or I first click on B and then on C, the midpoint will come, right? So both have their own advantages, both the methods. When you have a line segment, you always click on the line segment, but when you don't have a line segment, you have only 2 points and you want a midpoint, then you have to go by clicking first on first point and then the second. So since here we already have line segment, so I'll click directly on the line segment. So you can see the midpoint of BC has been created. Another way, first I click on C, then you can see that the point C is highlighted, and then on click A, the midpoint E is created. So similarly, we created this 3. Now I'll draw medians. So to that, I'll take this ray tool so that the median can extend. So I'll draw this AD and BE. So, and this is the point of intersection. So let us find the point of intersection using this tool intersect. So I'll select this line. It is highlighted, and then the second line. So I got this G, which is a point of intersection of these two median AD and B. Now we'll draw the third median, and we'll see that the third median will also pass through G. So you can see that this is also passing through G, and no matter we change this triangle, you can always have that these 3 medians, they are concurrent. Okay. So can you try it out that the perpendicular bisector of any triangle are concurrent? So again, I'll give you 5 minutes to complete the task. Once you're completed, just write on the chat box that you have completed, then Soumya would be able to give you sharing rights.
Sir, shall I share?
Yeah, just write on the chat box so that Soumya knows.
Yeah, I think
Ah.
you can share.
Yeah, we can see your screen.
Can you move some of the points so that?
Oh, you to move ABC, ABC, ABC. Just first select arrow tool. Arrow tool. No, don't select. Just press escape. Escape key. That's all. Now you move ABC.
I guess you need to click and then drag. Yeah. Perfect.
Perfect. Okay. Next.
Soumya.
Yes, sir.
That reminds me of is not kaan pakdo, kaan pakad ke khicho.
Yes, yes, yes.
This is something else, right?
No, these are also right bisectors only. But
oh, okay.
She has, instead of creating first midpoint, she has just selected the tool right bisector. So there is the point is not
perpendicular bisectors.
Yeah, perpendicular bisectors. So now you can use
I have
this.
also completed. Can I share it?
Yeah, please.
Sure. Okay.
Sir, I have a question.
Yeah.
Is that right?
I have got a line by selecting 2 points, but now I have to delete it.
Delete. So just right click on that line.
Right.
So you'll see a delete option.
Okay, thank you.
Yeah, Ashok.
Correct, no? Right. I'll stop sharing.
Yeah. So we learned this. So I mean, with this, you can also ask children to verify that the orthocenter, which is the point of, or circumcenter, which is the point of concurrence of right bisector. It lies inside the circle when inside the triangle when the triangle is acute, outside this triangle when the triangle is obtuse, and on the hypotenuse when the triangle is a right angle triangle. And other like two, that is circumcenter and centroid, they will always lie inside the triangle, no matter whether it's an obtuse angle triangle, acute angle triangle, or a right angle triangle. So in all cases, it will always be inside. So they can verify and they can remember the fact forever instead of we just telling them. So now we move to something called construction of a parallelogram, right? So there is a difference between drawing a parallelogram and constructing a parallelogram, right? So I'll draw a parallelogram. So I take this point A. Okay. And then I take this polygon tool. So I can say that ABCD is a parallelogram. But this parallelogram has been drawn, not constructed, because As soon as I move the point C, this is no longer a parallelogram. Okay. So now what we'll do is we construct a dynamic parallelogram. So no matter we move all 4 points, the figure will always remain a parallelogram, right? So let us do that. So delete again, if you want to delete, as we're telling, just select on any and right click on any object that would be deleted, and that object as well as all the objects that depends upon that would be deleted. For example, in this I have deleted B and the polygon was dependent on B, so therefore that polygon is also been deleted, but the point A, C and D, they were independent, so they were not deleted. So before deleting, you need to be very careful, because once you delete a point or a line, all the dependent objects will also get deleted. But don't worry, Bill Gates has given us a great tool, Control Z, which works on all software, but unfortunately not in life. So in life, there is nothing called Control Z. So I'll just delete this. One by one also can be deleted. So now again, so we'll need a line. So for line, I'll need 2 points. So I'll draw 2 points AB, and then there will be line through points AB. Now, parallelogram, I require 2 pairs of parallel lines. So I'll first draw a line which is parallel to AB. So parallel lines. So I have this. Now I need a point D on this side, that AB and CD, they are equal. So I have a pair of parallel line. Now I need 2 line segments which are equal in length. Now how to draw that equal length? So there is something which is called arc. When we construct, we use the system of arc, right? So I'll need arc to measure the distance AB. So there are various tools by which we can measure the distance, but the measured distance would be a fixed one, constant. Like for example, if I measure AB right now and I can see that it is 6 centimeter and I cut an arc 6 centimeter, that will be a fixed parallelogram, not a dynamic one. What I want is the length AB should always be equal to length CD. This is what I want. Or I want a D point where AC and BD, they are equal, right? So I'll join first line AC. So I have this line. So now I got 3 lines, right? So now I need a point D whose distance from this is same. Okay. So what I'll do, yeah. Anybody has any question? Okay. So I'll draw a circle. So there are possibilities drawing circles. A circle with center through point, and there is something called circle with center and radius. So I'll draw a circle with center through point. So this is my circle A, and this is. So now you can see I had drawn a circle through A whose radius is equal to AC. Now if I draw a circle through B whose radius is equal to AC, then wherever it intersects, that point would be my point D. Okay, am I clear? So now I need to measure the radius AC, and then I use that to create. So for that, there is, sorry. Yeah, the controls are hidden now. So here we have to call something distance or length, right? So I'll just measure this. Okay, this is the distance AC. So the name is here also of this object, distance. So what we can do is, so this is 4.47. So what I'll do is, here I'll just rename this. So when you rename, you can just right click and rename. So distance AC, I'll just rename this as R. So I know that this is the radius. Okay. So this distance AC is renamed as R. Now I'll construct a circle through B whose radius is R. Right. So I'll go choose the second one, circle center and radius. Okay. So I'll click on B, and the radius, now instead of typing 4.47, because if I type 4.47, it will be a static circle of always radius. Instead of that, I'll just type R, because I have given the radius as this name R. So this R and this radius will always be equal. So circle has been drawn. Now I need this intersection point. So I'll take intersect tool and just bring my arrow to this. As soon as it turns to hand, I'll click it. So now this point D has been created, whose distance is same as AC. So I'll just click this right line segment. So this is AD, the line segment AD will be R. So now we want all the unnecessary things to be hidden. Okay, to hide those, like the circles, this text, we want them to hide. So what, I'll just right click on this, and then there is a checkbox toggle, show object, and another is show label. So if you want to show the object, check this checkbox, and if you hide, uncheck. So I'll just uncheck this. So now this circle is hidden. Similarly, this circle is also hidden. I don't need this line, so I'll just hide these lines as well. Right. Now I'll select the polygon tool and A, B, D, C, and again A. So this is a parallelogram. So you can see always, wherever I take, it's a parallelogram. It's always parallel. We can verify this AC is 4.7. I'll just measure this distance. This is also 4.47. I'll measure the distance AB. This is 10, and this is also 10. So all the sides are equal and parallel. Opposite sides are equal and parallel. Hope you understood this. Now I'll give you an easier task to complete. Construct a rectangle. Or for that, let us construct a square. That is much easier than a rectangle. So construct a square. This is the task. And once you have constructed, just let us know.
Sir, we have only 3 minutes left. So
yeah. So
in case you have some more things to do, I mean, you can.
I mean, this much today they can grasp. They can have this. This is a homework task. Then they can verify that midpoint theorem, that the line segment passing to the midpoints of two sides is parallel to third side, that you can verify. So whatever we learned today, many result with triangles can be verified. Okay. So I think because tomorrow I was supposed to take dynamic, those texts and all, but slider and all, it won't be possible in this 3 minutes. So I'll take that tomorrow, how to use slider and dynamic text. Basically tomorrow's task would be that.
If you like, you can take 5 minutes more.
Okay. So I've just given them task.
Soumya, is it okay?
Yeah, fine. I mean, I just wanted to remind. Yeah.
So I will just see if somebody is able to construct a square. Otherwise, I'll demonstrate how to construct a square.
Yeah, someone would like to share their screen and. Yeah, so I think it's better you can do it. Yeah.
Okay. So again, to construct a square, we'll need 2 points. So I'll take points A and a line passing through AB. Then we need a perpendicular line. So I click on line AB and then A. So I've drawn a line which is perpendicular to AB. Similarly, I'll draw a line which is perpendicular to AB and passing through B. So I'll click on the line and then I'll click on point B. So I've constructed 2 perpendiculars. Now I want points here so that the distance AB and AC BD all are same. So I'll select the circle with center at point. So I'll draw a circle with center at A and passing through B. So this is being circle, this distance and this distance will be equal. So I'll take this intersect point So this is now AC and AB are of same length. I'll repeat the same steps with center at B. So I'll draw a circle with center at B and passing through A. So now this point would be my fourth point. So this is, now again we'll hide all unnecessary objects. So we have this ABCD and we draw polygon. So you can see this is a square. Right. And I'll tell you a little bit about the display which you're seeing, that the names of line segment here, this is AB is line segment A, this line segment is B, and this is D1 and this is C1. All this naming can be changed, and we can also select what needs to be displayed here. So suppose instead of the name of line AB, I want the length to be displayed. So I'll just go right click and go on settings. So a window will open on the right hand side. So from here you can change the label. So the label right now shows, so show label. So it is showing right now name. Sorry. So I'll just click on here. So you can show names, or you can value. So show label and value. So it will be value. So the area of the length is also shown 6.45. Same thing we can do for B, and then we can show value. So this is again 6 points. So this way you can change the values you want to. So you have options, either the name or name and value both, or caption. That means if you want to give something of your own, so we write caption. So if I write this is side of triangle, or rather side of square. So this caption will be shown. And if you want caption and value, so caption. So side of square equal to 6.45. So this way you can customize the way you want the things to get displayed. So this is one thing, right? Then there are fixed object. So once you click on fix, you won't be able to move that objects on the screen. So this is fixed, right? Then you can change color. So if you want that color to be blue, so the color of the line is blue, or you want the green, so you can change color as well. Then there's a style. Similarly, you can change, so all objects colors can be, like I've selected this, so you can have this as color. So since the sides are associated with the polygons, everything color is changed. So you can, and then you can have this opacity, how this works. So you can change this as well. So you need to just explore the things and how you want it. Then there is a style. So style gives you line thickness. So if you want thinner lines, you can have thinner lines. If you want, you can have bolder lines. Line opacity, then the line style. If you want continuous, or you want a dotted one. So these things are possible. Then feelings also, instead of this is a standard feeling. If you want hatching, so it would be hatch, dashed, and all this dots or honeycomb. So you can change a lot of things in the display. So obviously this will only change the display. It will not change the basic property of the object. If you can use this to make it beautiful or to make it more effective using different colors, so you know that which angles are to be shown equal, which sides are equal. So those who are more towards spatial kids who don't understand, but they understand the figures and colors and all, so for such children, these effects are more useful, right? So, and then there is third advanced will be using this tomorrow, not today, but yes, we can have basics. You can change name, you can change caption, you can see show objects, or you want to hide object can be shown or hidden by toggle, and these things are there. Okay, so a lot of when you explore, you will find out what all things can be done. So this is all for today. Tomorrow we'll see how can use sliders, a checkbox, and how to use tracing and the dynamic text. So this is tomorrow's things which I will cover. And this is all from my end.
Girish.
Yes, sir.
I just want to give them an exercise for tomorrow, which they should do today and show you tomorrow.
So that is construction of a rectangle?
No, you have already done construction of a square, right?
Square I've done. Rectangle, I want.
I want them to construct a square whose diagonal is given.
Okay. Yeah, correct.
Construct a square, length of its diagonal is given. Say something like 2 units or 3 units. So take fixed length and construct a square on it. Okay, so that is exercise for tomorrow.
Yeah.
Want to practice it and show it tomorrow by sharing your screen to Girish.
Yeah, and also that verification of midpoint theorem.
Yeah, so 2 exercises for tomorrow. Okay. Yeah, thank you, Girish. So we'll take a short break of how much time? 10 minutes. We meet.
Yeah, so we meet at 3.
Yeah, we meet at 3 o'clock sharp for the next session.
Yeah, okay.
कल से ब्लैक हो जाएगा। अच्छा हो गया रजिस्ट्रेशन अभी रोक दो सर। इन हाउस 31 दिसंबर
Hello, Satvinder.
Hello, sir. Good
How are
afternoon.
you?
Yeah, I'm
Good
good. Thank
afternoon.
you. I
Good,
hope
good.
you can hear me, right?
Yes, yes, very much.
That's great.
Yeah. You want to share your screen?
Yep.
Yeah. Uh, yeah. Visible. Perfectly visible.
Perfect.
You already know Soumya, right?
Yeah, we have met.
Yeah.
Math
Right.
clinic. Yeah, yeah.
Yeah.
So he and we will be helping you if any questions come up in the chat box or something.
Cool. Thank you. Yeah. Let me know when we are ready to start. So I'll...
Yeah. Soumya, we will tell when to start.
Yes. 1 more minute.
Yeah.
Yes, sir. We can start now.
Sure. So we have the next workshop on Desmos by Satvinder Singh. So I think we'll utilize the time by just starting off. Satvinder, please.
Thank you. So welcome, guys. This time 21 math workshop session. And I hope you are excited to start with Desmos. If you know about Desmos, that's great. Otherwise, I'll share some of my experiences using Desmos in my math lessons. And yeah, so if you have your laptops ready, you're watching from mobile, please, you can work side by side with me. I don't mind. You can visit desmos.com. And to save your work, you can sign in with your email IDs. That is the requirement to save your work. For try, you don't need to sign in. So my plan is 10 minutes I'll spend for the tools which are available on Desmos, and 10 minutes for that particular tool, which is very, very useful, Desmos graphing calculator. And further than 10 minutes we'll spend on the geometry and matrix tools, which are available within the Desmos. And then the last part, which is really, really important for the classroom session to organize activities, it is actually Desmos Activity Builder. So I hope you're excited about it. And if you just type desmos.com, you will land on this page. Please confirm if you can see my screen, which is showing Desmos Math Tools.
Yeah.
Thank you. Yeah. So as soon as you are on desmos.com, here you will see, let me take you to the another page here. Look at this. You can see my name here because I'm signed in with my account, and I can anytime I can change my email address. So on this Desmos, there are lots of things on this page itself. So first of all, it's written math tools. So in math tools, we can see graphing calculator, scientific calculator, 4-function calculator, and matrix calculator, geometry tool as well. These are also available on the mobile applications. You can download in your iOS platform or the Android. On iPads also, it works fine. In the classroom, which will come at the end for the last 20 to 25 minutes, resources for you to learn. So you can actually go to Help Center if you want to learn anything. And let me start with the graphing calculator first of all. And if I scroll down, you will see these options for classroom only. Classroom, I mean to say the Desmos activities. So this is for the student and this is for the teachers. Desmos also have their own curriculum. They're based on the US curriculum for middle and high school. If anyone is interested, they can just connect with them. So, but our focus will be on how to integrate Desmos in our math lessons. And I will be covering middle school to high school things. And if you have any specific thing to ask, please ask your question in the chat. I'll get in touch with the host. So let me go first of all to the graphing calculator. So if you click on that, you can see this is the graphing calculator, very similar to the Geogebra you were actually seeing in the previous session. But Desmos has its own platform. So definitely everything you can do in Geogebra cannot do here right away, but you can definitely explore the options here. So first of all, it's very similar to the Geogebra. You type anything, let's say y equals to x, you will see the graph. You click on the settings and you create the table. Immediately you have the table ready. And what you can do with this, you can go again back to the settings. This is the setting gear, I'm calling it. And you click on it and you click on the color, you change the color. You change color of points or the line, the way how you want to decorate it. And you want to show the line or only the points. That is also possible here. You can increase the thickness. You can also increase the thickness of the points if you want. Definitely, you can make the lines dotted and a proper line. So these things are very basic. You can actually do with the setting tool here. If I enter again y equals to x, you can see the line is there. And let's say you don't want to see the line and the points in the same color. You can change the color either of the line or of the points. So go here and change the color. And here you can hide the line. So what will happen in this case? Points are visible from the table. The line is visible from this graph, y equals to x. Same thing you can do with any type of other functions, trigonometric functions. Let's say you have sine x and you have e to the power x. So all types of functions you can definitely explore. The good thing is you have a graphing tab, I mean to say the keypad, which can be used to enter any type of function, inequalities, or other things. If you can see here, this is function tool. Click here and you can see all the functions are available for you from the statistics, distribution, miscellaneous, integration, everything is here. You can create a list. You can find out the mean, mode, median, whatever you want. So I'll go in brief because I'll not go in detail for everything. But the beauty which I want to explore here, or I want to explain here, that would be using of sliders. This is the plus button, first of all, to add any type of item. I'm just adding a text here and I'm just writing using sliders just for you so that you are aware what I'm using. Using sliders means I can use any alphabet, A, B, C, etc. to have my sliders. So let's say I want to enter y equals to mx because m I'm considering my slider. So I just entered m times x and I'm done. As soon as I click enter, my slider is ready and I can play with my slider here. Look at this. It's moving from -10 to 10 and we can see the live changes in the slope of the line. You can increase the speed of the animation. You can slow it down. You can only have in one direction. let it be. And you can also control the step size. Let's say I want to see from 0.1 and minimum I want -1, maximum I want +1. If I play now, you can see this. Look, so it's changing with the equal steps of 0.1. And if you don't want to play the slider, it's okay. You can just drag it. Look at this. Drag it and use it for your class, for your lesson. Same thing you can use for, let's say I'm going to use one more. Y equals to mx plus c. Now I have two sliders, m and c, right? I can play with m. I can play with c or m, whichever I want. So both sliders are ready for me. Again, as I said, you can always change these colors and make the lines thick enough to see. And you can also create a new color. I'll tell you later. That's not really important here. So yeah, so the first thing is using sliders. That's really, really important if you want to make use of Desmos. Let me give you more examples of that. Y equals to sine of, let's say I'm using the same slider mx. Now I'm going to hide my line because I don't want to see the line anymore. I want to see the function sine x. Let me just hide the points also. So with one click, you can hide and unhide. Look at this. Now, if I run the slider, you can see. See, because I have given command only one direction. So I can repeat it. Now it will make a loop and I can increase the speed. So this is really great thing to do with the sliders. Very easy to do. What else you can do? Let me help you out here. Let's say you have, let me hide it. I have 2 points, A and B. Sorry, 1 point with A and B, and another point is C and D. I'm just entering C and D. It will ask you add slider. Click because C is already there with us. So let me delete M because I don't need it now. And now I have 2 points. A, B, I can actually label it here. I can maybe mark as point A, and CD I can also mark as point B. Let's say I want to create a line through these 2 points, right? So you can use your any concept of creating a line or a segment, right? But the thing which I want to tell you is the way how you can actually play with those 2 points, because you can drag them. So what I'm going to do, I'm creating the line through those 2 points, not D minus C, D minus B over C minus A times X minus A. Sorry, C minus, yeah. So what I'm missing, A, B, C, D, D minus B over C minus A. Yeah, missing B. Look at this. Now I have my line, which is going through 2 points. So I can drag these 2 points anywhere and I can play. I can fit this line to any particular slope or at particular y-intercept. Same thing you can do with the parabolas, you can do with the trigonometric functions. But the difference is here you were able to drag points. But the same, yeah.
Can we give some small exercise for them, whatever you have done till now?
Yeah, I will give in the form of sliders, definitely. Yes.
Yeah, so give some, just orally say and let them.
Okay, so you want to let them try now or?
Yes,
later?
now itself.
Okay, fine.
Just
Cool.
a small one.
So the exercises, I'm writing here in the form of text. I hope you guys can read it and you can see what I'm writing. So create a line using 2 points. Okay, one slider as a slope and a fixed point. Like the line is going through a fixed point and the slider, because you can change the slider. So the slider should show me only the values of even numbers. Even numbers, I mean to say, let's say in decimals, 0.2, 0.4, 0.6. So this is the exercise. Those who are here and can access to the Desmos, try to do this.
You can give them 2-3 minutes to try.
Yeah, definitely. I will just write few notes here so that they can understand what I meant. So I need a slider, which is M, and I need a fixed point, which can be anything.
Yeah, that's good.
Yeah. So if someone has done anything, please, you can speak up and tell us.
Yeah.
Or write in the chat.
We can ask them to share their screen.
Perfect. Yeah, definitely.
If somebody is doing it. So please try, and as when you are able to draw that line with a slider slope changing, but passing through the 0.23, please say yes in the chat box, and you can then share your screen to show everybody that you are able to do it.
And in the reverse manner, after doing this, if you have some question, please do ask. I will show you how to do that.
So please try, because these things are best learned if you are doing something.
Correct. Now you can see my green line has a slope of 2 and is passing through the 0.34. But the task was do not use a number for the slope, rather use a slider. If anyone has done it, please write in the chat. We would definitely love to see that. Great. So Aniruddha already finished. You want to share the screen? Aniruddha, if it's okay, if you want to share your screen, you.
Yes, he is doing it.
Richa also done. Perfect. Cool. Yeah, I can see that there's a point which is 2.3. Could you mark on the label of 0.23?
Yeah, sure.
Click on the label. Correct. Now you change the slider, please. Perfect. Perfect. Can you show me the slider settings? Just click on the slider here. Perfect. Absolutely correct. The step size is 0.2 and the slider is starting from 0 and going till 1. Best example. Yeah. Can you change the color of the point, sir? Only
Yeah.
the color of, yeah. Go to the settings. Perfect. No. Yeah. Click on the color. Mark it orange. Cool. That's it. You can increase the label size to have the label in bigger in size. Change into 2. No. Yeah. Here. Change to. Write down 2. Yeah. Look at this. The letters will become actually bigger in size, and you can also play around with these things later. Yeah. Thank you so much for sharing this. Yeah.
Okay.
Yeah, I can see maybe in the next task I'll definitely give you another opportunity to share your screen, guys. Okay, so here I am now. Let's say you have done something and you want to save your work. Please save it. Click on save. Give a title to this this graph, let's say lines, using 2 points, and save it. Make sure if you want to save it, you should have your account like this. And let me tell you one thing. Click on these three lines, sorry. You will see there are lots of graphs which are available from Desmos itself. Desmos itself. Let me show you. Those are in high school teaching. So let me show you one with the gradients and the tangent line. Here, the tangent line. Look at this. It's very easy to do. What we are doing, there is a curve and there is a tangent through this point. You drag this point, the tangent will change. So this is actually a very nice demonstration what you want to show on a whiteboard using the curves. But demonstrate using technology, that would be always great. A better visualization would be there. So like this, you can explore, you can save this also. You don't need to create, you just learn from this. Look at this, how you can actually use this. Look, we are not showing the dx function here because that is the derivative of fx. Rather, we were just using the point A and using the slope of GA, value of GA. Look at this, because G is the derivative, x minus A plus f of A. Same manner, you can always try. I can show you some of my things which I have done, and which if you like something, let me just know. I will show you how you can do it quickly. Let me show you this area between two curves. It's a very old thing I have done. I'm just playing a slider to change the limits. And I can show regions covered under two curves. Look at this. If my limit is here, look at this, the area is between them. Now, if my limit is here, let's say 0, because I'm just changing only left limit. So this way you can actually play around. And other things, what you can see, you can create a very good art from this, just showing you for reference, otherwise not required. Look at this. This is the art piece you can create using only lines. You can use, I'm using a parametric equations here. So using parametric equations, I can play around. I created a limacons for that. So this way you guys can actually create. Let me create a new graph for you. And let me introduce one more thing, which is in a minute, you can create so many points. So there is a new feature in Desmos to control the graph. Okay, let me just show you that first. Let's say I want to see the sin x graph, but I want to see for a particular range, particular domain, you can say. I just want to see from 0 to 2 pi. Look at this. So my graph is only visible from 0 to 2 pi, right? But
Satwinder,
yeah,
I just wanted to ask you, people know probably in GeoGebra how to enter the symbols less than or equal to and pi and so on.
Yeah.
Here, how do you enter by this?
Same manner. You can use your laptop keypad. You can use the Desmos keypad here. It's always there.
Yeah. Okay. Fine.
Yeah.
So,
square root, powers, everything is available here.
Yeah. Fine. Go ahead.
So, guys, the thing is, if I enter sin x, look at the difference in these two. The difference in sin x and sin x from 0 to 2 pi. When I'm using the curly brackets, I'm controlling my graph. If I'm not using my brackets, I'm not controlling my graph. Look at this. I hope you can see that and you can control it. Now let's play around. Let's play around. What else you can do? I don't want to restrict to 2 pi. I want to move my graph as I move my slider. So I'm going to create a slider. Let's say the slider is K. Okay. And now I'm going to change the slider. Look at this. I'm moving my slider and my curve is going. So I can stop at any moment, right? Definitely you can convert in the multiples of pi, let's say K times pi, right? I just entered Ti In GeoGebra also, it will definitely consider. If you type pi, it will convert pi. So pi. By default, Desmos calculator is on radians. You can always convert into degrees for those if you are interested. But for that, you have to change these settings. I'm just changing 720 to 720, right? And I can change the steps, let's say 90. On y-axis also, you can change. So here, let me just remove it now. And let me take the values from 100 to 500. So now my slider is starting from 100 and going till 500. So you can see this. Okay, can someone tell me how can I show the end point of that graph? As I'm moving the slider, I want to see the point on the graph. If anyone has idea, please write in the chat. Otherwise, I'll show you, because that would be really informative for the student or for the users. Okay, somebody has. Yeah, okay, you are using sin k. Yeah, that's correct. So you can use k comma sin k. Look at this. Now you don't need a slider there. You just, okay, let me just move it back and drag the point just from here. It's amazing, right? Look at this. So I'm just not using slider from this view. Rather, I'm just using this just to move my graph in any direction. Sorry, I think.
No, it's okay. Somebody, Rajesh Kumar, please mute yourself.
Thank you. So this way we can actually play around with this slider. I think this was really helpful. Now let me make it more informative for you guys. What I'm going to do, I'm going to create a new thing. Okay, I'm writing here for you. I did curly brackets or to control the graph. You can control the graph from both directions. I'm just showing you in one direction. Another one, I'm going to use the square brackets. This is for list. To create a list, I'm going to create a list. So L is my list. Okay, L equals square bracket, just like a sequence. You start from a number, let's say 0, 2, 4, etc. like that. You just enter 3 numbers. It will recognize the pattern. Now, where you want to go, the last number would be, let me just enter 20 or 30, 60, because we are dealing with angles. So I'm just using multiples of 30. And I'm going to use the number 3 dots here. 1, 2, 3. And then last number should be K. Now what's going to happen with this? If I use L comma sin L, look at this, what happened. Now sin has taken all the inputs of L, and L is a dynamic because I'm using K as my slider. Look, if I don't use this, if I just leave at 90, my points are limited. But if I'm using K here, now my points are dynamic because I can change the range, the last value. Let's just mark the steps here to be 30 and start from 90. And let's just talk about 630. Now look at this. Let me bring it back here. Now you can see this. Look at this. I think this is making more sense. What you can do, you can also click on the label. You will be able to see all the points. So this is really helpful when your list is changing. Look at the number in the sequence, 16, right? And if I go forward, my numbers are changing. 18. Look at this. So this way you can play around with 2 brackets. the curly and the square. Now, the task is, guys, if you are here, please note down the task. The task is create a parabola. Okay, parabola from -4 to 4 with a dynamic slider to change the x value. As the way how I'm doing it, using this slider, I'm changing the x value, right? Here, my values are till 120 only. So now I should be able to drag in a similar fashion, but I should not get the trigonometric function. I should get a parabola. The parabola can be standard parabola, just x square. I don't mind. So if somebody is doing, please do it. The minimum value should be -4. The maximum should be 4. Meanwhile, if you guys have any question, please ask. I'm going to give you 1 minute. If anyone has done, please write in the chat. We would love to see that. You can use the function notations. Actually, it's very thin because we are using the degree system. So if you want to play around, let's say a comma f of a, that's how you can do. Which means you will be able to see the point on the curve using a comma f of a. Anyone has done, please say yes. Otherwise, we will move because there are lots of things to explore. I know I will not bombard so many things to you because I want to give you enough time to also practice and then come up with the questions. Curly brackets to control the graph. I didn't give you the task for the list, but it's okay. It's optional for you. Okay, if no one has done it, it's okay. We can actually see those things later. Now I want to move to the next part, which I'll definitely go back to desmos.com. And in the math tools, very brief, matrix calculator. Very simple. Just enter any matrix. So click on a new matrix, right? Change rows and columns and enter the values. I'm just using the arrow forward button to move my cursor. So you can just use that. So let's say I have my matrix A. Click on enter, this button. Now what you want to do with that, you can do A square, definitely. Enter A and square of it. You have the square. You want to create another matrix B, definitely you can try. Let me have a 3 by 3 again. 2, 3, 1. Sorry, let me just change these values. 1, 8, 1, 6, 7, 0. Okay, I have A and B. I want to use A plus B. Look at this. I have the sum of A and B. You can see, I can maybe delete this. You don't want, look at this now. You can easily compare and you can find out the inverse of A. So A inverse. Oh, determinant of A, let me find out. Determinant of A. Yeah, determinant of A is 0. Therefore, the A inverse was not existing. A inverse will show the warning sign. Singular metrics do not have an inverse. So we can try with B then. B and inverse. Look at this. You can see in the fractions. And to confirm, you can find out the determinant of B. Negative 37, and which is the proof here, because we are dividing everything by negative 37. So this way you can play around with this tool and make use of it for transpose for different powers. Next one is the geometry tool for those teachers who generally use the construction or compass things. But the geometry tool is available in the Desmos platform. How to reach that? Let me show you again, desmos.com. Go to math tools, click on geometry tool. So we are on the geometry tool. There is a setting gear. Click on this and show the grid if you want, because it will make your life easy. And you have things here: select, point, circle, polygon, angle, segment, etc. Let me create a polygon quickly. So I have a polygon. It's very similar to GeoGebra now. So bring it back. Now my polygon is ready. I want to find the angle, right? Definitely you can label these points. Go to select, click on the more tools, click on the point and show the label. You can change the color if you want. Click on next point. You can hide it if you don't want to see this. Look, unhide, hide. If you hide it, you won't be able to drag it. Remember this. The black point is B. Let's say the third point is again black, which is C. You can also lock. So if you lock, which means I'm not going to drag it, right? So look, I can only change point A. I can only change point B. I'm not able to change point C. Now, what you can do with this, you can calculate figure out the angles, click on angle. The instructions will come here. Choose a point. Let's choose a point C. Choose a point vertex. Oh, sorry, it was the vertex, but okay, fine. Let's go with A. Choose another point. So just select 3 points to get the angle. Look at this, the angle is 90 degrees. Now you change it, angle will definitely change. So this is a good practice for students. Let's say you, because you can share these links with your students. You create an exercise and create a task using this. Drag these points in order to create an isosceles triangle, something like that. So that way you can definitely try. And you can demonstrate these angles here. Okay, I have 2 angles now. So if I change anything, I can see my angles are changed. Now you can definitely try the midpoint, parallel lines, perpendicular lines. Let me show you this perpendicular line. It's written here in very light color, line plus point. So if I click on the perpendicular line, I need to choose a line to set up the slope. So I'm gonna select this. Now choose a point. So I'm gonna click here. Look at this. I can go to select if I want to move this. So this is my perpendicular, not a bisector, but definitely you can create a perpendicular bisector. Let me delete this, right? And let me delete this point as well. In order to create the perpendicular bisector, better you create a midpoint. So midpoint of this line is here. So midpoint is ready. And now I can go with the perpendicular line. So click here and click on this point. Look at this. Now this becomes my perpendicular bisector. Same way you can practice for the other line, midpoint, and go to more tools, perpendicular, and here. Right. Now you can actually see the point which is here. You can use it for different properties of, because if you move, the point will also move. So you can explore under what conditions this point will be outside of the triangle, right? Under what condition that point will be inside of that triangle. So you can play around with this. Arcs you can create, factors you can create, lines you can create. Just click on a line, you will get a line. Simple. You create a square, rectangle, etc. So the way how you can actually use the other tools, same way you can create here. Now, what I want to show here is transform. So I have this transform function. Yes.
So Twinder, can you give them some exercise so that they get a feel for doing things again?
Yeah, definitely.
Probably, I think you can give them how to draw the incenter for ABC.
I'm just writing in the chat, guys. If you can see that the task is in the chat. So the task is use a circle and set up lines in order to prove the angle in semicircle is right angle.
Good.
Is right angle. So you should be able to move the center of the circle. You should be able to change the radius of the circle, but the angle should always be 90 degrees for that. So if anyone is trying, please do that. Meanwhile, I'll just create some circles for you if that may help you. So look at this. I have this. I can go to show grid. Click on a circle. Click on any 2 points. You have your circle ready. This is what I can help you out. So if you guys are trying, please do this. Similar manner, you can also play with the properties of triangle. Or the basic thing what you can do. If you're not able to do this, draw a perpendicular bisector of line which is 6 units long. I'm writing that as well. Create a perpendicular bisector of a line which is 6 units length. This could be the basic one. If anyone has got the solution, please do mention in the chat. We would love to see that. Great, I can see somebody. I have done the circle exercise. Thanks, Aniruddha. Okay, let's see what you have done. Let's inspire other people. Cool. Could you share your screen? Okay. Could you explain how you did it?
Yes. So I fixed 2 points first. So this point and the other point, and then I drew a line by choosing these two.
Yeah.
Oh, sorry. Actually, I drew a circle first and then the line.
The line. Yeah.
Yeah. And then I just arbitrarily fixed a point on the circle and then drew line segments. from this point to this point, and then here.
How did you measure the angle?
Using this angle thing.
Using the angle tool?
1, 2.
Cool. Can you move any the point on the circle's
Yeah.
circumference? Cool, guys, look at this. See, using this simple thing, you were able to do that. Perfect. Let's see from Anaga as well.
Okay, I have stopped sharing.
Thank you so much. Thank you,
Thank you.
Aniruddha. Yeah, Anaga, if you would like to share your screen, that would be great.
Hello.
Yeah. Yes, we can see your screen. Perfect. Yes, you have done it. But your circle is also changing, right?
Circle.
Yeah. Like the radius is, yeah. So somehow you have to fix things so that circle should not change when you demonstrate the 90-degree property, right? Can you, can you move the point again? Yeah, look at this.
Circle is changing.
What you can do, lock free point. Click on the lock on the left hand side, left hand, bottom, left, bottom. Yes. Do same thing for the other point. Now you move your points. These things will not change. I think your center is not fixed. That's the reason. Somehow it's yeah, it's okay, but yeah, definitely you tried and it came out well. And I can see the triangle you have shaded. That's a cool thing because you have used the polygon, not the lines, right? Yeah. Thank you so much. It's a great thing. Yeah. Okay, guys, let's continue now. I think if someone else would like to share something, please go ahead. I don't mind. I know we have hardly 15 minutes left, and I would love to jump to the amazing tool, which is called the Activity Builder. And the beauty is, you guys, you don't need to create your activities. There are plenty of activities which are created by so many great teachers already who are using Desmos on a regular basis. So let me show you how you can access those free activities and you can make use of them. So here I am on the desmos.com. When you click on the teachers page, browse activity. And here, maybe it will ask you to sign in again. So make sure you have signed in. Look at this, my account. Here you can see there are activities available for you. You can click on most popular. You can click on the featured collections and you will see there are activities, most popular. This is like the amazing activity, land plane. So see, I have used it from 2019 to 2021. So with my students, let me show you how student will feel it. And I'll also show you how you can just to give this activity to your students. I'm going to go to the student preview and go to the full screen mode. So read, this is the investigation of the slope and intercept. So move the plane so that it lands safely, which means plane can only go like that. So once my plane is set, I can click on submit. Look at this, lines are, so the lights are red, which means it was not correctly placed, right? So this way, students, now I'm going to give them hint. The line is 15 minus x. So student will know, okay, I should mark it as 15. Now it will land safely. So student, they will love using these type of activities. If you have that flexibility at your school or institute, make use of laptops. Of course, you can try on mobiles, but I will not recommend. Look at this now. I have to change the slope of line in order to land the plane safely. So first of all, my -7 is correct, but I just need to figure out my slope. If I remove 1, I can see my line is coming closer. It means I have to go further. Okay, 0.7, 0.6, 0.5. Yes, it's correct, 0.5. So let me just run it. Like this, there are many activities. Okay, and you can access them free. You can also change language if you want of that content. Now, how to do it? How to figure out which activities are based or which you want to use it? Let's say you are teaching algebra. You just type algebra here in the search box. You will find there are activities using algebra, right? So also, if I have created these activities, it will appear on my page. Otherwise, you will be able to see only which are available only from the Desmos, because Desmos allow you to add your activities. So let's say I want to use this activity, which is on the domain and range. I have this activity for domain and range, and it is created by the Desmos guys, and I can use it. How to use it? What you have to do, there is a assign button. So click here, create a single session code. If your institute is allowing your students to use your email IDs to create accounts, you can also create your classes, right? Otherwise, you just add this single session code. Let me just give you this activity. Create invite code. Once you have created, look at the date, December 17, and it will active till December 19. So I can click on the view dashboard. And what you have to do, copy this code. I'm doing this. I'm sharing with you guys because I want to show you the beauty. So guys, please join. You don't need to sign in. Follow the link the same way as you are going to give to your students and join this activity. I would love to see you here. As soon as you join, I will see my students on my left-hand side. Perfect. I can see Aniruddha. I can see, yeah, perfect. Jitendra, Siva, Prakash, perfect. Guys, I can see your names now. Similarly, you would be able to see your student's name. If you want to hide it, don't worry. There is a way. Look at this. Just click on this. Now your names are changed to some mathematicians. Now your students are becoming mathematicians. So now if you start any activity, let me click on the actual name. Jitendra, can you move to page 3 quickly on the next, using the next button? There is a next button here and you go to page 3. Yeah, look at this, guys. If a student is still on page 1 and there are some students on page 2, page 3, I can see them live in my class. What they are doing, where they are stuck, I can send them feedback. Let me just click on, let's say, Jitendra on page 3. And I can see, oh no, Jitendra, this is wrong. What I can do, I can send this message. Look at this, lesson feedback. Guys, you need to pay attention here as well so that you can see how to use these features. So I can use this tool, lesson feedback, and I can say, Jitendra, please complete this, or just give a hint, some sort of hint, whatever you want. And the beauty is you can click on this type math, because you will be able to type any expression. Let's say x power 2. How did I get x power 2 or square root? You just type sqrt, it will convert in square root. If you do x and then on my keypad on letter 6, there is the top arrow, right? I'm using that to have the power like that. So I can send the feedback. Now Jitendra must get the feedback there. And how I know? Because look at this, there is a small corner is there. Jitendra, can you read it and move forward? Let me also give this feedback to somebody else. Look at this. Santosh Kumar has done page number 2. I can see the tick because that particular question is correct. Now, how based on Jitendra's work, sorry, Santosh's work, how I can help my other students? Teachers will have this access to the camera. Click on the camera. The snapshot will be captured. Turn off. Now go to snapshots. As a teacher, I'm saying, as a teacher, you go to snapshots, drag this here, and ask your students, hey guys, come on, have a look. We have a solution for this. So now you demonstrate. This is the work done by one particular student, and this is correct. Now you can discuss what are things they should actually pay attention on this. And this way you guys can actually engage your students and allow them to use technology in their classes to enhance their maths understanding and the visualization, right? Look at this. Now somebody has done it incorrectly. I can see the cross, which means I can ask them, hey, could you go back and correct it, please? Right? So this way I can send feedback and I can ask them to correct it. Please correct it. Or use your math notes, right? Or use the lesson from that. Look, if this is green, it means the student hasn't read the feedback. But when Santosh will come back to that particular page 4, and if he is reading that feedback, then it will turn to gray. As in case of Jitendra, it turned because Jitendra read at the same moment. So this way, guys, you can manage your class. Oh, one more thing, you can pause the activity. If I pause this activity, nobody will allow to go further. So this way I can control my live lesson. Students will not be able to do anything. I click on pause. There is another feature. I know I'm running out of time, but just one more minute. I can click on pacing. Pacing means you can control how many slides student should finish. So I'm going to click on this and I'm going to click on 6. So my students will play around only from slide number 1 to slide number 6. They won't go on slide number 7 because it is restricted. So this way I can control my class. I can go to the teacher page to see my collective responses on different pages. Look at this. I can see 5 responses. If I go to page 4, I can see more responses. So I can see the summary here. So guys, please explore this. And thank you so much. You participated. And that's the great thing for us. And see you tomorrow for the advanced session of this. And I would like to thank to Rana sir, who gave this opportunity, and happy actually, okay, stop sharing first of all. Yeah. Thank you, sir. Yeah.
Thank you, Satwinder. If anybody has a question to ask, we will have 2-3 minutes.
Definitely, I can
any queries,
answer those
questions you would like to ask for today's session?
I don't know if you allow me, but I can share the YouTube link for my channel.
Yeah, put it on the chat.
Yeah.
Please.
Thank you. So guys, I have a channel for GeoGebra and Desmos. You can make use of it. Subscribe. Mention in the comments what you would like to learn. There are playlists.
So if nobody has a question to ask, we'll close.
I will drop off. Thank you. Yeah.
No, we'll close the session and start the next session at 4:15. Soumya?
Yes, sir.
Yeah. So we'll start at 4:15. That will be paper presentations by teachers. So please stay connected till we start the next session. You can go and have a cup of tea or coffee and freshen up and come back.
Thank you, sir. See you tomorrow.
See you tomorrow.
Bye-bye.
Yeah. Take care. Hello, Santanam ji. Do you have two devices with you? मेरा वीडियो
Chanchal Das is here.
Yeah. So he has two presentations, right?
Yes. Welcome, Mr. Chanchal Das. So we start the session exactly at 4:15. Okay.
Yes, that's right.
Yeah. Time is 4:10. Another 5 minutes is there, Mr. Chanchal Das, for you to relax.
Yeah. So you have 4 presentations in the first 1 hour, right? Janaki will be joining soon. She said she is finishing a meeting in the school.
It's okay.
Yeah.
So 4 presentation in 1 hour, I think.
Yes, 10 minutes each.
Okay, okay. Then I will try to make it within 10 minutes. Okay.
You have
10 minutes and 5 minutes question and answers.
Okay, okay,
No,
okay.
that is maximum 5 minutes because switchover will be there. So
yes,
about 2
Okay.
minutes for question answer and then switch over.
Okay, sir. Thank you.
Yeah, sure. Let me just check other people are there in the session.
Yes.
So I can share my screen also, no?
Yeah, wait till the chairman.
Yes, yes. I know it.
Yeah. Sadaf is there.
Yes, sir. Yes, sir. I'm there.
Yeah, you are there. Then, who is the 4th person? That is slot 1.
Manjushri.
Manjushri is there.
Yes, Manjushri.
Yes, yes, I'm there.
Okay, so
Nandini is there. Nandini
Yes,
and
yes, sir, I'm there.
that's fine.
Yes, sir.
Imdad Ali.
No, I think that he is not in this slot.
They are in the slot 2. You see?
Yeah, these four people only. They are ready. No.
Yeah,
I think we shall start the.
So let me just tell. Chanchal Das is 1. Okay. And the second one is Sadaf. Okay.
Yes.
And the third one is Manjushri.
Yes.
And the 4th is Nandini.
Nandini. That's correct.
4 are there in the slot 1.
Yes.
That is 1 hour. Okay. So please go ahead.
Please go ahead, Mr. Chanchal Das.
Okay, sir. Thank you. Thank you, sir. I am sharing my screen. So, is it visible, my screen?
Yes.
Okay, thank you. And myself, Chanchal Das, and I will be presenting a paper on nothing abstract in abstract algebra. To some extent controversial title, but this is something written about me. And actually, this is the thing what I want to do. I don't want to exactly present on abstract algebra. I want to present that we can change the perception of mathematics, like from formulas, equations, and symbols. We can go for geometry to make mathematics more approachable and easy to learn. So that is my objective of whole activity, whatever I am doing, and this paper is part of that. So here I have written how to use technology to teach mathematics. That is my main objective of presenting this paper. So my paper presentation will, these points will cover. And now going by definition of abstract algebra, it comes to the first with a symmetry. Means origin is symmetry. Abstract algebra, what I should say, that origin is symmetry, and so many things we see in everyday life. But there was no definition of symmetry 200 years ago, I should say, and 200 years ago, we got some definition of symmetry from algebra, not from geometry, not from art. And this is the main start of abstract algebra. I will be presenting on that. So abstract algebra, the study of groups that originated from symmetry of algebraic equation. This is the main thing. It is not from this visual presentation. It is from algebraic equation. So we should understand what is this algebraic equation and how they related to abstract algebra, and what is the relation between those two things and symmetry. So symmetry, now it is defined as the transformation or operation that preserve the structure and so many things. That means if we rotate something, it remains same. These are the definitions. But what is the definition? And this definition also here, abstract algebra deals with structural feature of numbers. And this is also one thing confusing. So let us explore more about that. Now we know that this quadratic equation, Babylonians solved this problem 4,000 years ago. I had a issue for believing on that, but now I confidently believe that yes, they had this solution in 4,000 years ago. They are so advanced in mathematics, similar to other civilization also. And cubic equation, if you see, Archimedes was working on cubic equation around a cylinder, sphere, cone, how from a sphere, how many cones and cylinder, big size, small size can be made. He was studying on all those things. And Omar Khayyam, he has solved this cubic equation in almost 1,000 years back. But there is a color code difference between these two. Color code means subsequent, this 500 years back, this Pero, Fontana, Maria, Cardano, Bombelli, they are all they are also working on solving equations, but there was a characteristics change in these two approaches. Earlier, these approaches was geometry based. There was no algebra at all before that. So I am talking about 1,000 years back. And after that, all these things, they are related to algebra. Now, this was the thought of Omar Khayyam cubic equation. He told that this is a one circle and there is a parabola, and this intersection point gives a real root of a cubic equation. We can get one real root from this. So this was entirely geometry, not algebra. But subsequently, it was his description on that geometry, and he reached some numbers which now we know that it is complex number. At that time, complex number was not there, so he thought he may be mistaking somewhere. And these are the relationship between the coefficient and roots of any equation, and this is well established, and it is for applicable for any degree of polynomial. And these are some examples I have given, and these are the things for a quadratic equation, power 4. So this algebraic equation solving, when this cubic equation solved, everybody was thinking that polynomial of any degree can be solved. So this effort was going on, and quadratic equation was solved by Ferrari in 500 years back. And in doing so, this last two things, 200 years back, they told that there is some issue. And what is that issue? If people was thinking that, as we know that quadratic equations have two real roots, sometimes we get imaginary roots. So geometrically, I have shown this can be done all in Excel. And quintic, there will be 5 roots, but there may not be a formula for solving these roots. That is the issue. So what was the problem? This is, we can say, as a trap, because many people spend their whole life in getting a formula for solving polynomial equation of any power. So this was the two guys who first hinted that there is a problem and it cannot be solved. And you can see that these guys are only 27 years old age, and he died, and he was only 21 years of age, Galloway. And he told what he told, let me explain that. This, whatever they are doing, all these things can be shown geometrically like that. I have shown some scalar multiplication of thing and how geometrically it can be represented. The same thing we can do with any point, and scaling, reflection, sharing, rotation, all these things we can do with in Excel, and it is very easily can be done. So this is the formula we should get for a root, and this they told that it should be symmetry. But what is the symmetry? That is to be get cleared. So here I have given some example, a square with when we rotate in 90 degree, it looks similar to the original 180. Also it looks similar. So it 270 also similar. So we can say that it has 4 transformation symmetry. 4 type of transformation we do, and it remains same as earlier. Similarly, it has 4 reflectional symmetry. If we reflect like these dotted points, it will look same. And to identify that, I have given number codes, and we can identify from that which point is going where. So this is the symmetry, but it is related to geometry. Now this translation, rotation, reflection very easily can be done with these matrices in Excel, and I want to teach these methods in Excel. So these are the different reflection for that, and these are the inverses. These inverses also can be calculated easily in Microsoft Excel. So this symmetry also have used diagram and figures, and when it do, it becomes a tedious thing. So for that, what we can do, we can do some number coding, which can make this geometrical things is initially it is very good for understanding, but when we get acquainted, then we can go with number code. And this is suppose 90 degree rotation. So 1 comes to 2, 2 comes to 3, 3 comes to 4, that I have shown in right side, and this can be representation. So similarly, all this transformation together forms a set, and this set of numbers have a unique property. What is the unique property? This any binary operation, here binary operation means matrix multiplication, and indirectly transformation. So this transformation, whatever I do, A into B, B into C, C into R, R into T, U into A, all will be in one of the elements of this group, so on set. So this is a unique property. We will get whatever we do with these operations, it will be one of this set. So this we can form a set, and for putting this set, we can put it in a group, and groups should have this 4 properties: closure, identity element, inverses, associated property, and these are the symmetry operation of the obvious. All these property, then it will be a group. So this is a group, and here this quality will has give us a very easy way to see this what happens when B and C multiplied, B and C multiplies, we get A, and R and S multiplied, we get B. Similarly, all these elements will be the member of this set. So this group we can study, and when we form this group, we need not individually check this operation. We can collectively see what is the operation here. You can see that this group consisted rotation and reflection, rotation and reflection. So rotation we multiply, we get rotation, rotation reflection multiply, we get reflection, reflection rotation, we get reflection, reflection or reflection is rotation. So from this chart itself, we can tell that what will be the end result. And these are the things we can see many things. Rotation, what is that? This is a transformation which no flip, means it need not change the faces. But when we go for reflection, that face has to change of the plane. Plane will have to change the face. So similar many properties we can identify, and this is the actually study of the groups. And this Galois told this equation also has to be symmetric, then we can have a formula for solving this equation. And he told that this is I am going to that last one. With this observation, Galois concluded that a polynomial equation.
You have only 1 minute, Mr. Chanchal.
Yes, it is over. Equation only solved by radicals if the degree of polynomial is less than 4. So this is the thing, it will not have symmetry and it cannot be solved. So 200 years ago, we got the symmetry definition. We got another branch of mathematics, abstract algebra. And this abstract algebra, when we can approach with this way, geometrical way, it becomes very easy and understandable. So teaching mathematical concept geometrically can make mathematics learning easy and enjoyable, and mathematical modeling and animation in MS Excel, what I teach, can be very effective tool in this direction. And thank you.
Mr. Chanchal Das,
Yes.
any questions from the audience?
Can I ask 2 questions?
Yes.
One question is, you showed a matrix for translation.
Yes.
Can you just quickly come to that matrix for translation?
What is the question?
Matrix
for translation.
Yes, this is actually what my original.
Please understand, I'm asking, can you show that slide where you have where you have the translation matrix? Because the question relates to that. No, this is not translation.
Translation first.
Yes.
No,
much more before.
Before.
Matrix.
No.
More, yes, it's much before. He wrote 3 by 3 matrices for translation.
Yes.
Where is that matrix? I want to see that.
That is.
Yes. Yes.
Have you applied it to a point X, Y, Z and seen what is the result?
No, when X, Y, Z, there will be 4 by 4. It is for 2D.
Yeah, but
it is for 2D object. If 3D object, then there will be X, Y, Z.
Yes,
and
so you have to say that the matrix 3 by 3 is giving you for 2 by 2.
No, I can. That is again, I have to discuss the homogeneous coordinate system. So that time will not permit. So this is not included in.
No, at least you can mention that it is pertaining to that. This is, you are dealing with dimension 2 and matrix is order 3. So that you have to say that anyway, one line. So one, that is okay, clear. Now, what was the aim of your whole presentation?
Aim is to appraise the pupil that there is a very easy tool available. Without coding, we can animate and model any physical, scientific, mathematical.
No. Your title is about algebra.
Algebra, I am telling that this abstract algebra can be modeled and
only up to dimension 2 or 3, right?
It can be extended to anything, but that visualization will not be there.
No, how do you deal with quadratic? You can do quadratic, you can do cubic, but you can't do degree 4. How do you do it in degree 4 to say that the solution does not exist?
Degree 4 solution is there, but degree 5 and above, there is no solution.
Yeah, but even 4, is there an animation or Excel available where you show that, okay, these are the roots and this is what it corresponds to theory?
Yes, this is whenever I plot this for degree 4, we will get some plot like this.
What?
This type plot we will get when it is 4, 5, 6, 7, does not matter, no?
Right.
But I am telling this, there is a root, but we don't have formula to calculate that root. It is easy to plot.
But how do you show there is no formula to calculate? Again, you have to go to abstract, right?
No. In that case, everything abstract. So
yes, that is the beauty of abstraction.
No. I am telling it is anything math is abstract in that sense. We need not go. It is very much visual there.
Okay, thank you.
Thank you very much.
Yes.
Now,
can I close my?
Yes, please.
Yes, please.
Okay. Thank you.
So, thank you very much. Can I call upon Sadaf Saeed?
Yes, sir. So good afternoon, everyone present here. This is me, Sadaf Sayed, a B.Ed student teacher from KG Sumaya College of Education. Sir, am I clearly audible to each and everyone?
Yes.
Okay, thank you. So I'm just presenting my screen. Is my screen visible?
Yes.
Okay. Fine. So what made me think of this research? Once there was a kid in my class who had a habit of reading newspaper on his daily basis. So while reading newspaper articles, he always comes across the problems faced by us in our real life. He was very much confused, and one day he came to me and asked, "Ma'am, can't maths give us solution to our real life problems?" I smiled and answered, "Of course, dear. Maths do solve our real life problems." After answering him, I thought, why not I research on it? As I mostly use different techniques and models to teach my students, I realized that 5V model can give solution to our problems. Then I reviewed 3 to 4 research papers and found that there are not many research papers written on 5V model for subject mathematics. This made me to do research on 5V model as a tool for mathematical modeling for solving real life problem in maths classroom. Now, how can we use 5V model to solve a real life problem in our classroom? So here are the 5 stages of 5V model. First stage is engage. Approach the topic in an attractive way, enjoying it. Explore. The learning process must then explore the topic to its fully extent. Explain. Apply this knowledge to find the reasons why something occurred. Elaborate. Move forward and make predictions about other situations. Evaluate. Evaluate if the learning process has been successful and effective. Now, you all can see in the left of my PPT, I have mentioned the students' perception towards math subject. If we use 5V model as a bridge while teaching mathematics, then we teachers can achieve our achievement that is changing students' perception and making mathematics subjects interesting to them. Now, the topic of my research paper is exploring students' perception on use of 5V model as a tool for mathematical modeling. My main aim was to explore students' perception on use of 5V model as a tool for mathematical modeling. Introduction. Mathematics is an abstract subject which involves utilization of creativity, critical thinking skills, and mathematical skills to solve real-life problems. 5V model is a constructivist theory which deals with 5 stages where students are engaged in a classroom, explores new knowledge, explains the concept, elaborates the concept, and evaluates the solution. Methodology. The methodology used in this research paper is that this research paper is a qualitative research. The students' perception was taken through questionnaire, and this is one short case study. Due to time constraint, there was no treatment given to the second group. So this research is just a tryout where treatment was given to the first group and then perception was taken. So bringing a real life problem in the maths classroom, a real life problem on COVID-19 was brought in the maths classroom. Then discussing upon the problems, we found the solution using mathematics topics such as pi diagram, graph, discount, and then we analyzed the perception of the student. Now participants, because of this time constraint, the research was conducted on 30 students from reputed school, that is Michael High School, Mumbai. Sampling and sampling techniques. Sampling used in this paper were 30 students from grade 8. And then their perception was taken through questionnaire and open-ended questionnaire. The research questions were, how maths is used in real life problems? Do you feel mathematics is used to solve real life problem? Justify. Why is it essential to use maths to solve real life problems? Is solving real life problem in maths classroom interesting? Justify. Then the data analysis. After data analysis, we got conceptual clarity that 96.6% of the students felt that we already use basic concepts of maths to solve our real life problems. Then second point was active learning. 96.6% of students felt we learn maths while solving our real life problems, which was active learning. Interesting, 100% of the students felt that solving real life problem in maths classroom is interesting, as it's fun to apply the concept for real life solving real life problems which we have learned. Now these are some of the perceptions which we have taken from the students through the questionnaire. Now what is the finding of this research? This study found that there were different perceptions from the student. That is, we got a mixed reaction where most of the students felt that it is beneficial for conceptual clarity, active learning and developing interest. Then though some students felt it, maths is only used to learn concept and write it on paper in the examination hall. Now the conclusion of this study is, this study shows that adapting 5V model as a tool for mathematical modeling makes teaching and learning process interesting, where students are engaged throughout the lesson. Those students are there who have negative perception, but it's a duty of the teacher to include each and every student and make learning more interesting using 5V model. Now recommendations. Recommendation for administrators. More and more workshops for the teachers on use of 5V model as a tool of mathematical modeling must be conducted in teaching of maths. For teachers, reading researches on use of 5V model as a tool of mathematics modeling, joining discussion forums to get inputs on the challenges faced in use of 5V model in maths class. For curriculum framework, design maths textbook with content where real life problem is discussed. So thank you, this much from my side. Any question?
Miss Sadaf, no?
Yes, sir.
All the topics, what you say, is 5E model is applicable?
Yes, sir, it's about 5E model.
No. I'm asking you.
Yes.
All the topics in mathematics, can we use this 5E model?
Yes, sir, we can teach in 5E model.
For example, factorization in algebra. How will you do it?
Okay, so for factorization, if we say for engagement level, I will give them a tiles where I will see that these sides of the tile, the length is x square plus 4x, and I will give them 4 borders. That is, one border is of 1 centimeter. Then I will say that now arrange it in a square in tiles, make a distance either the sides of the border or anything. Then the equation will be 4x square plus 4x plus 4. Then students are engaged to it. Then after that, the exploration stage where the students are doing hands-on activity. So while making that tile, putting that in the order. So it's exploration where they're exploring something new, where they're using it in the life. Then the stage comes explain. Now students will try to explain it, but as the factorization part is new to them, they will only just say that it's a quadratic equation, because at that stage quadratic equation is discussed to them. Then it's a duty of the teacher to explain further that how we can factorize it, how what will happen further. Then the elaboration state will come, where a student will elaborate in the real life, as we have given this example to them of the tiles. Then they will think and they will use their mind, their critical thinking, and they will think. If not possible for them, then teacher will help out, as it's an instruction model. Then teacher will instruct them, and then elaboration stage will be over. Last comes to evaluation, where the questions can be given and the students can find out the answer of it.
Oh, that's fine. You mean that any factorization of quadratic polynomial, you see it as a length and breadth of a rectangle or whatever it is, and then finding the area has been converted into length and breadth of the rectangle. Am I correct? That's fine. Okay.
Yes, sir.
Any other questions from the audience?
I have a question.
Yes, Janaki.
Yeah, so I just wanted to know that you said that you took students' perception, no? You asked them these questions and they responded to them, where you asked them what is their perception about how mathematics can be used. But did the students go through any such that kind of problem solving in their school or otherwise, so that they could respond to these questions well, or was it just based on what they have? Yeah.
No. Ma'am, what happened? I actually conducted the class in that. I have conducted the classes on that 8th standard students, where I have brought the COVID pandemic situation, this real life problem, which is a very big problem nowadays. So I explained them. I gave them some of instructions that how pandemic happens, what is less in our body, then why it's happening. Then they said, ma'am, immunity is one of the main important where this COVID is happening. So how we can boost our immunity. So I have given, they said that eating good food or eating healthy food. So I just said that how we can eat a healthy food. So they have given me fruits, nuts, and all these things. So we have used the mathematical concept like a pie diagram over there, that how much percentage of foods that rice, chapati is used in our daily diet. Then we have used bar graphs. Then we have used discount also as well, where we have created a pamphlet over there. As we all know that STEAM should be available everywhere. So pamphlet was created for lunch boxes, where healthy food is mentioned over there. So I have conducted the classes, and after that I have taken the perception of the student on this. Okay. I have taken a class on 5E model over there, bringing the COVID pandemic problem.
Okay, thank you.
Yes, ma'am.
Any other questions from the audience? So shall we go for the next presentation.
Thank you, sir.
Thank you. Manjushri Dhume. Are you available?
Yes, sir.
Please.
Thank you. Let me share my screen. Is my screen visible?
Yes.
Can I start?
Please.
Thank you. A very good afternoon. I'm Manjushri Dhume, and my work pertains mainly to designing hands-on activities and games and puzzles to teach school level maths. And I focus mainly from standard 1 to standard 8. My paper is titled Play and Learn Maths, and it falls under the theme 5 of this conference, which is Mathematics Education Initiatives and Practices During the Pandemic. So I am going to, this is a sequence that I'm going to follow in my presentation. I'll talk about the challenges that we faced because of the pandemic and the initiatives that we took and what was the result of the initiatives. So as we all know, maths is an abstract subject and it's difficult to teach and learn. But when maths is taught using hands-on activities, children are able to visualize the concept and they are able to understand the concept better. But with the lockdown in place, the biggest question was how do we make hands-on learning possible for children? Because as a team, LearnQuest supports 5 or 6 schools. And how do we make this hands-on material available to children in their house because they just cannot move out of the house? This was the biggest question that we had. And after a lot of discussion, brainstorming, we came up with 3 initiatives, which I'm going to discuss. The first thing was that if children are at home, let them make the learning aids at home. That was the first initiative. So we redesigned our learning aids so that they could be made by children or parents at home for learning maths. Some criteria that we took into account were that there should be no need for printing or photocopying. Simple materials should be used. Tools should also be something that are available at home. And we made videos of instructional videos to teach how to make these learning aids and send them to the schools. And the schools send them to the parents. And I'm happy to say that we could actually conduct hands-on teaching from standard 1 to standard 8 over the entire year. We have redesigned a lot of these learning aids and made them available as small YouTube videos. What I'm going to share now are just a few examples. So this is a Rekenrek. A Rekenrek is just 2 strings with beads in it. So we redesigned this so that the beads are made from wheat flour, if you can't go out and buy. And parents actually made the Rekenreks and children were learning with that. First standard children were learning counting, addition, subtraction using the Rekenrek. And it became easy to even teach hands-on in the online mode because the teacher would explain by showing, ask a question, and children would do something. That is, they would do the maths and show the answer. So this was one example. The other example is tangrams. Tangrams is a very standard puzzle and normally we buy it. But we made a video to teach how to make a tangram by just pulling out a paper from a notebook and then folding it and cutting it. And then we use these tangrams to teach about shapes or even concepts like fractions, percentages. Some very important foundational concepts of place value, of addition with carry, subtraction with borrow were taught and learned by children by actually doing hands-on through the online mode. You can see over here a child, they have drawn that place value house and they are using Rajma beans. So this was the first initiative. The result of this initiative was that we actually concluded that it is possible to teach hands-on maths through online. And this is the feedback that we have received from teachers from various schools. The advantage of this is that since some of these lessons were converted into video lessons for supporting the schools in conducting the lessons, children could go back to it again and again and revisit at their own pace. We have the second initiative was to convert some of our origami lessons into video lessons. So we also there are many lessons where geometry concepts are taught through paper folding. Now, how do we take this to children during the pandemic? So we made videos which have questions embedded in them along with the answers, and it's like it's an entire set where there's a video, there's a question answer, again there's a video. So what happens is it becomes a self-paced kind of a lesson where children are making, they're exploring, they're understanding, and they continue. And the end product is something very interesting because you end up by making an origami model. So let me show you some examples. Say, for example, the first row, children actually folded and made these geometric shapes which have linear symmetry. Sometimes they folded and cut so that you have rotational symmetry. They arranged these pieces to make a rangoli. Or in the second row, children folded and then they studied and explored the angles after they folded. And then further the lesson went further and made a model of talking lips. Or for example, over here, children actually explored the angle sum property of a triangle by folding triangles, and then the triangles were used to make a flower. Basically, there was a lot of engagement in the children and exploration and learning in this process. The last row, there was exploration on parallel lines, and afterwards they folded and made a Diwali lantern. So this initiative, we found that origami can be really a very powerful tool to teach geometry concepts, and children get a very
देना था पेपर बुक्स का वगैरह डिटेल्स वगैरह, तो इसके लिए मैं आई बोला
हेलो
चलो फिर लंच था। अभी मुझे याद नहीं।
Can I continue? I think somebody has to mute. Okay, I'll just continue.
मुझे याद नहीं अभी तभी।
Thank you. So this was the second initiative, and I'll move on to the third initiative. In the third, actually, as a group, LearnQuest has a lot of puzzles that are given to schools for revising maths. And this revision happens in a playway method. But again, puzzles were not available in a physical form, so we converted them into an online mode. That is, they were made as digital puzzles. They were aligned as per curriculum with varying degrees of difficulty. We took a lot of inputs from teachers for designing these puzzles. I would like to show a very short demo of the puzzles because these are available for all children to play and learn. I'm going to stop sharing this and I'm going to start sharing a small demo. Learnquest.co.in, that's the website. And over there, when you go to Fun Corner, you can click on Login and enter the site. There are puzzles for every standard from 1st to 8th. Let me show you some games from fraction chapter. Some of these games have a lot of help. For example, if you click on this first puzzle, we have to match the fraction with the picture. But if children make a mistake, then we have a video which pops up and explains the concept. So a child can correct himself or herself. Okay, in this puzzle, you have to match the correct answer to the question. And if you make a mistake, then the puzzle tells you that by highlighting the border blue. Then you correct yourself and do it again. In some puzzles, like for example in this quiz, you get the explanation as well. If you make a mistake, then it tells you what is the correct answer. In fact, if you don't do the quiz and you skip, then you can actually review and find out which questions you got correct, which you got wrong, and what are the correct answers. So you can learn this way. In the sorting puzzle, you have to actually put the pieces in the right bucket. If it's correct, it becomes green. If it's wrong, it becomes red. So you know that you've made a mistake. So these are all puzzles where children are supported. There are post-tests designed for some chapters. So after you finish that chapter, you have to test yourself by answering these questions. And once you finish answering all the questions and you click on submit, the puzzle tells you which areas you have done correctly and where you have made mistakes. So you can go and play those puzzles again. The tick marks on the left-hand side tell you which puzzles you have solved correctly. So this is a very short demo, and I'll go back to my presentation. The feedback for the puzzles was also good, and children really enjoyed because they didn't feel as if they are studying, but they were studying. And so with these three initiatives in place, what we realized is that online learning and teaching can be made effective and engaging, even with physical hands-on activities. Children can make them at home. Now with the new education policy, where play way method is what is recommended from 3rd to 5th, it can become very affordable for schools to make these learning aids and use them. A strong management support is necessary. This was what we felt. But all the online resources which are made during the pandemic will serve as a very good resource in the years to come when blended learning becomes a norm. So this was the conclusion that we had. And I would like to stop here. My time is up. And answer any questions.
Yeah, so nice of you. Do you think that such type of things are not available in the net?
No. So let me stop. Sir, these are available. Yes, they are definitely available. Let me tell you what was the rationale behind making them again. Yes. So there were three things that happened. One is that schools were used to certain types of puzzles where I went, like pyramid puzzles. They were standard puzzles that they knew. And they actually used to make those puzzles themselves. So when they now found it on the internet, it became easy for them to relate, for the teachers to teach. Secondly, it became engaging for them. Like it's a comfort level that you know these puzzles. And the third thing that I was doing with the site is I started giving reports to school on the schools used to use this as a homework. And from the back end, we used to give schools the report that which child has done which puzzle correctly and where they are going wrong. So this was like, because homework checking became very difficult during pandemic, many schools did not have in check homework, and this became an easy way to help the schools, but only for maths. Yes.
That's fine. Thank you.
Yes. Thank you.
Any question from the audience side?
Sir, may I ask? Sir, may I ask? Hello?
Go ahead.
Yes, please.
Madam, origami is used in explaining the properties of triangles.
Yes.
Can you give the glimpse of that thing?
Sir, I am going to conduct a workshop in this conference on teaching maths using origami on Sunday. You can please feel free to join. Because it's an hour-long session where I will be touching upon various concepts which can be taught through origami.
Okay, ma'am. Thank
you. Yes, any other questions?
There is a question in chat box. Somebody has asked how 10 gram is used for fractions.
Oh, probably
they can come to workshop again.
Yes, they can come to the workshop, and there are some links. There are some lesson links on my YouTube channel, which is the LearnQuest channel, where I have actually taught fractions using 10 grams. I can actually post a link if.
Please post a link in the chat box. That will be a good idea.
Yes, thank you. I'll just do that.
In the meantime, anybody else has a question?
So after she puts that one, we'll go on to present to Nandini. Nandini, are you ready?
Yes, I'm ready.
Okay.
1 minute.
Yes.
That's okay.
Yes.
You can share your screen if you want to. Hello.
Sir, can I share the screen?
Yeah, go ahead.
Yes.
Okay, sir. Is the screen visible?
Yes, go ahead.
Okay. Good afternoon, everyone. Good evening, everyone. So myself, Nandini VS, currently pursuing my Bachelor of Education from Christ James University. I'm a co-author, Dr. Jacqueline Kareem, Assistant Professor, School of Education from Christ James University, Bangalore. So we did an empirical research study in math education. The topic goes like this: STEM education, influence of 21st century skills and student engagement on teaching outcome expectancy. So we worked on the theme 1, that is use of technology in math classroom. Here, STEM, science, technology, engineering, and mathematics. This allows the students to explore 2 or more subjects, and then it helps to implement it in the real world situations. And National Science Foundation has helped or promoting the STEM education in the curriculum and in the pedagogy. It has been contributing promoting and contributing many things so that they can be students as well as the teachers can do research on this. And inquiry-based learning, it is a form of active learning that starts by posing questions, problems, or scenarios. And here the students, they coordinate, comprehend, to develop as well as to create a curiosity in themselves and then raise questions and understand what is the learning subjects that they want to. Teachers' perception are thoughts or the mental images that teachers have about their students that are shaped by the background knowledge and life experiences. Also, what I see is that the role that learners' motivation is an emotional response to STEM. It plays a role in their participation and achievement STEM education. This is from the student engagement topic. When we see that it's a need of the hour. As we see student engagement, it's very important to see how a student engage in the classroom, like what are the plays and how they inculcate themselves in doing the activities that the teacher gave, or how they do the peer influences, and how importantly they do in the classroom. That is what student engagement is. So it is a need of the hour. Now, the need for the study. It is seen that students in the middle class or middle schools, they have limited STEM career knowledge regarding the subject requirements. And what sort of these activities involved, the career involvement is very less seen. Next one is an influence of 21st century skill and student engagement on teaching outcome expectancy, and how inquiry-based approach is used in the STEM education. So here we reviewed a few literature, and some of them are adventure engineering, which design-centered inquiry-based approach to middle grade science and mathematics education. There, teachers express an increased interest and enthusiasm for learning among their students. This was done by Mooney and Lombak in 2002. This was some of the other researchers. Our base paper was Connecting Science Instruction and Teacher Self-Efficacy and Beliefs in STEM Education, where teacher self-efficacy was consistent over the 3 phases. And STEM OP workshops were influenced the teaching and provided them which new teaching methods were used. The gaps that were identified were that majorly there was a disconnect between the belief and the implementation in the practice. And especially during this pandemic, the so-called online learning has come into existence, and there was no longer the traditional and conventional mode of learning and detaching. The platform has opened into a new era of budding generation, and in the era of technology, institutions, they have opened the online platform for teaching and learning. Aggravated by this above findings, it is noted that studies on inquiry-based learning in mathematics online, this have not been studied in detail. Also, the utilization of statistical tools like correlation, probable error, the slope of the data points, and the linear regression for the analysis of the result, this adds to the proposed study novelty. Here, the research question, objective, and hypothesis. So the research question that has emerged from the need of the study are, what are the levels of teaching outcome expectancy and student engagement with regard to implementing STEM education? And what are the strategies that can be adopted for inquiry-based approaches that takes place in STEM classes? Some of the objectives were that to explore the relation of 21st century skill and student engagement in teaching outcome expectancy of STEM education, and to relate inquiry-based approach in STEM classes. The hypothesis of the study was there is no significant relationship between 21st century skill and student engagement on teaching outcome expectancy. So the methodology that we adopted, as I told, it is a quantitative and qualitative study, it is an empirical study. And then the sampling, it was a convenient sampling technique, and an online questionnaire was sent out through Google Forms, and interviews was conducted for the qualitative part and through Zoom Meet. The sample, 84 science and mathematics school teachers across various school boards and at all levels of school education, primary, secondary, and higher education, were being done for the study. And then 58 female teachers and 26 male teachers are included, out of which 45 teachers, they dealt with science subjects and 39 teachers with the mathematics. So, quantitative and qualitative surveys. For the quantitative survey, teacher efficacy attitudes towards STEM, the T-STEM survey tool was used to measure the teaching outcome expectancy, student engagement, and 21st century skill. The tool, it consists of 34 items under a Likert scale for 3 constructs. Then 34 items were subdivided into these 3 categories, out of which teaching outcome expectancy, there were 9 questions, student engagement with 14, and 21st century learning attitude with 11 questions each. And the qualitative survey, in the interview, we interviewed 4 science and mathematics teachers, and from this perception and implementation of STEM education in the classroom. This also included the strategies that teachers use and inquiry-based approaches, challenges to implement STEM education and teachers' engagement in STEM research for the implementation. A thematic analysis was then conducted to study the themes that were prevalent across all the interviews. The 3 concepts that I was talking about, teaching outcome expectancy beliefs, was a measurement that was at the degree to which the respondents believe in general the student learning in the specific STEM education that can be impacted by the action of teachers. And the STEM instruction, that is the student engagement, how the students engage in the classroom, for that how often the respondent use certain STEM instructional practices. And the last one, the 21st century learning attitudes, like the learning attitude that student has during this 21st century, and this questions were answered by the teacher. So the demographic profile of the sample, just how the genders are female and male, how many were there, distribution. And the professional development here means the workshop that they attended, like if they have gone to a STEM workshop or any other workshop that is related to the STEM education or all those things. So 32 attempted and 52 did not attempt it. And the teaching experiences less than 5 years, 6 to 10 years, and then more than 11 years. So the school board that we've gone through was CBSE, IB, ICSE, IGSE, and the state. To all the schools, some of the schools we personally went and sent the questionnaires, and some the Google forms were sent across. to teachers. So the reliability analysis from this, we did the Cronbach alpha. It was clear that the Cronbach alpha for each of them was 0.882, 0.941, and 0.902. So it was reliable. The tools that we use were reliable. Correlation analysis was done, as we saw. So the major findings from the study was that the analysis suggests that both student engagement and 21st century, they has a significant positive relationship with the teaching outcome expectancy. The value was at 0.586. Here, our value determined the correlation of these two on the teaching outcome expectancy. And the significant value P is less than 0.05. That is an evidence that student engagement 21st century skills are statistically significant predictor of teaching outcome expectancy in the STEM education. Now the analysis, the qualitative analysis, from that the recurring themes were that teachers' knowledge in STEM education through skill and effective dimension, the contribution of STEM education, challenges to implement the STEM education, inquiry-based learning in STEM classes. So the reflection from the interview, what it indicated that majority of them had a great overwhelming knowledge about STEM education, teachers, okay? So, and then they hadn't had an experience to share when asked about the definition of STEM. At the same time, few teachers, they lacked in contributing STEM in their classes. So they knew the definition, they were not able to put it in the classroom. Then, though they try to make the concept more understandable to the students using all the science and technology, they lag behind the major concept of asking the students to demonstrate. They are trying all the possible ways to make the learners grasp the advanced knowledge of education for the long run of the society. But by accepting all these challenges and taking up the new roles, teachers are crossing the comfort zone to make the students grasp all the knowledge. Almost all the participants were recruiting inquiry-based approach in their teaching strategies with hands-on experience and demonstration, as few of the teachers were talking about how they inculcate like dotting games and how they use the puzzle games in the classroom, and how how they want the students to come up with the inquiry in the mind. And the implication recommendation, although many studies were conducted on STEM education, few were investigated on the new approaches. Additionally, this focused on the inquiry-based along with the factors and influence STEM. Now, STEM studies, this have increased in the last 10 years. The last decade has been increased a lot vast. This increase can be due to discourse of the important standards, for instance, ITA, International Technology Education Association, and National Research Council. Thus, educators have published international papers and journals about STEM education from different perspectives. Through professional development and workshop, all those conducted, teachers can construct a community of practices where they could enhance knowledge, instructional skill, and pedagogical approaches. To educate integrated STEM, in addition, studies were required to broaden the educational techniques, which can be focusing on teaching and learning throughout all the three domains, namely learning, cognitive, affective, that is psychomotor too. Since integrated STEM education, it includes a complicated teaching techniques and calls for insight into students' education and mental needs, which can be done on kind of preferred education. In addition, discussions could be based on greater and logical empirical studies are required. Coming to the conclusion part, from the result, it is very clear that 21st century skills and the student engagement, it has a positive influence on teaching outcome expectancy in STEM classes. And the teachers, they are required to integrate science and engineering practices in the classroom explicitly for the students to exercise the real-world problem solving and the growth 21st century skills by the teachers. Now, implementing STEM education in a classroom has got a great impact on school boards, and it also depends on the professional development courses, all those adapted and adopted. These are few of the references. Yeah, that's it. Thank you.
That is quite okay, Nandini. But
yes, sir.
That 84 science and mathematics school teachers were selected. And,
yes, sir.
When it was selected? When?
Sir, this was during the pandemic time. I mean, recently, just in the month of August. Yeah. July, August, sir.
July, August.
Yes, sir. And even like we sent the Google forms to many schools. Many of them were not responding to our calls and all, but we did our best, whatever we did.
And that is a problem with the schools.
Yes, sir.
We also face. And whenever we give a questionnaire, that response is very poor.
Yes, sir.
That's fine. Any other question to Manjushri? Sorry, Nandini.
Nandini.
Please.
I think response is poor. Even 200 people register for this our conference, and you can see only 35 are present. So that is the way people respond. Anyway, just Nandini, I want to ask. Many of us don't know what is STEM.
Okay. STEM,
Yes,
science,
what is it?
technology, engineering, science, technology, engineering, mathematics.
Oh, great. Thank you. Thank you for enlightening. Because this is not used in India at all. There is nothing called STEM education in India.
Sir, to your knowledge, STEM education is being there nowadays in almost CBSE school as well as in ICSE, because when we went and asked the teacher, many of them knew what STEM education was.
Yeah, they know what is STEM education, but it is not being practiced as such. In any one of the schools, even international schools don't do it.
मेरे विचार से STEM एजुकेशन तो हमारे सिलेबस का ही पार्ट है।
कौन से स्कूल में हैं आप?
जी मैं CBSE बोर्ड के सभी सिलेबस की बात कर रहा हूँ।
अरे वाह, ग्रेट। My knowledge is poor about CBSE.
NCERT की जितनी पुस्तकें हैं सभी में STEM तो छिपा हुआ है।
अच्छा, good, that's good.
Even for the interview part, the qualitative part, when we asked, they were like, they knew STEM, but how to inculcate the STEM classes, they were like lacking the knowledge when the teachers were lacking the knowledge.
Good. So, any other question? I'm just passing over to Santanam, sir.
Yeah, any other questions? So we call it a day, we call it a session.
Yes.
Thank you. Thank you, Nandini and others who have done wonderfully well. Thank you very much.
Thank you, sir.
So thank you all. And the next session is at 5:30 by David Porras. He is going to talk about using virtual manipulatives to engage students in deep mathematical explorations and discovery. He is at present in US. I think he is a US citizen probably. So his early morning is getting up to lecture for us. So please be there at 5:30. Take a break and be there at 5:30. Thank you. Hello, David. Can you hear me?
I can. Hello. Good morning. Good afternoon. Good evening.
Good evening. For you, what is the time for you now?
It is about to be 7 in the morning.
7 in the morning in US.
Yes.
Oh,
yes.
You are in US, right?
I am. Yeah. I'm in Boston on the East Coast of the United States.
Oh God, Boston.
Yeah.
How cold it is in Boston now?
It's actually pretty mild today. It's been a nice warm week. It's about 50 degrees Fahrenheit this morning. I can do the conversion in a little bit, but yeah.
Boston, New York can get very bad in winter. No?
It can be, yeah. And what part of India are you in?
I am in Western India, Mumbai.
Oh, nice. Yeah.
That is a sea coast, west
yes.
of India.
Sure. Yeah. I was lucky enough to travel to India almost 20 years ago now, but I spent some time in Mumbai and had a spectacular visit.
Okay, good. Things have changed in 20 years in India.
Yeah, I'm sure, yes. But I think I'm all ready to go. I can share my screen.
Yeah, please.
Oh, yeah, so when it's time to, I don't need to now, but let me just confirm that it works if that's okay.
Yeah, please.
Yeah. I assume you can see that, right?
Yes, it's good.
Great. And then if I do this,
yes,
you can see that, right?
Yes, very much visible. Great. Everything clear. Your audio is clear.
Great. All right. I will stop sharing, and then we'll get rolling when it's ready.
Yeah, sure. In about 10 minutes more.
Yeah. Great.
Because
wonderful.
According to our time, it is evening 5:30 when we start.
Yes. Yes. Great.
So what? 10 minutes more.
Great.
So if you want to do something, carry on. I'll just take a freshen up myself.
Great. All right. I'll see you in 10 minutes.
Yeah, sure. You can. Hello, David.
Hello again.
Yep. Hi, Barry. We have Barry Kisan from Australia. He is also joined. He will be talking tomorrow.
Hi, Prof. Rana.
Yep. How is it weather-wise? How is Australia?
It's not too bad. It's about 30 degrees today.
Oh, no. It's as close to Bombay. Bombay is 32.
Yeah.
David, we start in about 2 minutes.
Sounds great.
Yep. And Barry, how is the COVID situation in Australia now?
There's a lot of Omicron at the moment in the eastern states, but nothing in Western Australia at all. We're very lucky here.
Okay. Yeah, I think we feel it, we are getting out of it, and then suddenly something else comes.
Yeah. It's been a lot of surge recently of Omicron.
Yeah, that's right. Okay, it's bad in US also, I think.
It is, yeah. It's getting worse as we head into winter in the US.
Yeah, that's right. So I think it's time for me to formally welcome David for us. He is the head of content division in Mathigon, one of the popular softwares or online virtual tool manipulatives, which can help in teaching and learning of mathematics. So we'll all learn from him what does Mathigon can do. And let me just remind you that followed by his talk, there is a hands-on workshop by Sangeeta Gulati on the same software, Mathigon. Okay. So with that, let me welcome David. David has gotten up early in the morning at 7 o'clock in US to enlighten us about Mathigon. So David, welcome, please.
Thank you very much for that nice introduction. It's a pleasure to be here. I'm really excited to share some of the ideas about using the virtual tools on Mathigon to engage students in exploration and discovery. Like many of you who are teachers, we are always up early. So this is when I'm normally at school getting ready for the day. So it is my pleasure to be here to talk about Mathigon. As you heard, there's a few talks that are coming as part of the conference today and tomorrow, I think, that are going to get into more of the specifics of how to use all the tools. In my talk today, I want to share some of the bigger ideas about why a virtual manipulative can be helpful to engage students in mathematics. And just to be clear on the word, what a manipulative is, here's an example of some of them. You know, these are physical manipulatives that I have in my classroom, shapes that students can fit together and play with mathematically to help their brains think of concrete ideas and understand mathematics. And a virtual manipulative is ones that are online. So I am a full-time middle school math teacher in the United States outside of Boston. I teach 6th and 7th graders who are like 11, 12, 13 years old. And I'm also the head of content at Mathigon. So I am going to talk about 4 reasons why virtual manipulatives can be beneficial for students. I'll share an example or 2 of each on Mathagon. So the first one that I think can be really beneficial for students is it creates an opportunity for students to discover and explore mathematical ideas on their own, with obviously, the facilitation from the teacher. But here's an example of a parallelogram being cut up to form a rectangle as a way for students to have a visual of the area of a parallelogram is the base times the height, because you can take that parallelogram and change it into a rectangle. For years, I've done this in school where I've just drawn it on the board and students have watched. And then I switched to, I would give students a piece of graph paper and they'd cut out the graph paper and they'd move the triangle over. And that was somewhat successful, but I found like the scissors and the paper actually got in the way of them understanding the mathematics behind the idea. And so the past year, as I've shifted into the virtual tools on Mathagon, I found that the tools are so easy and inviting for students to use that the scissors, the paper, all the tape, the things that got in the way of their understanding were removed, and now they could really focus on the mathematics. So I want to share an example about how I use these tools to explore the area of a circle. We all probably have the formula memorized that it's pi r squared. When I first started teaching years ago, I just told my students the formula. I made them memorize the formula. They practiced it over and over again. They never really understood where the formula came from, but they got good at just kind of like a memorization of the formula. And as I've grown in my teaching, as our approach to math instruction in the United States has changed, we're much more interested in students understanding where that formula comes from. Why is the area of a circle pi r squared? And so I'm going to head over to Mathagon to explore and share an activity that I did with students around the area of a circle that I think shows off a number of the tools. So here I am at mathagon.org. I put the link in the chat. I don't expect you to do this as I'm doing it. I might go a little fast. You can always come back and watch the recording. And again, there are some follow-up sessions in this conference about the specific tools. Mathagon is a mathematical playground. It is free for students and teachers around the world. So everything I'm showing you today is open, available, free for everyone. It works on in a browser. It works on phones. So a lot of open access to students and teachers around the world. So I'm going to go to Polypad, which is in the top right. And Polypad, we like to describe as an open canvas for exploring mathematics. So here, this white space is the canvas. On the left is a tile panel where you can add all sorts of tiles to the canvas. I could add polygons. I could add a tangram. There is a whole section of numbers. You can do number tiles and number bars. They all kind of like snap together in nice ways, but I want to explore, as I talked about, how to find the area of a circle. So I'm going to go to the fraction circles, and I want to make a circle out of 8ths. So I'm going to drag a 1/8 on the canvas. I'm just going to zoom in a little bit. I can copy this. As you notice, if I click on a tile on the canvas, there are some options at the bottom, and one of them is copy. So I'm going to take a copy and put it on top of itself, and then I can spin it down. I can also make a copy with the C button on my keyboard. And so there are 3 of them. I'm going to make a full circle out of 8ths. In fact, in the magic of production, I've made one in advance, which I've saved. So I will show you later how to save them and add them to your files. But here is a circle out of 8ths. And I don't necessarily care that these are 1/8 right now. So under settings, I'm going to select the option to hide the number labels. I got there again under settings and hide number labels. So there's my circle, right? And let me just change the color here. I'll make it orange or something. And the story that I would talk about with students is, this is a pizza, and I first want to have them make an estimate of the area of this pizza. And so under tiles, I would have them put a blue square on the canvas, and that square has an area of 1 as a default on Polypad. And they would just go and explore, and they'd put the squares in here and try to come up with an estimate of the area of the circle. So they would go do that and share their estimate. And so again, that's building the idea again that the area of something in square units is how many squares fit inside the shape. And their brains are actually doing it by putting the squares inside. And this exploration of area of a circle would have come after we explored parallelograms and triangles. And they would have developed a really clear understanding that the way we found the area of parallelograms and triangles was taking those shapes and making them into rectangles. You saw that video where I cut the parallelogram and moved it over. And then we would have spent time on triangles where every triangle can be doubled to make a parallelogram. So I would just say, go see if you can make this into a parallelogram. And with some supports on my end, maybe they would take a piece of the pizza and move it over here, and then take another one and move it over here to try to take the circle and arrange it into a parallelogram. So there's 2 of them, there's 6 of them, and there's 8 of the pieces into a parallelogram. And then we would talk about how to find the area of this almost parallelogram. And so another one of the polygons that I can put on the canvas, just to share a little bit, here is a septagon I put on the canvas. You can see I can spin it, I can move it, I can change its color, I can cut it into pieces, but I can't change the size of it. It is fixed as a septagon. And that's true for all of these except for this one, which you can see has the white vertices that change black when I put them on the canvas. This is a custom polygon. And this one is a custom polygon because I can change the shape. If I click on a side, I can add a vertex. If I click on a vertex, I can get rid of it. And so I can use this to put a parallelogram on top of this almost parallelogram that I made with the slices of the pizza. So there's the parallelogram. That looks pretty good. I don't want to move the vertices anymore. I'm happy with that. So one option at the bottom is to fix the vertices. When I click that, you can see that now I can move it, I can spin it, but I can't change the shape of it anymore. I'll make it a little transparent so we can see through it. So here I can change the color, but also if I click on the sliders, the last one changes the level of transparency here. So there we go, we can kind of see it. And then I'd have students explore the area of this parallelogram. And so we would do the cut tool. Oh, that's not a straight line, so I'm going to undo that. I'm actually going to put a ruler on the canvas to show you that we can put a ruler on here to help us make a nice straight cut that goes at a 90-degree angle. So I'll take this, and you can see it kind of snaps to a 90-degree angle, which is nice. So now I'll click on the parallelogram and cut it, and I can use the ruler to guide me in that cut. And now I can take this, I'll just copy it so we can see how it's changing on the canvas, and I can move the triangle over here. And so I've taken this circle, sort of changed it into a parallelogram, put the parallelogram on top, and now made it into a rectangle. If I wanted to, I could have students explore the area of this rectangle with the blue squares, or I could use our construction tools at the bottom to draw, I'm going to make it black here, to draw a rectangle around this. And what's nice about that, when I do that and make a rectangle, I can have PolyPad show me the area of that rectangle that I made. So I'll just move this out of the way. And if I click and drag on the rectangle, you can see there's an option here with these 3 dots. That shows me the area of that rectangle is 11.3 of these squares. So I found that this area is 11.3 square units. Oh, square units, there we go. And now I can also use the construction tool to make a circle on top of this. And when I click on the circle, I can see that that area is 12.6, which seems a little bit off. So we could say this area is 12.6 square units. And we talk as a class, why are those different, right? Like, why is the area of this rectangle a little bit smaller than the circle? And students would, we'd have a good discussion that there's those little bits of the circle that aren't enclosed by the parallelogram because it's rounded a little bit too much. And we talk about how could we make this better? Well, maybe if our slices were smaller, right, then those pieces that are sticking up would not be as big. So then I would have them go on their own and do the same thing with a smaller piece of the circle. And they would go through this whole exploration on their own and see that as the pieces get smaller, this area becomes closer and closer to 12.6. And I think there's great power in this because it's not students that are watching a video of this. It's not students watching an animation of it. It's students doing it for themselves on their own. And they're building that knowledge of where that formula comes from. After a few examples of that, I would take this rectangle. There's a join button also. So now you can see these are two separate pieces. I'm going to join them together to make a full rectangle. And we talk about how does this rectangle compare to the circle? And we'd say, oh, this side of the circle seems like the radius. Sorry, that side of the rectangle is the radius. And the bottom of the rectangle is half of the circumference. Right, so then I could add here, this is half of the circumference, half of circumference. And then we'd work with our algebra skills to prove that r times half of circumference or r times half times pi times diameter can simplify to pi r squared. So we would see a proof of that as pi r squared. But what was really powerful for me as a teacher, I had some students who continued to use the formula radius, or the area of a circle is radius times half of circumference. Even though we had proved algebraically it's pi r squared, what made sense for them in their brain was the area of a circle is radius times half of circumference, because they had built it and discovered that on their own. And so we had talked about the power of developing ideas for oneself can lead to good depth of understanding. And then what we talked about as well, I'm going to build another circle, and I'm actually going to put on a background of the grids. So let me move this circle so it matches up with the grid lines. So there, it'll be in the middle, and I'm going to make this, there we go. And then we talked about, I used the custom polygon to put a square here. And I'm going to make a 3x3 square. And we talked about how many of those squares, let me turn off the grid now so it can snap to the circle. How many of these squares are needed to complete the circle? And we saw, is it one? Well, one obviously is not going to be enough. Is it 2 squares fill up the circle? That's not going to be enough. Is it 4? That's way too many. And we talked about, could it be 3? Could 3 squares totally fill up the circle? And so we continued with this exploration and cut this into lots of pieces and used all this leftover to see how we could fill in the circle. And it turns out that 3 of the r squareds is not quite enough, right? Here, this is an r squared here. And so we saw that 1 r squared was not enough, 2 r squareds was not enough, 3 was not quite enough. And it was another visual of where the formula pi r squared comes from. I have made one to share with you. Here is all of those pieces cut up, and I'm trying to use the red, purple, and the pink to fill in that extra space. And so what students saw, not by me doing it, but them doing it on their own, was another visual of where pi r squared comes from. And so it took a little bit longer, right? It's much quicker if I just write the formula on the board and say, memorize this formula, go use it, but they don't understand that. And so through this exploration of the virtual tools, students came away with an understanding of how mathematicians develop that formula and how it makes sense for them. So that is an example of using the virtual tools to create opportunities for students to discover ideas, going beyond the memorization of something, but really developing a deep understanding of something. The next example that I want to talk about is the virtual tools I found allow students to move from concrete representations to abstract ideas at their own pace. And so in the United States, in learning about positive and negative numbers, we've used integer chips for a long time. And you can see the picture on the left is the physical integer chips. They're yellow on one side and red on the other. And yellow often will be a positive one, and red is the negative one. And when you put them together, it makes 0. And you can do lots of ways to use these physical chips to show additions of positives and negatives. I've had good success with those chips, but I found that students don't like to use the chips for as long as they actually need to. There's something about like having them on their desk, moving them around doesn't feel as advanced to them mathematically. And so they're quick to say, I don't need the chips anymore. I got it. When truly they don't have a deep understanding of the ideas. But I found when they use the virtual tools, they're much more willing to engage with them for a longer period of time until they've developed their own deep understanding. So this is a video of the ones and the negative ones on Mathagon. But I want to share with you another example where the virtual tools can help students move from concrete to abstract at a pace at their own learning. And I'm going to show you an example on our task page. I'll put the link in the chat, but also show you how to get there on your own, mathagon.org/tasks. I'm going to get there here by on the top right. If I click on 4 teachers, one of the links under 4 teachers is lesson plans. So I'm going to click on lesson plans, and there's over 100 games, activities, explorations, tutorials here. But I'm going to search for the one called the mean of a data set. And I'll put this link in the chat as well, but you can find it there. And I found this I've done in my 6th grade class, the students who are about 11 years old. The mean, as you probably know, is an average of a set of numbers. You add them up and divide by the number of data points. But I think for students to have a good visual of what that is showing with a set of numbers can be really powerful. So this is a whole lesson plan I'm not going to read through, but I'm going to use it as a way to find links to polypads that I want to share with you. So here is the link to the first one. And this was my first introduction with students about how to find the mean. I didn't even use the word mean. I just put this on the screen. I shared it with them. Each student had this on their own device. And I said, arrange the tiles into 5 equal stacks. And they, went and explored, and they moved the purple ones down here and maybe a red one over here. And they just kind of moved them around, and they said, oh yeah, the size of each stack is 15. And they typed it in and they got it right. Awesome. And you can see nice confetti comes down the screen when I enter an answer in the box correctly. These are all so easy to make. I will show you in a few minutes how to find tutorials about how to make canvases like this, where you can add a box to fill in. But again, it was like very easy, for students to do. I just hit a reload, and we had students talk about the strategies that they used. And then I talked about how that was great, but I also want to do this a little bit more efficiently if the numbers were much bigger. And you can see as I select all the tiles, one of the options is to merge here. And so I constructed this graph with the number tiles. So all of these are the number tiles. And one option is I can put them together. So I'm going to click merge, and you'll see that they're all going to be grouped together into one stack with the same color. So I click merge, and there they are up here. And it's one big stack, which I'll just kind of spin around. And that's a visual of we've added them all together, right? So I found out how many there are in total. And now as I click and drag this black handle, it takes the total tiles and continues to change the arrangement of them. I want to split it up into 5 equal groups. So when I do this, I've got 5 of them. There's 5 columns. And now I can split the tiles, and I can take each column and split it apart, right? Which is a really nice way to show the visual of what we're actually doing when finding the mean of a data set. We could start, as I showed at the beginning, and take pieces and move them around so all the stacks are the same size, or we could group them all together into one big clump and then split them up into an even number of stacks, which is a visual representation of adding them all up and dividing by the number of data points that we have. Let me go back to the task page here. So that was the first one. And then I had students do a number of different examples, but then I just wanted them to practice this. And so here's an example of a polypad where there's a bunch of dice. You can spin all the dice, a nice little sound effect here, 6, 6, 1, 12. So then I either had students find the mean on their own, but what I noticed is students were enjoyed showing the visual of actually how to do this. So there's 6, And then here's a 6. And this was 1. And this was 12. So let me copy these and make 2 sets of 12. And so they like would build this on their polypad and they'd try to find the mean here. So they would take all these and they group them together, merge the tiles and try to split it up into 4. And we can see when I split it up into 4, there's 1 left over. And then we had great conversation about what does that 1 left over mean, right? So I can split all these, there's 1 left over. So I do this and I have a stack of 6 in each. And how can we handle, that 1 left over? And so then it was a good conversation about how, the pros and cons of a virtual tool. This thing I can't split. I could go to fraction bars and put a full 1 out here and say, oh yeah, there's a full 1. So we can take this and split it. And, each thing gets a 4th. It's a little bigger than the number tiles, but we can see that the mean here is 6 1/4. So that I think is a really good example of where students are able to abstract things at their own pace. I had some students, every time I gave them a set of numbers to find the mean of, they wanted to go build it in Polypad. And I let them do it as long as they wanted to, which is probably not what I would have done 10, 15 years ago as a teacher. But now I believe if the virtual tools are helpful, go build it as long as you need to. And what began to happen is students on their own came to the point where they didn't need to use the tool anymore. Each student individually abstracted the idea at a pace that was right for them, where in earlier as a teacher, I would force the abstraction upon them, and many students weren't ready yet, and therefore they didn't come away with a good understanding of it. Another example of this that I want to share is our balance scale. And so I'm also going to go back to our task page here under lesson plans, and I'm going to click on balance scale polypads. I'll put this link in the chat as well. And I'm going to start with some really kind of like clear examples of the balance scale and then build up to how we can use them to solve equations. So let me just go to this first one here. This is a balance scale where it says balance the bottom scale. And what you can see here, the box has an answer because I've created this in my teacher account and I've opened it in my teacher account. So you can see the answer right here. When students see this, that would just be a question mark. But, just a fun puzzle for students to explore. 4 of these equal 32. What are 3 of them going to be? I was doing this with my daughter when she was in 2nd grade, and she just went and explored and said, well, she thinks it was going to be 6. So, she put 6 here and she said, let me copy this a few times. And did that balance it? Said, oh, that was not enough, right? 6 did not balance the scale. So she took those and moved them over. And then she tried 7. And actually, if you put the number cards on top of each other, it finds the sum of them. So there's 21 and there's 28. And she was like, oh, that was not enough. She was in 2nd grade at the time. And then she put 8. And then she did 8, 16. And she saw, as she was doing this, she was counting by 8 and saw that, oh, 4 of them is 32. And then she went over here and went 8, 16, 24. And you can see as I do the 24, the scale balances, right? So it started unbalanced and there's 24. And for a really young math student, just that ability to explore numbers and play and think about what makes things equal was a really nice task on this page. Let me go back to the balance scale and enhance this a little bit. This is one that uses all of the types of number tiles. So you can see here, there's these number bars and frames. We have the cards that I've showed you. We have these prime factor circles I'll talk about. But this is a task where a student can balance the scale any way they want. And I think this task helps students think about numbers in lots of different ways. So here's a 10, and a 3, and that's a 6, right? So how might students choose, to balance that scale? Maybe they'll go to the number frames and they might add on an 8 here. That's not going to balance it, but I could kind of put this over here to see 6 and 8, or that's 3 and 4 is 7. So maybe we need a 3 by 3 to get us up to 20. And then let me put on a 3 right here. Is that going to balance it? There we go. So I balance the scale. Here on the number cards, we have a 17 and a 25. So I put an 8 here. Oh, what's that? 17 and 25, right? So I could, right, we'll put a number card, right? I need an 8 on that side, of course, to balance it. I was putting it on the wrong side. Not enough coffee in the morning in the United States, right? But that balances. All of the number cards can work together at the same time, all of the number tile types. And then it can build up to how to solve equations. So let me jump to a little bit more abstract example like this. So here's an equation to solve. And I just presented this with my students and said, go. And what a lot of my students did at first is they just took the 48 here and they moved it over here. But that's not balanced anymore, right? I can't just take the 48 and move it over here. What do we actually have to do to get this, you know, like in order for this scale to balance, I have to go to the number cards. I want to add a 48 over here, right? I can't just take this negative 48 and move it to the other side. What I'm really doing is I want to find moves that keep the scale balanced. So if I, on the number cards, I can type in 48. If I drag the 48 over here, it's no longer balanced. But if I put a 48 on each side, now the scale is balanced. And so as doing this, students are building the idea that in order to maintain equality, I have to put the same thing on each side of the scale. And now I can put the 48 on top of the 22, and that makes 70. And then I can put the 48 and the negative 48. And what's really awesome here is that makes a 0. It doesn't just go away or disappear. Students actually see by doing that, they've created a 0, which is the goal, right? We wanted to kind of think about getting rid of that negative 48. The way to do it is add 48 to itself. And now I take that 0 and I get rid of the 0. And now I can hit delete on the 0 there. So now, all right, we have these 3 x's and negative 2 x's to give 70. Same idea. I kind of want to get these over here, but that doesn't keep it balanced, right? What do I actually have to do? I want to add 2 x's onto that side of the equation, right? And so when I put 2 x's over here and 2 x's, oh, I have to copy those, not just move them, and 2 x's over here, now it's balanced, right? Because we put the same thing on each side of the scale. That keeps things balanced. I love the visual feedback here that students get when they do a move that doesn't preserve equality, right? Here, let me just go back here. On paper, I see students do this a lot, and they don't understand in the moment that they messed up the situation of equality. When they're using the balance scale and they're first exploring the idea, they get that immediate visual feedback that, oh, you just messed up equality here. And so in order to preserve equality, I need to do the same thing to both sides of the scale. And now when I put the x's on top of the opposite of the x, those make a 0 pair, actually 2 0 pairs, which is great. So now I can get rid of those and move them off the scale. And now we see that 5 x's is 70. So I could say that, oh, 70 divided by 5, I think is 14. And so if I put a 14 here, let me put 5 of them and see what happens. 1, 2, 3, 4, 5. Oh, it balances, right? So now I can split each thing into 5 groups and take off 4 of them. And now I see that the value of 1x is 14. And again, this is just at the start of a time in which students would be solving equations. In school, after they play around with a couple of them, we actually do the algebra on the screen at the same time. So if I go back here to the beginning, as you know, at some point, as we're doing it, I would have on the screen here 3x minus 48 equals negative 2x plus 22. I could make this bigger here. And I would have students, as they're solving it, they would show their work here on the screen. So the first thing that I did was, I think we added 48 to each side, right? So we could do 48 and 48. So then I would have them take this, copy it, and say what they did next was add 48 here and add 48 here to show that, right? So at some point, my goal as a teacher is for them to abstract these ideas and solve equations without using the balance scale. But I want them to create that understanding as they're doing it. So when they're ready to shift from the virtual manipulative to the abstraction on paper, they have a good understanding of what they're doing and why. So that is all sorts of fun on the balance scale. Let me see if there are any other canvases here on the balance scale to share with you. You can see it can get, pretty complex. You can add an x squared onto that, and you could have students explore a quadratic equation. But I want to move on because I have other topics I want to talk about. Before I keep moving here, I've been sharing a lot of tools with you. I just want to share with you places where you can learn more about PolyPad. I'm just sharing a broad stroke, a couple of examples. Again, there are other sessions in this conference that are going to get into more of the how to do this. I'm trying to show you examples of why I think this is powerful for students. But here under PolyPad, if you click on tutorials, there's a whole page. I'll put this in the chat as well. There's a whole page of like how to use the tools. So how to build the balance scale. If you go to using PolyPad in algebra, there's all these short videos about how to use the balance scale, how to create those equations that I was showing to you are all on this tutorial page. And then on the teacher page, under events and webinars, there are a number of past webinars that you are welcome to go watch about how to explore probability, explore geometry, exploring numbers. So that's under events and webinars. And then a bunch of tutorial videos for teachers. So if you want to know how to make classes, how to add that blank question that when you fill in, you get the check that you get it right. All of this is here. So lots of resources at mathagon.org/teachers to go learn more. But let me keep going because I have some other really exciting examples to share with you. So we talked about this where it allows students to move to abstraction at their own pace. The next example I want to share with you is that virtual manipulatives allow students to go beyond what is possible with physical manipulatives. So you can see there are these awesome features where you can take a shape and build it in 2 dimensions and then fold it into a 3-dimensional shape, which is not actually possible to do very easily in the physical world. Let me go back a couple slides, right? This is possible to do in the physical world. You could draw it on a piece of paper and cut it and then just move it over. It takes a little bit longer, but it's possible, right? Here, it's possible to do this with the integer chips. It's kind of messy and it's like harder to visualize and can get in the way. But here, I want to show examples where our tools really allow students to do things that might be possible with one shape in the physical world, but are really, really challenging to do. And so some examples of where this, this goes beyond what is possible. So let me go to polypad.org just to get a new canvas. And I've shared with you some of the polygons here. I'm going to put 6 squares on the canvas. And so there's 1, 2, 3, 4, 5, 6. And you might see, oh yeah, that looks like the net of a cube, right? And so as I click and drag on all of them and I select all of them, one of the options here is to join them together. I could join it in to make one big polygon. But what I want to show you is this fold net option. So watch what happens when I fold the net. It's so cool. Whoa, it comes together and makes that cube. How cool is that? And then I can use this slider to unfold it and stop at any point along the way, right? And then I can click unfold and say, what happens if I move this over here or move that over there? Is that going to make a cube? I could do fold net. Ah, yes. How wonderful is that? And then I would share this with students and I would say, go find all the ways to make a cube. Go explore, go build, go build as many nets of a cube as you can. And maybe some students would build this one. What happens here? Fold net. Oh, it does not make a cube. It makes like half a box, right? And this is not possible to do on paper in a short, efficient amount of time for students just to try something and build it. And it doesn't have to be a cube. under nets here, under 3D solids, there's a prism, which I think I showed on that video. So there's that prism. We have a dodecahedron, which you can unfold and put back together. But students can build their own. And I want to share an example with you that I was doing with my son. My son is a 6th grader here. He is 11 years old. And he had this question on his homework one day. It was on Desmos, which is another awesome platform. I think there are some sessions about in this conference, but this was like a static image on his Chromebook. It said that a student had made this net, and the question is, what polyhedron can be folded from this net? And he was learning about prisms, that is 2 congruent faces that are connected by rectangles, and pyramids that come to a point. And he looked at this quickly and he said that it was a pyramid. And he explained why, because he saw that the 2 triangles were kind of folding up and he visualized them coming to a point. And so he thought it was a pyramid. And I was trying to talk him through it and not just give him the answer, but help him describe in more detail about what he saw. And he couldn't quite see it. And then I said, wait, let's go build it in PolyPad. And so because he's my son and I've been working on Mathicon for a while, he was pretty comfortable with that. But it's pretty easy to do with the custom polygon tool, right? So he went to polygons, and you can use the custom polygon tool and make any kind of polygon that you want on the grid line. So you can make this square that's in blue. And so I just told him to go to PolyPad and build it. And he did. And then he said, all right, I'm going to fold it. And he clicked fold. And then as he was able to move it, he saw that it in fact was a prism, that it is 2 of the triangles. Those triangles are the bases. There is the 2 congruent triangles connected by the rectangles. And so it was a great example where he was stuck on how to visualize this. And so to be able to build it in PolyPad allowed him to get unstuck and see what was going on there. And eventually, what I think the next time he sees one like this, he might not need to build it because he's gone through that example of building it. So that was really cool. Let me totally change gears. And I want to go to a blank canvas, and I want to show you some of our probability tools, because I think our probability tools can be really helpful in students exploring mathematics. We have dice that you can spin, makes a nice sound effect. I can copy the dice to get a lot of them on the screen at once. And so there's 4 of them, right? So I can spin all of those at once. We have coins I can put on the screen. I can flip all of the coins at once. There are spinners that you can spin. You can change the number of regions of the spinner. There's a custom spinner. I can add regions to the spinner and change the sizes so it's not all the same. We have dice of many sides. And so I can put all of those here. And what's really fun is I can spin all of these at once. Watch this. It's just beautiful mathematics right there. I think that's great. And then I want to get a lot of dice on the screen at once. You can see it was very easy to get 4, but I'm going to go to File menu. And so here are all my saved polypads. I have a lot, obviously. But for all accounts, for all people who go to PolyPad, examples and templates will be at the bottom here. And under probability and data, we have a pre-made canvas with 100 pair of dice. And so here are 100 pair of dice. And so I explored, I asked my students, how often do they think a 1 and a 1 is going to come up in 100 rolls? This is before we'd explored probability of rolling 2 dice. So they did it and they rolled them all. You can see all of them can roll at once. And this was on their own device. And let's see, how many double ones did I got? I see, did I only get 1 of them? That's pretty cool. I got 1. So that is 1 out of 100. There might be others that I'm missing. And then I would do it again. And then I could count how many more I got. Here's 1 down here. Is that the only one? So I got 2 out of 100. I had students who did this on their own device, right? And I had each student do this 10 times. It did not take them a long time at all, right? So there's 3 times. I could do it 3. Oh, I got a bunch right here. Look at this. 1, 2, 3, 4, 5. And keep track of the data. I had 25 students in a class. They each did this 10 times of 100 rolls of the dice. So in about 5 minutes, we got 25,000 trials of rolling 2 dice. And we had up on the board the total number of times of a 1 and a 1 came up. And we had that experimental probability. And then we calculated the theoretical probability. And it was really close because our trial was so big. We had 25,000. Now there's lots of places where you could go code something that says, flip 2 dice 25,000 times and tell me how many times a 1 and a 1 comes up. And it'll tell you a number. But I think when students see this actually happening on their device and they counted it, and then they know all of their classmates are doing the same, and I'm keeping track of the numbers on the board, the seeing is believing here, right? And so that when they see that our experimental probability and the theoretical probability come really close to each other, they believe the probability, I think, right? It's really hard in a class in 10 minutes with actual dice to get 25,000 trials. Maybe you could do 50 trials or 100 trials, but then there's a good chance the experimental and theoretical probability might not be that close to each other. So the power here of building lots and lots of trials really quickly, I think is great for students. So the probability tools can be great. Another example of something that I want to share with you are our prime factor circles. So here under prime factor circles, you might notice something about these circles. Here's 2 and 3 and 4 and 12 I'll put up here, and 19. Here's 20. Let me build one that'll have a lot of colors to it, 360. And you might notice, if you haven't seen these prime factor circles before, that any number that's prime is a full color, but any composite number is made up of its prime factors. So this 12 here is a 2, a 2, and a 3. This 20 is a 2, a 2, and a 5, right? This 16 is a 2, a 2, a 2. And if you have not explored this as a topic with students, so many great places to go learn about prime factor circles. One place you can go is Math for Love by Dan Finkel. I'm putting that in the chat. He has a great game called Prime Climb, which explores these prime factor circles. But here on Polypad, the power comes where you can actually do the following. I could take this 12 here and I can pull it apart into its prime factors. So I could pull this out and see that, oh, 12 is 6 times 2. And I can take this and I can pull it apart, and that's a 3, 2, and a 2. And so I've shown like visually that prime factorization is 2 times 2 times 3. And this is so wonderful for students as we explore, like, find the common factors of 336 and 1260. That's kind of a mess of a question. But what students can do as they're beginning to understand these ideas, here's 336, here's 1260, right? And let me see what they have in common. And I find as my students started this, they just talked about colors. And they were like, oh, they both have a 2 in common. I'm just going to copy these so I keep the question up here. They both have a 2 in common. I can pull out a 2. Oh, cool. So yeah, a common factor is 2. Let me put that 2 back in here, right? And then other students might say, oh, I could pull out a green and a green, but maybe we could pull out a purple and a purple. Also, a common factor is 21 is a common factor. And they could go through and list all the common factors just by, by taking these apart and putting them back together. Eventually, of course, we'd get to a way to find the greatest common factor, the highest common factor, by pulling out as many as we can. Let's see here, we can get a 2 and a 2, and a green and a green, a 3. And this is the 7 and the 7. And then we get another 2 and another 2. And it seems like the greatest common factor is 84. But I think it's powerful for students to list all the common factors. And then eventually they're building the idea of, oh, you can use the prime factorization and find all the factors they have in common to find the greatest common factor, and then build up to the idea of the least common multiple. So those are super helpful as well. Another example of something that's not possible in the physical world is an activity like this for younger students. here is just arrange the numbers 1 through 20, and it's numbers in all different representations, right? So it's helpful for younger students to be flexible in their representations of numbers. So a great task, I'll put this in the chat if you want to be able to use it with students because it's not on our task page, but just have students say, okay, this is 8. So let me put that above 8. This is 5, and go through and put all those in order. Could be a fun task for students. All right, I have one last category in my final minutes that I have. We've talked about this allows students to go beyond what is possible. And then I think there's just opportunities for creativity, enjoyment, problem solving, and engagement. These are column tiles. You can learn more at columntiles.com. I will show you that site, a great place to go explore, but we have them on Polypad. So it's fun to do this with dots on graph paper, but you can also build right on Polypad in column tiles. Let me put this link in the chat. If you are not familiar with column tiles, go check them out. But there's a great site here where you can learn more about column tiles. It's an example of geometry and art coming together. And I think these tiles are being made at some point. You may know that column is a traditional art form from India, mostly practiced by women using rice or chalk dust to draw a complex pattern of lines and curves around a grid of dots. And we have them here on Polypad. So I'm gonna go to a new Polypad and go to tiles. Under geometry, there's so much I haven't showed you, but under patterns and art, there are the column tiles. So you can have students build and explore with the column tiles. Let me show you a fun activity here. I'm gonna go back to our task page where I just have a time in class. I just want to have fun with students and explore and play. And so I'm going to go to class openers and math talks, and I'm going to put this here. And one of my new favorite things to do with students is I do this activity where it's called What Are the Two Cards? And so here I haven't even showed you our playing cards, but we have a whole set of playing cards. I'm going to select all the playing cards. I'm going to turn them over. I'm going to stack them, and I'm going to shuffle a whole bunch of times. So I'm shuffling the deck, and I'm going to deal 2 cards. And you can see the cards work on the balance scale. The dice also work on the balance scale. So I'll put 5 and 2 here, and let's see if we can figure out what the 2 cards are. So we can see that when I put 7 here, these 2 cards are heavier than 7. Feel free to guess in the chat if you want. But as I roll the dice, I might get more information about the cards. Oh, 7 again, not helpful. You have a guess in the chat. 6 again, not helpful. Let's see if we can get above 6. 7, I'm going to add this 3rd dice on here. Let's see if that gives us more information. Oh, that is 11, heavier than 11. So I know those 2 numbers add up to more than 11. Let's see what else we can figure out. Oh, I've balanced. It's 12. I think that's 12. So I know it's none of those. But now I need to have a conversation with my students. What are all the ways to get 12? Even that in and of itself is a great question. What are all the possible ways I could use these cards to get 12, 5 and 7, 4 and 8, and so on? And then I'd show them this card, and now they'd probably have a pretty good guess about what that card is. There's the 4. So that is really fun to be able to play guess the card. Some other great things to do on our task page is there are lots of puzzles and games. So I'm going to go to the task page and just select puzzles and games. And I want to show you the Genius Star puzzle, which is such a fun puzzle for students to play. This is here on Polypad. Here in the Genius Star, you spin all of these spinners. I'm going to spin them all. And then I put all of these gray triangles in those numbers. So I have to put 1 in 44. I'll do this one because it's arranged the right way. 1 in 18. 1 in 19. 19 will be going this way. 1 in 31. This goes in 31. 1 in 7. And the goal is after I've filled all of these in, oops, I have to use all these pieces to fill in the star. So this one I need to turn around. But now all of these other pieces I use to fill in the star without any overlapping shapes that's that. I could do that. I could put the blue one there. And what's amazing about this, every possibility has a solution. So it's an awesome puzzle. Students have a great time exploring this puzzle. So that's the Genius Star. I encourage you to go explore that. Let me go back to the task page and just close with a final few things before I take any questions. I just want to show you again on the task page some of these other puzzles and games for students to explore. There is one called the Puzzle of the Day, and it is a similar puzzle to the Genius Star, where you have to use these pieces to cover up everything except the current day and month. So what are we in December right now? Is it December 17th? So I have to cover up everything except December and 17. So maybe I'd start going like this, and like, that's not gonna work, but you get the idea. I have to leave everything covered except December and 17. That's not gonna do it, but I could do something like this, and maybe I'm, oh, not like that, but maybe I'm on my way there to covering up everything but December and 17th. And not every one of those has a solution as well. All right, so that is fun to explore as well. In closing, this has been super fun sharing all sorts of ideas with you. I hope you've gotten some ideas of how you could use this in school with students, but I bounced around. I was all over the place. I just wanted to share with you examples in all of these categories of where I think the virtual tools could be really helpful for students. There is so much to explore on Mathagon that I did not even get into. I really encourage you to go to the follow-up sessions later in this conference. And I just want to close with some links to share with you. I had talked about these in the session, but mathagon.org/teachers. I'll type this in the chat. mathagon.org/teachers will take you to this page, which has all sorts of information. There's past events and webinars to learn more. There are tutorial videos. There's our task page. And then finally, the last thing at Polypad itself, at the very bottom here is a link to tutorials where you can learn about how to use all of those tile types. Free for everybody. One really exciting thing that I love being a part of Mathagon about is that it is free and open for everyone. We are really excited about these high quality math resources that we hope students and teachers around the world can find value in. So we got a few minutes for questions. I hope those of you found some value and some good ideas of what you could use with your teaching. And thank you very much for having me again. It's been a pleasure sharing ideas with you for the past hour. And if there are any questions, I'd be happy to stick around and answer questions.
Yeah, thank you, David. It was a very interesting and illuminating presentation where I could see actual manipulatives leading to some abstract conceptualization of ideas. That's what I liked about almost all of them. So before I say anything, I would ask the audience if they have any questions or suggestions to ask. Probably you can, I don't know whether you should stop sharing or not, I don't know.
Sure, yeah. I can stop sharing.
Yeah, I can see whether anybody has a question to ask.
Yeah, great. There's a question about how much language is used in the reasoning using manipulatives. What I like about this is it's very visual, right? And so I find that students aren't getting bogged down by a lot of language and text and instructions on the screen. I just give them a very simple prompt or instruction and say, go. So, on those balance scales, it's just go try to balance the scale. And they just go and explore on that exploration, finding the average of numbers, go try to balance everything out. And so for students where the language of mathematics can sometimes get in the way, being able to have a concrete visual that's kind of intuitive to use and engaging can be helpful, I find.
And moreover, I think the language doesn't come very much as abstraction. The facilitator, who's our teacher, for example, I can explain these manipulatives in Hindi, what is to be done, and then respond back in Hindi. Students can respond back. I can understand. The idea is to spark their imagination and have their own words, whatever language it is, it doesn't matter actually.
Yeah, that's great.
spark the mathematical thinking in their, yeah. So
Yeah.
anybody else has a question to ask?
There was a question about, is there a tutorial book? There's not a physical book or a PDF of a book, but that link to mathagon.org/tutorials has a really thorough tutorial on how to use all the tools. So, you know, as I said, I was going quick. I just wanted to present a really general, here are some things that you could do, but that link has a whole bunch of tutorials. We are continually updating and adding more features and more tools. Every couple of weeks we have something new coming out. So if you are on Twitter, I think it's a great place for a math teacher to learn and explore and grow. I've learned so much over the years on Twitter as a math teacher. So I put, I'm at David Porras and we're at mathagon.org on Twitter. So feel free to give us a follow. Love to follow you back and learn from you as well. It's been an awesome place to be a math teacher. So I encourage you to check it out if you're not active on Twitter.
If you have a question to ask, please unmute your mic and you can ask the question, or you can put in the chat box, whichever way you feel comfortable.
Yeah. Hi, may I ask a question?
Sure.
Yeah, please go ahead.
Yeah, this is Ranjani. I work as a teacher and I've also been working with teachers, and I've been using a lot of technology tools and manipulatives with children.
Wonderful.
I asked a question about the language. So my question really here is, you know, to go back to the example that you had of the algebraic equation balancing. Now that 5x is equal to 70 and x equal to 14, the issue there is, what I found is children really don't understand that 5 multiplied by x is different from 5 added to x.
Yeah.
And that's a key problem. I mean, there are many examples of gaps in language processing which interferes with algebraic thinking and formulation. But the example that you showed, I was wondering how it gets to that, because it sort of it doesn't really address that problem at all, right? I mean, or am I missing something? I just wondered whether you could, you know, explain that a bit.
Yeah, I found that as I've been working with students on the balance scale, they come with a better understanding that, you know, this picture that I have on the scale now, x plus x plus x plus x plus x, is the same as 5 of those x's. And so as I've moved from the concrete to the abstract on paper, I've actually seen fewer students who are making the mistake or a gap of 5 x's as this picture, as opposed to a situation where, you know, where they have this, or sorry, the number cards, because I think this looks so different visually to them on the screen. As they worked through a lot of examples here, I saw less examples where students would do something like 2x plus 5, where they'd simplify that as 7x, which would happen to me a lot in prior years, where, you know, if students had this on a piece of paper, they're tempted to say that is 7x. But here, there's actually no way to put them together, right? It doesn't even let you try to put those together. So I think it's a great question, and a misconception that I see a lot in my teaching as well. I would say that by not like rushing to give up the virtual tools and allowing them to use them as long as they need, or if they make mistakes on what you're describing, say, let's go back to Polypad and build it, and let's see what you're thinking on Polypad and see, you know, what that does, could help in the moment.
Yeah, I think going from concrete to abstract is always a difficult thing for students, especially in earlier years. And if manipulatives in any way can help in that transition, that is a great thing. For example, if you have a green bar of X and a number tile 5 along with it, and they try to merge the two, they will slowly at least get to know that they are different things probably. You can't merge them. So probably there the teacher can later on come and say that, okay, you can't add these things probably. Yeah. So
exactly, yeah.
Only my add-on. I don't know. Every student is different. Every teacher is different. So one has to find different ways of convincing. So anybody else has a question to ask? Or a suggestion or a difficulty? which manipulatives probably can help. There is going to be a workshop on Mathicon just after this. There are 2 sessions, one today and one advanced. So I would suggest that you can ask very specific questions there, how to sort of do something probably using tools. I just wanted to ask David one question.
Sure.
Yeah, in your for example, when you showed that parallel, this trapezium or parallelogram being cut as a rectangle, see, do you allow only vertical or horizontal cuts?
Nope, you can cut in any direction. Yeah.
Yeah, but only rectilinear cuts.
Nope, any polygon can be cut, any shape.
No.
Oh, I'm sorry.
If I have a sphere, can I don't know, there is a tool or pen or something, I draw a curve, instead of a line, a curve. So
yeah.
Cut the square into 2 pieces along that curve as coming as the boundary?
Not at this point, no. So that is a
think
feature
that will
yes.
be a great tool, because I
Yes.
have some sort of thinking. One can make many kind of tiles by cutting and pasting them together.
Yes.
You can cut along some nice simple curves even. So you can put a cutting curve, see, in the one section, saying that, okay, pick up a sine kind of a curve which is cutting, or put up a parabolic kind of a thing which is cutting. So that will be a very good tool if you can add it. So it's my suggestion for the future development of Mathicon.
Yeah, I think that's a great suggestion, and one that I will add to our list if it's not already on there.
Yeah, if once you make it, let me know. Then,
I will. Yeah.
Then I will make a sort of applet or whatever you want to call it using Mathicon.
Great. Yeah, that would be great.
Yeah. Anybody else has a question? Because we can take one more question before we close, because next session is going to be on in a short while. That is going to be a workshop at 6:40. So we have around 1 minute to ask anybody. If not, let me thank David for agreeing to give this presentation and beautiful
Pleasure.
introduction to.
It was I really enjoyed it. Thank you for having me. And if anyone has any Mathicon questions, feel free to get in touch with me on Twitter at David Porras. You also can get in touch with us via support@mathicon.org. If you have any questions, I'll put that in the chat, is our email. And again, any message on Twitter at David Porras works as well. So thanks everyone. Hope you have a great rest of the conference. It looks like an awesome lineup of speakers.
So you had this virtual tour to India after 20 years. Let us hope that you have an actual tour sometime soon. All the
I would love that.
Okay, take care.
Okay.
So
bye everybody.
Bye. We take a short break and then come back for. So next at 6:40 by Sangeeta Gulati, workshop on Mathicon. Hello, Sangeeta.
Good evening, sir. Good evening.
Good evening. Would you like to, Soumya, can you give the host for presentation?
Yeah. You can share your screen.
Yeah. Want to try, Sangeeta?
Yes, sir. I'm doing that.
Okay. Okay. So let me just, it's already time. Welcome you to time 2021. And so we have a workshop on Methigon, basic by Sangeeta Gulati. She is head of the Department of Mathematics at Sanskriti School, Delhi. So without wasting much time, I invite Sangeeta to start the workshop. Please.
Thank you, sir. Thank you. Definitely, it's a wonderful opportunity, but it's a tall order to follow after David to talk about Methigon, because I think he's covered so much in his 1 hour session, so many possibilities, and he's an expert. So definitely I'm a little nervous now bringing this to everyone, because there is so much absolutely amazing in Methigon, but it is a wonderful opportunity to share with all of you who have experienced it and seen the power of this tool.
Yes.
So wonderful to be here, to be in this virtual conference, which is bringing such stars of maths experts here to all of us. So good evening, everyone, and I hope you've had an amazing day so far and you're ready to learn some more. And if you're not watching us live, when you watch the recording, perhaps this will prove a gem of sessions that are coming your way since morning. So this particular session is a follow-up on the presentation which you just saw by David, who is, of course, the content expert of Methigon. When we think about Methigon, my focus would be on Polypad, how one can use Polypad. But just to give you a tour of what Methigon is, it is, of course, a website. You can go to methigon.org. So when you go first to the Methigon, this is the kind of a view that you would get. So it is not a software that you need to download, right? So one of the things that we always get confused as to where do we start. So I'm going to be talking like a teacher who is, starting something for the first time and you don't know where to go and how to get it. So we know that you have certain softwares, like you have gone through perhaps a workshop of Geogebra. So you could download the software of Geogebra. You can run it offline. As David mentioned, you have an app for Methigon, which is also very, very interesting. But definitely to start with, you can come to methigon.org, and there is so much to explore just here. It's one of the wonderful, one would say, textbook of future, which is already with you. And if you can share some of these lessons with your students, you will find them amazingly interesting and exploratory, and something which would take the learning much beyond what our textbooks allow us to do. So that is something that you must not miss, and must come back to this main website and observe and learn from here. What we are going to be talking about, and what you have seen David demonstrating and talking about, the power of virtual manipulatives, that comes from Polypad. So right on the top, you would find something called as courses, and then next to that is Polypad. So once you click on Polypad, you will get to see the interface, which was, of course, demonstrated by David as well in his talk. And we are going to start with an absolute blank screen, which was earlier, like in place of the slides that one would normally have. You saw my welcome slide there. So you can use this even as a whiteboard. It is just a plain page which you can use to pull the manipulatives and construct something on the spot or impromptu you want to demonstrate. But maths also requires some working. So if you have maybe a stylus, you can always pick that up and you can start writing, because there is a drawing tool as well, which you saw as David was demonstrating. So you can actually take it and start writing or scribbling something. So that is where one would start with. You will have a blank page to work with. And then there are a whole lot of things that are hidden under the tiles. So we are going to go and explore. We have 2 sessions today and tomorrow, and we hope that we will be able to give you a good understanding of what is contained, but it will be something which you can start exploring on your own and discover as you were shown. And as I will again reinforce, just in case you were not present there for the earlier session, there are a whole lot of resources and tutorials and templates that are ready to use. So you don't have to wait for another webinar. You can actually just go back to the recordings that are there all in place for you to learn again from the website. And that is how I learn. That is how I have learned all these years. So let's start from exploring the tiles that we have. And along the way, we will touch upon some of their usage. And tomorrow we will scale it up and see what are the other details that we need to be aware of. So I hope you are able to see the screen clearly. And what you are looking at here are 2 panels. There is one long panel on the left in black, and then there is a small panel of tools or settings on the right. We'll ignore that for the time being. We'll start from here and start exploring what is hidden under these very colorful display of geometry, numbers, fractions, algebra, probability, and of course you are looking at tools and axes and some more work stuff coming in. So starting with geometry. When we think about geometry, definitely yes, somewhere or other you start thinking about polygons, right? So that is exactly what you see right on the top. The very first thing is polygons, and if you click on polygons, you will actually get all the polygon tiles that we would normally have in our math classrooms or math labs or any other lesson of where some manipulatives are being used. You can find all of them here. So how does one start using them? Let's start with clicking on any of these polygons. So the moment you click on this polygon, it shows up on your screen. Now, my screen is a little magnified. Usually it would be smaller. So in case you want to zoom in and out, yes, I shouldn't say that we'll ignore this right panel, because here is where you will find the zooming function as well. So you can zoom in or out depending on what your purpose is, right? But these polygons are fixed. They are not going to be changing in their size per se on their own. That means it's not a dynamic polygon. But there is a handle, so you can rotate it around, you can move it around if you wish to. So let's get another polygon in. Let's bring in a square. Again, the beauty of these polygons are that they are meant to be stacked and clubbed together. So they both are rigid, but you can bring one and put it next to the other and it kind of fits it. So the moment you bring it here, it kind of gets not pasted to it, but they are completely aligned. So whether I zoom out or I zoom in, I will be able to see that they will stay together and they are meant to be of that dimension. So that is the beauty of these tiles that you're looking at. Once you have that, then, well, if you give us some polygons, the first thing I would say one would start is perhaps create some patterns, bring some tessellations in. So let's try to create a pattern out of these. So again, you saw how easy it is to duplicate these tiles. So what I can do is I can just select them, right? Just select all of them. And if you click on the key on your keypad, the key of C, it gets copied. So you don't even have to go, at the bottom and use the copy button. And don't miss, there are a lot of these buttons coming at the bottom as well, which definitely I'm going to try to move let's move my zoom bar up. and they are all showing up here. So the moment I had this selected, this one is here, this is here, let's bring them together. And now I'm going to create some tessellations. So I can always try and turn this around and try to join it together. So let's see if we can have some pattern created. And if you are already using, have opened up the website or have opened up Polypad along with me to try, then let's see if you can create one on your own also or not. But not a problem if you have not started, because I would like to, in between, give you a chance to create something along with me. But for the beginning, let's just watch and then you can try it on your own. So once you have that, you can perhaps just take these two pieces and then copy it again and try to see if you can align them and try to create a pattern. So I'm bringing it here and trying to complete a full round, and yeah, just taking it there and bringing it up, and that's it, right? So again, a C, you can actually could have taken a half circle also and then copied and pasted, but I want to take it a little slow to begin with. And you can see how convenient it is. And again, when you think about giving this to children, they will definitely love to, bring their own creativity in place, and they will come up with their own way of designing and bringing that pattern. But just as a beginner to Polypad, this could be one of the activities to explore how they can be rotated, how can they be joined together. And the last one coming up to complete the circle. And then we'll see if we can fill up this space. So I'm just trying to select and move it up here. So let's move this handle around and see if it fits in. So there we go. Just turn this handle around and then slide it down, and we have this, right? So this is one round done. And of course, you will find other tiles here. So you can take an hexagon and then try to fit it right in. There you go. So let's see if we can create one of those tessellations just by using this pad. Another beautiful thing about this white pad is, or white background, is that it's not a limited page. You can keep scrolling up and down. You can keep, shrinking it and making it bigger or smaller. So you have a lot of white space to work on. So it's a kind of an extended whiteboard for you. All right, so let's try to now tessellate this. So I can perhaps select, so click on the shift key of your keyboard and you can do multi-select. So I'm going to multi-select part of it and see if we can copy and then paste it so that we get some kind of a tessellation pattern. So I've selected part of this pattern and copied it, and I'm going to try and slide it down and see if we can fit it in and make a complete, did I get it right? Maybe I need to change the pattern, but this is kind of way it is working, right? You can be flexible in how much you have copied and pasted. You can keep repeating this pattern and you will find that you will be able to fill up all the space that you're looking at. So with your squares and triangles, will the tessellation be done? So again, there's a beautiful lesson, in fact, on tessellation in Mathicon itself, where which polygons tessellate, why do they tessellate? All of that is given in a very exploratory manner. So definitely you can give it a try. I'm going to just complete this because I missed one square here. Not a problem. You can again bring that up and we have this shape getting filled up, right? Now, what you may do is you can select all of them and you can turn them around. And you can have, part of it again copied and pasted to fill up more and more pattern and kind of bring up maybe some kind of theory into it if you want children to explore more of why these are tessellating or when will they not tessellate, and all of those explorations can be done. But for fun, if you are just getting the kids started on these kind of explorations, just creating pattern itself is a wonderful exercise. So I'm going to again copy, and maybe some part is not being copied. Never mind, we can always fill it up. So we can drag it down and put it down, and you can see it will start filling up that entire white screen. And in no time, you will have a nice pattern created for yourself. So that is definitely something which can be tried out and can be thought about as one of the ways that you are looking at this little set of polygons that you have. So let me see if you have tried it. If anyone has tried it, let's get some response from you in the chat. If anyone has tried to create this along with me, if you've been excited to do that. If not, I'm also going to give you a chance to do that in our next, maybe another 5 minutes. So if you are working on it, keep doing it, and we will come back to that, your work in a minute. But before we move ahead, one of the very interesting things demonstrated by David was the custom polygon. So these polygons are fixed. They cannot be changed in their size, but there is a custom polygon. So let's try to see how we can use this custom polygon. And one of the things that was demonstrated about was cutting a polygon, because there are so many cutting and pasting activities we do in our classrooms, whether it is Pythagoras theorem proof that we are talking about, or the result that was talked by David. So I thought, let's me use that itself as an illustration. So here is a custom polygon. If you want to think about or explore it, you can definitely, extend it, take it to make any kind of polygon out of it, right? If you want it to be polygon of more vertices, you can just click on any of the edges and you would be able to find more vertices coming in. So I can have another vertex coming in and I can add another vertex coming in. So you can create as many vertices or as many sides as you want. If you don't want a particular vertex, you just click and it will get deselected. So let's turn this into first a quadrilateral. Since we talked about the activity on tessellations, one of the things that one may want to explore is that all quadrilaterals will tessellate. So if I take a quadrilateral, something like this, right? Let's fix vertices. So for that, since I cannot zoom the lower part of it, once you have a figure, whether it is a polygon or it is any other object like a line or a number card, as you are going to see them later, anything that is selected, the properties that follow with it, they get activated at the lower part of the screen. So here, the moment I have this polygon selected, I can see that there is a flip option, cut option, and fix vertices. So I can fix vertex and I can change the color. So you saw how we can change the color. So once again, click on that color button. You can change the color of it. You can also change the opacity. So if I want to make it pink, I can change the opacity by using this little bars, and I can even use RGB codes to get a specific color. I can make it slightly lighter pink or a darker deep pink, depending on what your requirement is. So let's keep it as it is. And right now, my intention is to try and test whether I can tessellate with this quadrilateral, right? So let's just select this and make a copy and flip that, turn that around. So there is a flip button there. So I made a copy. And now I'm going to try and see if there is a way that I can create an image so that I can flip it and I can turn it around. Maybe instead of flipping, I should rotate it. Let me just make a copy and then I'm just going to rotate it and make a shape out of this here. There you go. So let's see if we can use these two shapes to create and fill up more space. So I'm going to copy this, select, copy, and you can see that it starts tessellating. Do you think it will fill up all the space? So let's put it there, again, copy, and I can bring it here. And you will be able to see that it in no time, you will be, I'm leaving a little space in between one because I'm nervous, right? So I'm making a little bit of an error in the placement. Also, the outline of the polygons sometimes doesn't give you an exact view of it. So excuse me for that, but you know that they will get filled up if I am not being too nervous and I'm putting it exactly where I want it. So that is one way that you can ask children to explore and to come up with the reasonings as well, going from here. If you wanted to become more attractive, what you can do is change the colors. That is always an advantage of having manipulatives which have that freedom. So you can select, multi-select again, maybe this one, and you want to select this one and maybe another one. So you can choose to have different tiles selected and change the colors, let the kids play with it, have fun, and bring up some contrast and, design into the maths that we are looking at, because the maths need to be more fun, maths need to be more attractive for everyone and engaging as well. So that is one way that you can use custom polygon to draw a polygon and then turn it around to the need that you have as the requirement may be. So one of this case is to create such kind of customized tessellations. Let's try to explore that cutting tool, which was the most fascinating thing that I had seen. And I realized that, especially when we had gone online, we were not able to give children that advantage of doing those hands-on activities in the class. Even if they were doing, half the time, one was struggling to see whether they've actually been able to perform the task as suggested. But this definitely has made a big difference. So let's see what can be done with this particular task. So again, I'm choosing to do the same task which was talked about as how do we understand area of a polygon, a parallelogram. So for that, again, let's get to get a polygon, a parallelogram done here. So I'm looking at the grid setting on the right side. I want to bring the grid for reference. So when you click on that grid setting on the right hand side, you have number of types of grids. That's again, superb advantage. So I can take these small square grids, and I'm going to first get a parallelogram, and then we will talk about discovering or figuring out the area of this parallelogram using the cutting tool. So let's try to turn this into a parallelogram. So keeping it there, I don't want this vertex, so I click it. I can turn this around and maybe put it here. And so this will give me the corner points to follow and to have an exact parallelogram coming up. There you go, right? So once you have this parallelogram, let's fix its vertices. So select this, and right underneath, there is a fix vertices. So the moment we do that, now it has turned into a rigid polygon, which you did not have ready-made. So again, think about possible use cases as where are the problems, which cases, if you are a middle school teacher especially, there are so many times that you want children to explore areas. So areas of figures which are compound figures, you're looking at a number of rectangles coming in there, and they're put together to make a shape. And we often ask children to find areas and also perimeter. So if you have those shapes that you want, you can actually get them customized using this custom polygon. And then to cut them into pieces so that the child can recognize them to be a more familiar figure. In this case, we want to cut this parallelogram and use that piece to turn this parallelogram into a rectangle. So for doing that, again, select the polygon, and we want to cut it right here. So although we do have a line here, and actually I'm going to also use the opacity possibility to make it slightly less, dark, and I can now see the line behind it. But if you're not too sure as to where to cut, there are definitely more tools that you can have, like a ruler coming in, which would help you draw a line. So again, that would be following somewhere later in this possible tools. You can find utensils. There is definitely the word utensils, which we normally do not think about. But if you click on utensils, you will find the tools that you very often are in need of. And right now I want a ruler. So I'm going to bring the ruler up here, and I want to place the ruler exactly where I want to cut. So I'm going to just move this around here and bring it and place it exactly at this point, right? Now, if I select the polygon, then only you will be able to find the cut option. So click on the cut option right at the bottom of the screen. And now just along the ruler, you just use your cursor to draw and it gets cut. That's it. So if you now move the ruler away, you can see there is this piece that has been freed and you can come and place it here. And now our polygon has turned into a rectangle. So that is as simple as it is. And this is what was so beautifully demonstrated earlier as well, that you can use this cutting tool to, in fact, I did replicate that activity as it was being demonstrated in the previous lecture by David on area of circle. So you can use this custom tool of polygon as well as cutting tool to cover that parallelogram and then cut it and so on. And you can then talk about the area of the parallelogram to be the same as the area of this rectangle constructed. And you can always pick the pen tool if you want to draw or write and even measure and do the exploration as it goes. So I hope you've been able to keep up with this. And what I'm going to do now is give you 2 minutes to process all of that. And along with that, come and play with me, join in or do some activity on your own. So yeah, of course, there is an option of saving a file. If I want to close a file and I open another one, it always gives me a warning. Do you want to save your changes? So since I don't want to save my changes, I'm going to discard that and open a new file, which is complete the pattern, right? So I'm going to share this activity with you to try it out. For that, tomorrow's lesson, or I was like a teacher talking about lesson. Tomorrow's session will be definitely more helpful because I will be able to talk about sharing it through a classroom. So you would be able to join maybe one of my Google Classroom or a Polypad classroom or learn about how to create all of that. But right now, I'm just going to copy the link. So as usual, there is a share button. I copy that link. And if I can come to the Zoom chat and I'm going to try and paste it in the chat. And if you can access that link from there, then you can draw this or either complete this pattern, or you can choose to draw any other pattern without even having an account in Polypad. Good thing will be to have an account in Polypad so that your work gets saved. But don't you worry, you can do that later. But right now, take 2 minutes to try and do this activity. It would be wonderful if, I don't know if we have the option, but I did see in Desmos and Geogebra workshop that we could ask them to share their screen. So again, Soumya and Professor Rana, if at all any participant agrees, it would be nice.
Yeah. We can allow them to share.
Right. Good. So I'm giving everybody 2 minutes to open up that file. No account is needed. It can be worked, in any incognito account as well, which I'm going to try and show. So if you didn't have an account and I had opened up this link in incognito, I would have still got the same thing. And all the tools are there and everything is there and you can start working on it. So take 2 minutes. Let us know in the chat if you say done. Maybe we can give you access to share your screen and you can show you not only this pattern, create anything else. More artistic you get, the better it would be. Okay, so Shubhangi is saying done. She's already been doing it, I guess. So if we can have Shubhangi presenting what she's done.
Yeah. Soumya, can you give her the right?
Yeah, she can do it.
Yeah.
Should I stop sharing or she can override?
No, I think you have to stop sharing.
Yeah.
Okay. Yeah, let's have Shubhangi's.
Yes, I'm trying to share. 1 minute. Can you see my screen?
Yeah,
yes,
absolutely. You did keep up with it. Yes. So do try and create something new for yourself if you would like to, and try the custom polygon tool as well, perhaps. Anyone else who would want to has created something different. So you can see how easy it is going to be when you use it with your children. But with the children, there is also going to be a possibility to have them all in a classroom, so that you can see their work from, asynchronous as well. It doesn't have to be that they are sitting in front of you and showing their screen. So that's coming up tomorrow. Okay, so if nobody else is ready to did some pattern, Sharda Bhatt, would you want to share, sir, or shall we move ahead? Okay.
Yeah.
So Soumya, if we can have one more. Oh, that's another pattern coming up there. Yes. Absolutely. So do you think the children would enjoy creating, right? Even if it is something just as a pattern, which you can ask them to create some artwork, some just some kind of exploratory activities, definitely. Yes. So you've definitely chosen a lot of other shapes as well. So definitely there is a whole lot of possibilities, when we start with the patterns and we think about bringing in these explorations with our children. Students definitely amaze you sometime with the possibilities. And of course, not only polygons, there are also under the polygons, under the geometry itself, you will find there are a lot of tiles, lot of types of tiles that are given, which you can use just as a recreation activity. So pentominoes are there. Tangrams is something which is very, very popular. And classic tangram is also there, but along with that, even the magic egg. So you can try to find all different patterns that children can create, or you can create using tessellations, which I had not explored earlier, when you had them in an egg shape. Penrose tiles are there. So again, a lot of possibilities that you can create from here. And then, we're looking at opening this whole Pandora for them and saying, okay, treasure box that, okay, go ahead and explore from there. Going back to our what we were doing earlier and taking it step by step, we are looking at another interesting thing that was talked about, and I had kept it in my list also, was how you can use these polygons to explore cubes and nets of cubes. So let's try one of those activities. So if I choose a polygon here and I want to create net of a solid, and for the time being the cube, so I can definitely take this and copy. So 6 of them coming in, and you can then place them around and start exploring whether they are going to create a net of a cube or not. So here is possibility that I have 6. So obviously, if I put them down like this, do they always fold up to be a cube or not? So let me just copy them and put them in different positions, and we'll try to explore them. So all you have to do is select all of them and write down. You will get varied options, and one of them is fold net. So if you click on fold net, it just wrapped around, but is it really a cube? Hold it and turn it around, and you will see what happened. This is not forming a cube as a closed cube. So this is not what we call as a net. So then we can have more explorations left for children to do. You can ask them, what should I do? Where do you think these little 6 faces of the cube be placed? So again, if you give them as an exploration, perhaps they might come up with some examples, some possibilities. And it is so easy to explore. Even if some of them are going wrong, it's perfectly all right, because the student will not get disheartened by that failure. What happens otherwise in our cut and paste activity is it takes a lot of time. And once it doesn't work out, we just say, okay, no, it's really cutting into the class time and we want to move on. But these explorations goes pretty fast. and very, very smooth. What you can also do is keep some work ready in advance, just like this activity that I gave you. And there you can ask the students to do the exploration. So you can have an activity sheet like this created. So again, this will be one of the features we will talk about tomorrow. But this is as simple as this. You have some nets here. Some of them fold into a cube. Some of them do not. So you can give them some, and then you can ask them to create more, or search and figure out how many nets can be created for a cube. So have we covered all of them or not? So if you pose them as an exploratory question to the kids, it would definitely open up a lot of discussion, a lot of possibilities. And just as the one, in fact, I really love the example which was taken up by David, where his 11-year-old child was asked to think about, net being given and what kind of, whether it will fold up into a certain polyhedron or not, which is something we, at least in our day-to-day classroom activities, we do not do them for most of the time, because we feel that we will not be able to do justice to it. But this opens up a lot of possibilities. So if I take the A1, do you think that will close? Because I think tried it earlier, so it is already giving me the net and it is folding up. But don't just go by the look of it. We have to ask the children to move this around and see that it remains closed from all the sides. So like that, maybe take a guess. Which one will not fold? Maybe you can use the chat and we can try it out. We have already seen G doesn't fold into a cube. Which other one doesn't look like that it will fold into a cube? Let's see if we have any answers in the chat, if somebody can share. Take a guess. We'll just try to fold it around and see whether it will or not, because not all of them are meant for that.
Make a random guess. There's no harm in guessing.
Yeah, absolutely.
Learning starts with guessing.
And especially now when we can just undo it, that is easily there. So Shivangi says D and K. Okay, so let's try D and K. So if we take...
Yeah, D, K and G. 3 are choices.
So let's fold that and see what happens. So D definitely doesn't. So again, this is something where that spatial skill need to, it gets sharpened. You can tell the children as to what did you understand, what did you try to visualize and see what will not close up, right? So that kind of a possibility. And somebody said K, so let's try K. Let's fold this and see what happens. So again, one edge is just, one face is just standing up and it is not closing down. So definitely you both were right. And I again, think about it. Could you do this earlier, in your classroom? Perhaps not. You could only have the answer ready, but you could not actually take the cutouts to the class and do this folding for all the time. Maybe the ones which do fold up, we definitely take to the class, but not the ones which do not. So this is one of the possibility which I thought can easily get aligned to any of the middle class discussion, and you can, make your lessons much more enriching from here. So definitely think about doing this or trying this on your own. At the same time, if we go back to the tiles, you will find that there is something called as a 3D solids. So you can always bring more platonic solids into the discussion which are ready-made. So let me just zoom out on that and show you. So this is what you have, right? Now this, if I again select, it will give me an unfold option. So you can easily, beautifully show the nets of all these polyhedras and things that we, again, as I say, I'm saying this out of my own experience, that we often do not discuss just because we don't have that manipulative, which is easily accessible. Even if it is there in a maths lab, sometimes we don't perhaps have access, or we don't have it readily available. Sometimes we don't even have it. But take a look at how beautiful this is. So that's, as demonstrated, these are things which are not so easy to do in a paper, and you will find a lot of web resources who perhaps would also support this. But this is a multiple thing, right? You can just jump into it, do the discussion, and then move on to your calculation or working, etc. So definitely do try and explore what you can do with this. Okay, so getting to the next one, trying to keep up with the sequence. We have talked about utensils earlier in terms of the ruler. But one of the things that was often asked by my own colleagues and many other math teachers was, how do we do constructions with our students in the online environment? And even if schools are reopening and hopefully we will be back to normal soon enough, there is going to be a section of students who are going to be sitting at home. So how do we even now teach them those constructions where you want that skill of putting a compass, etc.? There aren't definitely some other tools, but Methigon has also kept up with this demand and has added in these tools where you have a ruler, you have a protractor, you also has the right triangles, that set square as we call it, and you have the compass. So you can do some of the constructions, and I'm going to demonstrate just one of them, and then you can see whatever your need is and you can try it on your own. So I'm going to take a very basic construction of perpendicular bisector. So if I want to demonstrate to the children that I can definitely take a ruler and I can take a pen. So I'm going to try and get the color changed so that I can make it a little prominent. And let's try and draw a line right here. So this is a 5 centimeter line, which I have got, and I want to take the perpendicular bisector of that. So usual method of taking the compass and then putting the compass at one end point and then opening it to be more than half the length. So a little bit of accuracy might be lost, but you can try to keep it, the sharp point exactly at the tip, and then bring this, bring this compass again, dragging it with this black point. So if you select the compass, use this to change the radius, right? So we've got opened it more than half the length of the line segment. And to draw the arc, which could be the circle, you will click on the pencil part. That is the little thing that need to be known. So you will click on the pencil part and then make that arc. So this is what you tell the children as well, right? You hold the compass correctly so that you don't change the radius. One of the things, well, I should have asked David, but maybe another time, but I could not flip the compass around. But you can bring the compass to the other end, keeping the same radius and just making sure that it is at the tip. Hold the pencil, and now very gently we will be able to draw the circle, right? It does the job. So draw the circle, and in fact, I prefer getting the circle drawn then the arc, because most of the time children do not understand the meaning of these arcs when we bring them in the construction. Why do you think there is going to be a perpendicular bisector coming in, or why are we using that arcs that we are drawing to make an equilateral triangle? So even in GeoGebra, given a choice or any other tool that I would possibly, instead of arc, draw the whole circle. So our job is done of the compass. We can remove that from the screen, and we can take the line tool. Right here there is a line tool as well, and I can click on this point and I can just draw that line, or I can use a ruler and draw the line, and I will have a point of intersection as well, marked somewhere on the top. So let me just do and get that point of intersection marked here. You can use the pen tool to also label it if you want to be A, this could be P. I don't have a stylus right now with me, but this could be P, this could be Q, and you are looking at your construction being done. If you want to demonstrate, you can use the ruler and you can definitely try and check the lengths. Ask the students to, since this can go as a worksheet, when the students submit to you, they will have it labeled, and all the lines, segments, lengths, etc. can be marked as well. So definitely there is a lot of value as far as our day-to-day classroom concerned, a lot of value in these tools. which you can put to use and make the best of it for a given situation. So moving down, what else do we have? We have pattern and art. As demonstrated, you have the tantric styles. So again, if you want to give them some task to just be, have a brain break, because online classes are definitely very, very exhausting at times. So you can use this as yourself, or art integration when we think about, because there's definitely always a talk about, bringing art in maths. So you can think about using the column tiles, and maybe you have a child in your classroom whose mother or grandparents, they create this art on the floor, or the child has picked up. You can ask them to do some research on the history of it and how it is seen in certain parts of India, and how it is used as a auspicious rangoli that we often think about. Moving further, because there is so much to explore. So let's keep rolling. And we are looking at next is numbers. So numbers have all different options of number tiles, number bars and frames. Then you have number cards, prime factors. I think it was very well demonstrated by David also. I will also take a quick, not too much time, but a quick look at that. But number tiles, when you think about, again, if you are a middle school or primary school teacher, you might find this to be of great use. When you're looking at number tiles, so in this case, let's see, just copy it and make it to be a sum number. Let's say this is 20, and then I bring in some units here. So let's say, let's change it to 24, right? Now, if I have this, if I select all of them, you will find right at the bottom something called as merge tiles. I can merge them and it becomes one number, which is nothing but 24. So what one can demonstrate from here, if you pull this out, you can see that it has now become 12 times 2. So factorization. 12 times 2. Can we make it to be any other factors? Again, play with it. The moment it becomes a full square, we are now looking at it to be same as we have 8 times 3. Can that be done in any other way? So let's try and change that around and see where does it become again a full rectangle. So again, it is turning into the 6 times 4. So these are the possible explorations you can have. You can have 2 times 12 and a 12 times 2. They both give right to the same. So area model, as we are looking at, can be brought into discussion. If I remove one of the tiles, so if let's split this again and then remove one of these, now I'm thinking about the number 23. So instead of 24, now I have 23. Can we make some factors of 23? So again, if you do the same idea of selecting all of them, merging them, and trying to see if I can complete the rectangle. So this is something, again, as was being discussed, it is very important to have these visuals coming in when we think about factorization and we say, well, 23 is a prime number. What is the possibility? One possibility is you can only have it to be same as 1 into 23, right? If I can keep stretching it downward, horizontally or vertically. So that is the difference between a number like 24 and a 23, or 123 and 124. It's as easy as it would go for you to think of, no, 123 can still be written as 41 into 3. So you can, extend that exploration to that it doesn't really matter. I can still double them, copy them, and turn them around into numbers and explore whether the number is a prime number or not. So that is one advantage of using this. You can also have the entire 100 grid here. And if you want to use this for your discovery of factors, or for very younger ones, when you are talking about place values, etc., you may be in need for such kind of grids. Same goes for number bars and frames. So these are, so if you are not I would say junior school teacher, you may share this with your colleagues. Tell them to look it up, because this is absolutely amazing possibility for them. Number cards we had seen also in use, and number cards again will be used maybe later as I bring in more tools where we had those balance and equations. But number cards are definitely something that you can use or refer to as where, okay, let me bring one of them. So let me bring this 3 here and a 12 here. So if you want to talk about maybe addition, you want to, so there are two things which I thought of illustrating. One, when you're looking at 3 and 12 directly here, they are two independent number cards. Suppose you stack them one over the other, it clicks and becomes 15. But it will not do for everyone. There is something in the setting which you can change so that they don't add up. So let's talk about that before I assume that everybody knows it. So under the setting, the very first option is merge number types. So because it is activated, the two number cards got fused together and it showed you the sum. Now let's bring that in. So I have a 3, I have an 8, right? Now if I take 8 over 3, it doesn't add up. So if you want to illustrate the sum, you might have to think of it a different way, or if your purpose is to have them joined together as you put them together, you'll have to come to the setting and click on merge number types. Then only these two will click together and will become 11. So as we do some balance activities, as the case may be, maybe you would find that to be useful. Prime factor circles, it's an amazing, I had not realized what a power this might be, but a simple task like finding the common factors of big numbers. So again, let's try to think about what exactly is in these numbers. So if I bring this number here, 18, it's made of all the possible prime factors. So if I pull this orange part out, which represents 2, then I'm left with green, which is actually 3 and 3. So 3 into 3 and into 9. So you get all the prime factors here, right? Go back and stack them together and it turns into that same composite number 18. If we look at the demonstration of finding the common factor, so if I take two big numbers, which I noted down to be the same as what was shown by David, so I'm just bringing that same advantage of going through his lesson. So here's 336. So, and you take another big number. So how are we creating these big numbers? Is just by typing it right here on the right panel there. The other number was 1260, I think. So let's bring these two, and we wanted to find the common factors. So where do we start? I hope you've got it now. You're just going to put any number. So you look at your textbook questions. So there are so many questions where we are talking about the highest common factors. So if you want to start this concept with the visual representation, this is the tool to go for. And you can start talking about starting with the discussion again, since everything is so visual in the terms of the colors. It would really be helpful for the children to use this and to talk about, okay, this one, I was just too quick on doing that. So this one had a 2. Does it also have a 2? So yes, so 2 is a common factor, right? We can have another 2 coming in and another 2 coming in from here. Now I have a 2 more 2s because I have these orange, but this doesn't have any orange. So there is no 2 coming as a common factor from there. But you can think about perhaps again the purple and the green. So I have one purple, which is 7, and I have 5 here, or no, that was 3. Green is 3. Do we have another one? So let's bring that up here. So this definitely also makes sense. So you have 3 and 5, and you're looking at 3 and 7, and you're looking at 21 just to save time on it. So you're looking at that now, they both, these two as here, there's absolutely nothing more common in it. So these are the common factors, and the highest common factor then can also be talked about as to what you have paired up here. So that is, again, to start off a lesson on factorization and then taking them to the highest common factors. This can be a great visual for you to start with and ask the children to explore as well. Okay, so coming to now.
Sangeeta, can you wind up in 5 minutes?
Yes, sir. Because tomorrow also we have so much, so
Yes.
we will definitely we will focus on that.
Yeah, sure.
So I'm moving to integers directly from here, so that we can leave you with one small activity to try on your own as well. So integers addition has always been, I would say, a struggle for teachers to explain how integers work. So in the algebra tiles, you'll have a 1 and a -1, right? And if you just copy and make these tiles, again, you can have a grid coming at the back also, just to support you to put them. Let's pick the smaller grid, and you can put these and you can have a visual representation of addition of integers. So use these orange tiles. Suppose I didn't have a pink one. What I can always do is select all of these, copy, just let's bring that down, and you also have a negate button. So if you click on negate, it will become -1. So how do we use it now? That question is still there. So suppose you want to demonstrate to the children what would be let's say -2 plus 3, right? I'm starting with simple numbers so that I don't copy and paste more. You can extend that to as many. What this does is it helps you pair a +1 to a -1 and turn it into a 0. So to do that, you can select 2 negatives from here, and let's copy them. Let's bring them down, and let's take 3 positive ones from here, copy and bring them down. And then think about what will happen if I take these 2 negatives and overlap with these numbers. What am I left with? And that is where you can start the discussion off. So just again, instead of letting the kid know, we often talk about moving back 2 steps, etc. Those still options remain. You can have even a number line coming in, and you can try and explore. So again, keeping the time restriction in mind, what I'm going to do is I'm going to share this little task with all of you, which you can use and see how it can be helpful for children. So this is again coming as a worksheet, which is going to be very, very definitely of interest to everyone, because it's a kind of a self-assessed sheet, right? So you create it and you give it to the kids, they attempt it, and they get immediate feedback. So tomorrow's session will be on how do we create such worksheets. So I'm just coming to the chat and putting the link of this worksheet. Hopefully you will try it and would like to learn about how to create it. So you have the option of using the number line. So you can take going -4 and then coming back 9 steps and reaching your answers. You can use the number tiles to do the same exploration, right? So go ahead, try it out, and let me know if you have any more questions before we close this session. And I'll see you tomorrow at 1:45, if I have got the time right? 1:45 is again the second level session on Polygon, where we will explore so much more. And we will also talk about what can you do if you are a teacher of grade, say 10 or 11 and 12, where you want graphs coming in. So we didn't talk about graphs. We didn't talk about dynamic geometry. Is that possible or not? We'll be doing that tomorrow, and also how to create this kind of a worksheet.
Thank you, Sangeeta. Anybody has a question to ask for today's session, or you want to reserve it for tomorrow?
Yeah, try it today and you can come back with questions tomorrow.
I just want to share my screen with you. I want to put a problem let me see where it is gone. Oh, sorry. I think. Oh, what did I do with that? Did I close it? Okay.
Was it on Methigon?
Yeah, Methigon, I opened it.
So if you have got the account, it will be saved there.
Yeah, no, it is an account, and I didn't close, I think, that session. Time, Desmos. Oh, I just created something wonderful. I thought I will share it with you.
Oh.
Okay. I think maybe tomorrow I'll put it at a secure place and maybe it's there. I don't know. No, I think let us not waste time because there is a next session coming up.
Right.
So I will show you tomorrow that thing.
We'll look forward to that, sir.
So please take care and wait for the next session. That is on presentations by teachers.
Right. Thank you so much. Thank you for the opportunity, and everybody please try it and come back tomorrow with the questions, and there's so much more to cover.
Right.
Bye-bye. Thank you, sir.
Bye. Thank you. So we meet at 7:50, about 10 minutes gap to freshen up, to have a cup of tea, coffee, or a cold drink, and come back for presentations. हाँ,
वही बोल रहा हूँ, पूछ रही हूँ।
If you are still in the session and you can hear me, this is what I have created with the polygon tool of Mathigon. And there's an interesting, what is the interesting thing? Each piece can be fitted into, okay, for example, it fits here, okay. So it is what is called self-locking tile. So I have created self-locking tiles, okay. For example, I can create a copy of this and I can take it and I can add it here. So it fits nicely. So the question is, you try to create your own self-locking tile, okay. So think about it overnight, and we have got 3-4 minutes for the next session to start. So I will stop sharing. This is the kind of self-locking tiles one can make. Okay.
So this will fill the whole plane, right?
Yeah, any plane means you can just copy any one of them. So make a copy. Sorry, make a copy plus. Now you can fit it. Okay. So it fits in here. So you can go on fitting the same thing. It is a tile which interlocks with itself. So these are called interlocking tiles.
So you followed some particular algorithm, right?
I used to do it in a paper, scissor and something. Now that is what I was asking for us, how to cut it kind of a thing and how to do it. See, I have made straight cuts. One can make it actually any curve and then do it. So very beautiful tiles, self-locking tiles can be made.
Yeah, yeah.
So let me stop sharing because next session is to start. We have got 1 minute. So Jonaki?
Yes, good evening.
Yeah, fine. So you will be chairing the session for each presentation, 10 minutes, 2-3 minutes for question answer. Is it okay?
Yeah, yes.
Yeah. Do we know who are the people? Are they there?
Just give me a minute, sir. I'm just.
Yeah, I was.
Yes.
Yeah.
So the presenters for this session are Imdad Ali and Samiran Das, who have a joint paper, Varsha, Rajesh Raut, and Bhakti Velankar. So they are the 4 people who will be presenting.
So Imdad Ali, are you there? Hello.
I think Samiran Das is here.
Okay, Samiran Das.
Hello.
Yes.
Sir, are you audible?
Yeah. Who is it?
I'm Mr. Imdad Ali.
Okay, Imdad Ali, you are the first presenter. Next, who is?
Yeah.
Janaki?
Varsha,
Varsha,
is
you
there.
there?
Yes, I'm there.
Varsha is there then?
After that, Rajesh Raut.
Yes, madam, I'm there.
Okay.
Okay.
And Bhakti Velankar.
Bhakti, are you there? Bhakti Velankar? She is there.
No, I don't.
No, she is there, but her mic is muted.
Right, yes.
Okay.
So,
yes, she's there. Yes.
Yeah,
So we'll start with Imdad Ali.
And she will join in between. Yeah.
So the order is Imdad, then Varsha, then Rajesh and Bhakti. That is the order mentioned in the schedule also.
Santanam sir, have you joined? Santanam sir?
Yes, I am very much here.
Very good, sir. Thank you very much. So let us start. Junaki, you start.
Yes. So I'd request every participant to present your paper for 10 minutes, and then we'll have 2 to 3 minutes for question answer. So you can start Imdad Ali.
Thank you, ma'am.
You can share your screen.
So good evening.
Good evening. You want to share your screen?
So, yes, I am going to share my
okay,
screen.
Fine. Continue.
So is it visible? Hello.
Yeah.
Is it
Yeah,
visible?
yes, yes.
Good evening, our respected chairperson, guests, and other participants. Myself Imdad Ali and my supervisor is Dr. Somrion Das. I am going to present my paper. The title of the paper is The Relationship Between Study Habits, Parental Involvement, and Problem-Solving Achievement in Algebra at a secondary school level.
You can maximize the screen if you like. Yeah.
Okay.
It's okay. Go ahead. If it's not possible, let's not waste time.
Okay. And stack of the paper is this. The present study aims to study the relationship between the study habits and parental involvement in problem-solving achievement in algebra. The study employed a descriptive survey design. For that purpose, a sample of 200 secondary school students in class 9 has been randomly selected. A problem-solving test in algebra and a questionnaire are used to collect the data. The problem-solving test is done to determine the algebraic achievement of the student. Also, the questionnaire is designed to find out the student's study habit and parental involvement. The collected data is analyzed with the help of SPSS 26.0 version. Pearson's correlation and regression analysis are used to analyze the data. The results showed that a problem-solving achievement and study habits and parental involvement are positively related with problem-solving achievement had a positive relationship with the following aspect: study habit, parental involvement, and simultaneously with study habit and problem-solving parental involvement. Also, the obtained regression equation shows that study habit significantly contributes more to the prediction of problem-solving achievement in algebra. And the keywords are algebra, study habits, parental involvement, problem-solving achievement.
Can
Introduction.
I suggest that you sort of show us your objectives and aims and then go on to the actual study because time is limited. Thank you.
Our objective of the study is to examine the relationship between the students' problem-solving achievement in algebra and study habit and parental involvement, to determine the relative contribution of the study of student study habit and parental involvement to the prediction of problem-solving achievement in algebra. And these are our objectives. And the research questions are: is there a relationship between the variables study habit and parental involvement with problem-solving achievement of student in algebra? Second one is there any significant contribution of prediction, predictor variables these are study habits and parental involvement to the prediction of problem solving achievement in algebra and methodology. We have used here descriptive survey design sample 200 class 9 students of Morigaon districts has been considered as a sample of the study instruments. A problem solving test is done and a questionnaire is and we have prepared a questionnaire for collect the data of student study habit and parental involvement, and collected data were analyzed with the help of SPSS 26.0 version, and collected data has been analyzed person correlation and regression analysis. Results and discussions. From these tables, this in that students study habit and parental involvement and problem solving achievement all are correlated to each other at the significant level of 0.01. Also, all the predictor variables are also statistically significant at the level of 0.01. And table, I'm going to discuss about the table 2, the contribution of study habit and parental involvement or problem solving achievement. From this table, the value of F is highly significant at 0.000. That is significant and 0.01 level. So our model is highly significant. And from the table, we have found the value of R square is 0.485. That is the contribution of the two predictor variable to the prediction of algebra is 48.5%. And the other remaining 51.5% is influenced by the other variable. And simultaneous relationship among the variables. From the ANOVA table we have seen, and the value is here also statistically significant at 0.01 level. So there is simultaneous influence exists between students' study habit, parental and parental involvements to the prediction of algebra, algebraic problem solving achievement. And table 4, multiple linear regression for algebraic problem solving achievement. Here the study habit and problem solving all are all the value of T value of this study habit and parental involvement are statistically significant, and they are unstandardized beta coefficient all are positive. So there is a positive correlation between study habit, parental involvement, and problem solving achievement.
You have 2 minutes more, please. Okay.
And since all the beta coefficients are positive, so students' study habit and parental involvement has a significant positive contribution to the problem solving achievement of algebra. And from the regression table, we have find a linear equation of regression linear equation. This from this linear equation we can conclude that study habit has a highly significant contribution to the prediction of problem solving achievement of algebra. And conclusion. So we have found some statistically significant results. Student study habit and parental involvement have a positive relation to with problem solving achievement of algebra. And also from the regression equation, study habit have a significant contribution to the prediction of problem solving achievement in algebra. From this study, we can conclude that students' better study habit and more parental involvement lead to their better achievement, better their achievement in algebra. And these are the few references. Thank you.
So, are there any questions?
If nobody has, then I will ask one question. If somebody else has it, then
I have a basic question.
Who is it?
Shomo.
Okay, please.
Yeah, so I just want to understand these two variables here, like SH, study habit, and parental involvement.
I wanted to ask the same.
What type of questions did you ask in the form or whatever you have generated, and how exactly did you quantify them, right?
Actually, I have used for study habit and parental involvement like at 5-point scales, and question is like that. Students how much they for study habit, how much they spend their study regular, whether they study regularly mathematics, and whether they're interested learning mathematics with the help of their teachers and the peers, like that type, and their parents are always help them or not, this type of questions.
So the study time, basically, right?
Yeah.
Okay. Okay. And
Somya, go ahead.
Can you quickly tell us what is this regression analysis and correlation analysis? Like, what exactly do you do?
So regression analysis is the linear relationship with the dependent and independent variables. Here, dependent variables is our problem solving achievement, and their independent variables are study habit and parental involvement.
But in this equation, if I may ask, y is equal to what is showing, what is y here?
Y is problem solving achievement here, algebraic problem solving achievement.
Well, it's okay. I think I'll let my question go. Yeah.
Anyone else has a question? So you can ask if you want.
No, I just wanted to know, because parents' involvement, it's not very much clear what parents' involvement means. Just asking a student how much your parents help. Probably the student will try to say that my parents are very good and they help me in my studies. So you'll take yes, parent help is there, right? Whether parent is able to help in algebra or not, I wonder how much parent have understood algebra himself or herself. So, and how they are able to help in algebra, because 90% of the parents are scared of mathematics and those helping. So anyway,
does this study will be same for any? I mean, you replace algebra by any other subject, will it be different?
Hello.
Yeah, I think Somya's question is, आपने जो सवाल पूछे बच्चों से, वो अलजेब्रा स्पेसिफिक थे कि किसी और सब्जेक्ट, किसी और टॉपिक में भी चल सकते हैं?
Actually, question based on mathematics, and some part of this question are based on algebra also.
Okay, fine. Okay, I think it's good enough.
Yeah.
Sangeeta,
Thank you.
Janaki, go ahead.
Yes, thank you for the presentation.
Thank you.
Now we can have the next speaker, Parsha.
Yes. Am I audible?
Yes, please share your screen.
Yeah. So, good evening to everybody. My topic is teachers is matter. So I'll be covering these 5 one by one. So first thing that I would like to talk about is practices that yielded a positive impact. So these are just 5 practices that were implemented for a group of students, high school students. So before these 5 practices were implemented, some basic calculus concepts were taught to them and a short test was conducted for them. Then these 5 practices were implemented, after which another short test was conducted so that we were able to compare their performances. So the first one is usage of GeoGebra. So this aided mainly in their visualization of equations and curves. So they were able to use very simple tools in GeoGebra that made them understand how the curve looks or what slopes could mean and all of that. Those were just abstract concepts before they implemented this on GeoGebra. So that's how it helped them. And then making charts. So this was one thing that even the students were skeptical about before they did it. But what they were asked to do was to have a chart in which they stick 4 graphs, and it's basically for them to understand Rolle's theorem in specific. So they were just asked to take 4 curves and discuss about the various conditions for which only if they are satisfied, Rolle's theorem will hold good. So they were asked to discuss about what if the conditions are not satisfied, so on and so forth. And then coding. So not all the students were very good at coding, but they were all familiar with C. So they were asked to use the sine series expansion, cos series expansion. They were asked to explain. We were explained the logic behind it, and they were asked to code it and get the output. So the output kind of improved their understanding, and they were able to retain whatever they learned for a longer duration. So, and then discussion about mathematicians and scientists. This is a very small thing that we did. I came up with this just by inspiration from my teacher who used to do this in his classes. So not very often, but at regular intervals, we used to have a short discussion, a 10-minute discussion about different mathematicians. So I tried that in one of the sessions. And then revision recreated is basically a revision session where only the concepts would be discussed rather than the solutions and all that. We would take up a problem and we would just see how to approach the problem. So for the high school students who were supposed to give their board exams, so newer questions and newer ways of approaching the problems, that was useful for them. As I said previously, this had a positive impact on their learning, and I measured the impact by, as I told earlier, I gave few tests before and after implementing the 5 practices. And we could see some improvement in their performance. And we also took some feedback from the students. So one of the interesting feedback was that they still found the subject to be difficult, but was not boring anymore. That was one thing that I felt is a positive impact, because many students had sort of an aversion towards the subject, which they didn't have after trying out some new tools. And then one of the very common suggestions was that they needed more discussion sessions, wherein they could probably discuss what they knew and then learn what is the new concept, and basically more space for interaction. That's what they wanted. And so from those suggestions, I thought I would give some that would increase the interaction in a classroom. So I feel that a session where we could discuss about the possible areas where mistakes could occur while studying a topic. This is a very, it could be a very short session also, a 10-minute session where some students can share where they made mistakes, and this could possibly reduce the silly mistakes that the students make, in the sense that they are supposed to give their board exams in a short while. So when they discuss about silly mistakes, and when we can provide an opportunity for them that would lessen the mistakes that they make, it would be helpful for them. And then the second thing would be to form a team and record a video. This, if time permits, if they could do, because it will kind of give confidence to them also as students, and teachers can also gauge the level of understanding of students of different concepts. And then there's this QUAI, that is questioning the concept, asking questions in the concept that they are learning, and then analyzing the topic based on their questions, and then implementing whatever they've learned in problems. In all of these three processes, the interaction level will definitely increase when they do all of this. So I'd like to finish by just giving one suggestion for a lab activity that could, it's basically based on calculus. So the aim is to understand how the second derivative test works in identifying whether a point is a local maxima or a local minima. This is specific to the 12th standard syllabus. So yeah, the students could draw a concave down curve and a concave up curve, and that could be respectively f of x and g of x. They could first differentiate the functions and find out the values of x for which f dash of x will be 0, and then they could mark those x values on a number line and then select 2 points A and B. And in that interval, they are supposed to find out whether f of x is a increasing function or a decreasing function. And then the next step that they have to do is to draw a tangent at different points on the curve and then find the slope of the tangent at those points. So while they do that, they'll be able to find out whether f dash of x is an increasing or a decreasing function. So first they have to do these two things. And as I said, the aim is to understand why the second derivative, how the second derivative test works. So if I have a concave down curve, then there will be a point of maxima, and wherein I'll be able to find out that. So I'll move on to the next slide, wherein results is, say, I could possibly get these results. So for a concave up curve, I would find out that f dash of x is an increasing function, and that is why f double dash of x is greater than 0. So instead of just mugging up that, if a point of minima, then it will have second derivative to be greater than 0, they could understand that the slope is an increasing function, and that is why the second derivative becomes greater than 0. Same with the concave down curve also. So similarly with the concave down curve also. So this activity I thought would be helpful for them in understanding the second derivative test. So yes, that is about my presentation. I'd like to conclude by saying that such newer tools and practices need to be implemented, and there are some teachers who still are they have an aversion towards digital tools. Some teachers are still like that. So I feel that that sort of an aversion should not exist, and they should integrate digital tools also in the coming years. And there will be definitely challenges, and one main challenge would be time, but we have to plan it accordingly and include some practices at least. Yeah, that's it for my presentation. Thank you.
Okay, so any questions?
Yes, I have a question.
Yes.
Hello, please mute your mic.
Yes, please. I have a question.
Yeah, please.
Varsha, in your paper, Varsha, you are here?
Yes, I'm here. I'm sorry, I didn't turn on my video.
Yes.
Yeah, I'm sorry. Just a second. I'll come back to the meeting and.
Okay.
Yeah.
In your paper, you have stated Rolle's theorem. Can you please restate it? Please state it.
Yeah.
Can you state Rolle's theorem?
Orally, do it orally.
Orally.
You don't want me to show the paper now?
No. Just state orally.
Okay. I thought, okay. F of x is a function that is continuous on the closed interval a comma b, and it is differentiable on the open interval a comma b. And if f of a is equal to f of b, then there is a point x such that the x that lies between a and b such that f dash of x is 0.
No, you have written for some x with a less than or equal to x less than or equal to b. Is it so?
X lies in the interval a comma b.
Are you stating Rolle's theorem or something else?
Yes, it is Rolle's theorem.
What? Please say it again. What is Rolle's theorem?
F of x is a function that's if f of x is a function that's continuous on the interval closed interval a comma b and differentiable on the open interval a comma b.
Right.
And if f of a is equal to f of b, then there exists.
That you missed earlier. You didn't say that condition.
Really?
Anyway.
No
problem.
Then you proceed.
Then there exists a point x such that it lies between in the interval a comma b, where f dash of x is
in your paper, it is x with a less than or equal to x less than or equal to b, which means x is in the closed interval ab. Am I correct?
Yes.
You are telling the same thing?
Yes.
X must be in the closed interval ab?
It's in the open interval.
Open interval.
Okay. Yeah.
And one more thing also.
Why? I don't understand. If f is a constant function, then what happens?
Then you cannot say it's a point of maxima or minima.
That comes to your question of what is maxima, what is minima. Let's not go into that.
Yeah, I think we should focus on the
pedagogical aspects.
Yeah.
So, please go ahead. You were asking something?
Yeah, I just wanted to ask you say that these tools will help them to understand the convexity and concavity. But do students understand what is convex and what is concave function?
Yes, in the sense that they'll have already, they have been introduced to those terms. So I thought that will be helpful.
Yeah, but I think what I'm saying is, before you want to analyze whether these tools will help them to understand whether they know what is definition of convexity and concavity.
It could possibly differ from batch to batch, as the batch that I had is a very small group, and I could discuss that with them.
Yeah, but the point is 90% of the books define convexity and concavity via derivatives. They don't give the definition of convexity and concavity at all. So be careful when you analyze. First, ask them whether they know what is convex, what is concave.
Okay. Yes.
Yeah.
Yes, a point.
So your study will not be complete.
Okay. Yeah, I'll add on these points in the future.
Yeah. My side, it's okay, Janaki.
Yes. Yes. So also, Varsha, right? Yeah.
Yeah.
So I just wanted to know that you took up examples, but all of them calculus-based examples, or was it one example of Rolle's theorem only which you did with the students?
With the students, I could do only the Rolle's theorem for making charts, basically. Yeah.
And but you mentioned the use of GeoGebra. So did you use GeoGebra to, show that there is a tangent in that open interval which is parallel to the x-axis and whatever? So was it shown graphically? Did they understand it graphically?
Actually, I wanted them to draw and choose some points on the curve and draw the tangent manually. Yeah.
But draw on paper or draw using GeoGebra?
On paper.
Okay. But they can't draw it on paper unless they know what is a graph.
Yeah.
And convexity and concavity helps you to draw the graph. See, you are going in circle. So anyway, I think it's time to move on to the next one, probably. Janaki?
Yes. Thank you.
Ma'am, did I answer your question?
Yes. So I was just trying to gauge whether there were, it might be a good exercise to try and see, in the same study with the same group of students or another group, whether graphically you are able to demonstrate these ideas to them.
Okay. The point is, even I got introduced to GeoGebra very recently. So to implement that with a group, I must be equipped first. So
because all these derivative tests not going to be visually, but you have to basically be very firm with the content, with the understanding yourself, and then you can create those animations very easily. Okay. Thank you.
Thank you.
Okay, next, Rajesh Raut. Please, could you share your screen? Yeah.
Thank you, madam.
Please go ahead.
I want to share the whole screen, so I'm not getting the option.
No, it's there.
It's there?
Yeah. Click share screen and it will give you the option whole screen or desktop or one particular window, whatever you want, you can do that.
Okay. Yeah. So my topic is polygons and the isoperimetric problem in the hyperbolic plane. So the problem is like if I take a piecewise smooth simple closed curve, okay, when perimeter is fixed, then among this family, which curve will maximize the area? In Euclidean plane, okay, so we are going to use same techniques which are used for Euclidean plane, but I'm going to solve this problem or I'm going to explain it using GeoGebra in the hyperbolic plane. So I will share now GeoGebra screen. Can you see that GeoGebra screen? Hello?
Not yet.
I think, yeah. So I will, yeah. So now?
Yes.
Yeah. So here, yeah. So now, if I select 2 points, okay, then in hyperbolic plane, the geodesic is like these are circles with centers on the x-axis. Okay, and so here, if I select point A and B, then yeah, we can see this geodesic segment joining A and B. So in Poincaré's half plane model, the hyperbolic plane, we model it as a upper half plane, okay, with y greater than 0. Okay. Now, first we will consider isoperimetric problem, where the base, that is one side is fixed and the perimeter is fixed. So let me open that file. Okay, so I will open a file. Where yeah, one side is fixed and perimeter is fixed. So can you see this file?
Go ahead.
Yeah, okay. Yeah, so here I will start like this. I will start with point A here, okay, and point B, okay. So let me, yeah, and then I will construct the geodesic segment joining A and B. To construct this geodesic segment, yeah, since it is a semicircle and these A and B I have selected so that they are symmetric about the y-axis, you can get this semicircle easily. Now at point A, I will construct a hyperbolic circle, and yeah, so its center will be a point. The x coordinate will be same as x coordinate of A, but the y coordinate will be, I need to multiply with cos h and this radius A. Okay. Then I will fix a distance, that is at point B. I will draw a circle with radius 2 minus A. Okay. And now what I can do, that I can just using the slider, I can just keep on changing this value of A. Okay. So this way, what will happen if you look at the angle at A, I can go from 0 till whatever possible values. Okay, so it includes all possible triangles where base is fixed and perimeter is fixed. Now, in hyperbolic plane, the area of triangle is pi minus sum of the angles. Okay, so these angles in GeoGebra I can measure. And
Rajesh, just 1 minute.
Yeah.
What is the closed curve you are taking in the hyperbolic plane?
Sir, I'm not getting your question.
You see, isoparametric problem you are studying.
Yeah.
So what is the curve for which you are trying to analyze, right?
Yeah. So I'm first solving the problem for all triangles where base is fixed and perimeter is fixed.
Yeah. So you say that it is a triangle with fixed perimeter, right? That is the.
Yeah. Yeah.
Fine. Go ahead.
Yeah. So now perimeter is fixed, and now what I will do, I will just I will use this slider, and this F is measuring the here I have, if you see this E, it is gamma minus alpha minus beta, and this angle gamma is in fact pi minus angle at vertex C. So it is in fact pi minus the three angles. Okay, and we can see easily when I move this, that maximum value of F is when this point comes to the on the y-axis. That is the base angles, that is angle at A and angle at B, they are equal. You can see here it is 48.97 degrees and 48.97 degrees. Okay. The next thing I will open here, so GeoGebra helps to demonstrate this. Then I will open next file where I will now consider family of triangles where two sides are fixed in length. Okay, so let me open this. Yeah, so here again what I will do, I will start with point A, and let us fix this point at I. Okay, and I will just draw a circle of radius say 1. Then on the circle of radius 1, I will fix a point B, and I will again draw this black circle of another radius. And then when I move this B, then what happens now, this geodesic segment AB and geodesic segment BC, they are fixed in length. Okay, and the geodesic segment joining A and C, which is along y-axis, that is now varying. Okay, so third side is allowed to vary. Now the result is among these family of triangles, the area maximizer will be the triangle where the midpoint of this third side, which is varying, okay, is center of the hyperbolic circle passing through these 3 points A, B, and C. And here again I have here again I have this point G, which is measuring this area of the triangle. And so when this midpoint so F is in fact Euclidean center of the red circle, which is passing through A, B, C, and hyperbolic center will be just below it, so it will be on this line, and it will be a midpoint. Yeah. Then yeah, so this help us to next prove that when we go for this result can be generalized for n-gons, where we have suppose polynomials. Suppose we have polygons with n sides fixed and uh, except one side is fixed. Then the area maximizer will be the uh, uh, circle. Area maximizer will be polygon, where the all vertices will lie on the circle with midpoint of that remaining side as a center. Okay. So when we go for construction of regular polygon, so that is the next one.
Your time is up, but you can quickly show this one, please.
Yeah, thank you, madam. So here I need to use equation that is so here yeah, I will use this equation, that is parametric equation for geodesic. So I will just draw the geodesic from I, and here since I am drawing a regular polygon, that is a regular the triangle. So I will fix a angle 2 pi by 3. Okay, so first here the angle is 0. When I draw this, then I will take 2 pi by 3, and for next I will take this is as a yeah. So and so I want to say that GeoGebra helps to demonstrate these things. Yeah, thank you.
Thank you. Any questions?
Can you stop sharing the screen, please?
Yeah, I will stop sharing the screen. Yeah.
Yeah, if nobody asks question, then I'll be the last one. So please ask others if they want to ask questions.
Please go ahead, sir.
Go ahead. Okay. Rajesh, there are two questions. One, these applets that you made or you downloaded?
No, I have made it.
You have made this yourself?
Yes, sir. Yes, sir.
Good.
Thank you. Thank you, sir. In fact, sir, I have that spoken tutorial course I have done, and from there I learned how to do the slider, and remaining calculations I have done.
No, that is fine. Learning from wherever you learned, that is not really important. It's important that you have learned and you have done it yourself. And now, do you realize that is there a difference? It may look like instead of a hyperbolic plane, it may look like a ordinary plane with polar coordinates.
Sir, I selected that because then that background, it is easy to explain what are the geodesics.
Yeah, but will it not confuse students that probably you are doing the polar coordinates and trying to do that? Of course, your triangles don't look like ordinary triangles. They look like triangles in some other geometry. But surely that needs to be clarified whether in GeoGebra that does represent hyperbolic plane or not. That is thing. Okay. The second thing, whatever conjectures you are making based on your GeoGebra files, are you making these as illustrations of known facts, or are you trying to do conjectures and prove?
No, they are not conjectures, they are proved, sir.
They are only for illustrations. They are already known facts.
Yeah, they are known facts. I am just using GeoGebra to explain them.
Illustrate those facts.
Yeah.
Fine. Thank you.
Thank you, sir.
My thing is over.
Yeah, I just had one quick clarification. So do you teach this topic to students and have you tried it using this medium or?
No, in Euclidean geometry, I have explained this. Okay. But in hyperbolic, still I have not done presentation in front of students.
Yes. At what level would you be teaching this concept in hyperbolic planes?
To degree
college.
Okay, so I think it's quite fascinating to see that complex ideas can be represented nicely on GeoGebra. And so thank you for that.
Thanks.
And Bhakti.
Yes, ma'am, I'm here.
Yeah.
Okay.
Yeah.
So shall I share my screen?
Yeah, please.
Yeah, please go ahead.
So is my presentation visible, sir?
Not yet.
Not yet. Not yet. It says has started sharing screen. But...
Yes.
Is it visible?
No.
Still not yet.
So are you sharing the whole screen or?
Yeah, yes, whole screen.
Yeah, it's there. Yeah, please.
It's there.
Yeah. Your presentation is coming via a bus. So
Okay. There is. I'm sorry for that. There is a network lag here. So
no problem. Please go ahead.
Okay. So I'm keeping my video off just in case the network drops down. Okay.
Yes,
so
sure, sir.
Good evening, everyone. I am very glad to present as a paper some of the methods that I use in the classroom teaching using technology. So out of the 5 themes of the conference, I am presenting a paper under theme 1. I have been teaching in an undergraduate college for 17 years, and I want to share some of the resources that I use for teaching mathematics. Thanks to the Department of Biotechnology grants, which we received in the year 2017, our college has purchased license for Maple software. So for some years, I am integrating some of the resources from Maple into my teaching. Here I have noted down some of the problems that a common undergraduate student has in learning mathematics. Many times they come with incomplete knowledge of basic definitions. There is a complete lack of visualization, especially for students who come from places other than cities, maybe remote places in India. We have such students in our college also. Poor retention of knowledge as they find undergraduate mathematics as a dry subject. In an attempt to overcome these and develop interest in the course, I try to use Maple software for illustrations in the classroom. Maple is a symbolic and numeric computing environment. In my presentation, I will discuss some of the topics where I use Maple. The first one is epsilon delta definition of limits. This is probably the first definition in an undergraduate curriculum of calculus that uses there exist and for all notations in a formal setting. So Maple here provides with built-in applets. These applets are known as maplets. So I will just demonstrate those maplets here. Let me share them. Okay. So these maplets are inbuilt. When we download the Maple software, these maplets are already inbuilt. Now here I have, is my maplet seen, sir?
Yes.
Okay. So in this maplet, we can see that we can fix epsilon value and get the corresponding delta value. This provides the much needed visualization for them. So I can demonstrate it here for you. So here the maplet comes with option of choosing function. So there are 5 built-in types here: linear, quadratic, cubic, inverse, or a step function. So we can choose whichever function we want here. C is the point at which we want to determine whether the function fx has a limit. And the C value can also be changed using the slider. A slider is provided to change the C value. Now, to fix the epsilon, we have to just click on give me a new epsilon button. So now here, epsilon is chosen as 0.22. Now here, the task given to the student is to choose a delta small enough such that whenever the distance between x and c is less than delta, that means c is in the delta neighborhood of x, fx should be in the epsilon neighborhood of L. Now here to explain them, we can take an example as this blue strip is a river and the purple strip is the bridge. The function is illustrated in green here. It's green here. The green function must cross this river only when it is on the bridge. Now in this case, with the chosen delta here, it doesn't happen. But then the students can just scroll this down and decrease the value of delta, make it smaller, and this delta works. Now for this chosen delta, we can find that
fx actually goes through the purple patch. And if this delta is not possible, if we are not able to find such a delta, the conclusion will be limit of the function does not exist. So this is the way I usually illustrate. Once I do the problems in the class, I illustrate this, I demonstrate this maplet to them. The another nice example for which I will use maplet is for sequences, to study convergence of sequences. So here there is a maple applet wherein you can type in your sequence here, or there are some sample inbuilt sequences also here. So you can change the values of n here. Now, as you can see, as I increase value of n slowly on the slider, the sequence slowly approaches 0. So as n increases, an approaches 0. That means the sequence is convergent and the point of convergence is 0. We can change this value, maybe something divergent, an equal to n. Now here clearly students can identify. So whatever n I take, when the n increases, an also increases. So clearly the sequence becomes divergent. We can enter some value here manually also instead of using the inbuilt values. So I can put sign of n here. And then whatever n value we increase, clearly the sequence becomes divergent. As we can see, there is no point where the sequence will converge. So students are given this maplet in the lab. We have a lab where students actually work with this, and with different functions, they check the convergence of functions. Next, I will also illustrate another maplet on Riemann sums, upper and lower Riemann sums. So here, to find out upper Riemann sum and lower Riemann sum, there is a maplet available wherein you can type in the function. So it comes with changeable parameters. The parameters here are the function, the domain. You can select the domain. Here I have selected -1 to 1 as the domain. We can change this domain. Then n is the number of partitions. So here the number of partitions can be increased or decreased. Now the students are motivated here to see that this maplet actually comes with total area approximated by the rectangles and the actual area which we get computationally. Now students, usually in the class, I tell the students to observe this fact that when n increases, that is the number of partitions increases, then the actual area and the total area become approximately the same. More the number of partitions, more accurate is the area. Here we also have an option of getting upper Riemann sum or lower Riemann sum, left Riemann sum and right Riemann sum also. Here again, students are made to understand that whatever partition we choose, irrespective of the partition, any upper sum will always be greater than the lower sum, even if I change the partition. That is a standard theorem. So the theorem can be verified by changing number of partitions number of partitions and then checking whether lower sum and upper sum are different. So this is one of the way I teach upper and lower Riemann sums in the class. Another maplet which I want to illustrate is from discrete mathematics. Since we have a paper of discrete mathematics and I teach for computer science course also, so they have these sorting problems, sorting of arrays. So here Maple has this nice applet which compares different types of sorting algorithms. So there are so many sorting algorithms. So the maplet comes with the method of the sorting, time complexity which is required, and the code also, implementation code is also given. The fun part here is that students just enjoy this. Here you can select the method of sorting. Like here, suppose I select bubble sort, and then speed, I'm keeping the speed of the animation as maximum. An array, a random array of 10 elements can be selected from here. So now we have a random array of 10 elements. And once I click the sort button, the animation starts here. Now I tell the students to count the number of iterations required for the array to get sorted. And then I change the type of sort here. So now the bubble sort is done. The array is completely sorted. So then I tell them, why don't you verify with quick sort? How much iterations are required for the array to get sorted using a quick sort method? And then they can physically check which sorting method is the fastest. So this is one of the way I use this maplet in the class. There are many other features of Maple. One of them I have illustrated here. This is the home page of Maple. It comes with around 10 platelets here on the left hand side. You can see the platelets here. It comes with many built-in packages also. These packages are inside the tools menu. So under the tools menu, there are so many packages available. I will just show those packages here. So go to the tools menu. Here we have a load package option. So under this load package, there are several packages which are inbuilt, which are already available. It includes graph theory, number theory, optimization, partial differential equations, plotting tools, calculus, and many more. So whichever tool we want to use, we can just load that package and then start working. Now here I have loaded a linear algebra package, which comes with many inbuilt functions. So I can declare a matrix. I can do that either by physically entering this matrix through the platelets, or here there is an option here to select a random matrix. So I can choose a random matrix. Even the data types can be selected, whether it should be integer, float, or a complex number. So we select a matrix. Then there are many linear algebra functions which are inbuilt under this linear algebra package of Maple, like characteristic polynomial. So you just have to type in characteristic polynomial of our matrix A, which we have defined, and the variable in which I need the polynomial. So here I have put X here. So I get the characteristic polynomial. Then when I teach Cayley-Hamilton theorem in the classroom, I usually take a bigger matrix, because these examples, they do it manually also. In the class also they verify. So I take a bigger matrix and take them to the lab and tell them to verify Cayley-Hamilton theorem for a bigger matrix also. So here I have verified it. So Cayley-Hamilton theorem is verified. So matrix A satisfies its characteristic polynomial. There are many other inbuilt functions like eigenvalues, eigenvectors, and so many functions are also available. Maple.
You'll have to wind up in a minute.
Yeah, yes, ma'am. Yes. So there are many more maplets and tools and packages available in this software, which can be used in class to make the teaching effective. There is also a mobile app provided by Maple known as Maple Companion, which has it's a free app, but it has a very limited features, not like the software. But that features can be used by students even at home. They can practice using Maple Companion at home also. So I think I can stop here. So that's all from my side. I think the time is up. So any questions, sir?
Thank you. Yes.
Thank you.
Anyone in the audience first would like to ask a question?
Yes.
Yeah, madam.
Go ahead.
Good evening, madam. Actually, I have a question.
Yes, sir.
Actually, madam, I want to know whether it is a paid software or it is a free software.
It's a paid software, sir. It's a paid.
Okay. And is it useful for secondary and middle school also?
Yes, it has lots and lots of inbuilt features, but it's a paid software. Our college has received a DBT grant from the government, and through that we had purchased the software. There are n number of inbuilt packages available in the software.
Okay, thank you, madam.
Only one question. Hello. Do you hear me?
Yes, sir. Please go ahead. Yes.
Yes. Bhakti, you have illustrated using Maple epsilon delta definition. Can you just show that?
Yes, just a minute. You want the maplet, sir?
Yes.
Just a minute. Let me share the screen.
For the continuity you showed, correct?
Limit, only the limit, sir.
Limits.
Just limit. Yes, here it is.
Yes. Can you have where the epsilon delta definition fails?
Epsilon delta definition fails here if we are not able to find such a delta.
And that's why, in which any case you have
yes. Let me change this value a little bit, and then we will identify.
Yes.
Let me adjust the parameters a little bit here and there. Sir, see here.
What?
So, sir, in this, so this delta is not enough, sir. The distance between x and delta. So whenever the C is X is very close to delta, then Fx will be very close to epsilon. So I have to reduce this delta value here. It is clearly seen here.
I see. Okay, okay.
Thank you, sir. Any questions, ma'am?
No, so it's interesting showing these ideas, and in fact, it's possible to do whatever you showed. Most of it's possible to do it in GeoGebra also. So that is open.
Yes, yes.
But then I guess it's to do with what tool you have access to and using it to the best of your.
Yes, sir. Yes, ma'am.
Yes. Thank you. That was nice.
Yeah, I think the only difference is probably students get used to Maple and probably they can use it later on for higher classes also.
Yes.
It could be one advantage. Otherwise, as Jonaki said, almost everything is available in GeoGebra.
Yes.
Where
but, Maple has very nice features, sir, but the time is limited. I could have demonstrated them. There are many.
It's okay. One can always go to the site of Maple and see freely available resources and things available. But the question is, see, in GeoGebra, the fun lies in making that applet.
Yes. Here also there is a Maple builder option, sir. We can create our own Maplets. Yes.
Yeah, you can create, but it's not. I don't know.
Not that trivial.
Long back.
It's not that easy.
Maple applet builder, I've used it long back. But
that's not easy.
See as you do it kind of a thing. You pick up something and add, pick up something and add, pick up something and add. It builds a builder. But in GeoGebra, it's more logical.
Yes.
What comes first, what comes next, whether this to be done, that to be done, what is independent.
I agree, sir, completely.
Yeah, so sure. But as a illustrating tool, I think it's good to you because you have that available.
Yes.
And you don't have to spend money yourself. Your college doesn't have to spend. So that is a great tool to have. Thank you.
Thank you, sir. Thank you.
Thank you very much. I think we've come to the end of this session.
So
very varied and nice presentations from all participants. There will be more presentations on Sunday.
Sunday, right. So thank you, Jonaki, and thank you, Santan, for today's sessions. It's taxing, I know that, to evaluate and look at the presentations. So thank you very much. So we conclude today's session. And tomorrow, please do join. We have interesting talks lined up by Professor Ramanujam and others. So look at the site and please do join. Thank you very much. Have a comfortable evening. It's a bit late. We had a long day. So take care and enjoy the evening, whatever left of it. Thank you very much.
Thank you. Thank you. Thank you, sir.